becoming a data-driven decision maker using one of the most powerful tools in business intelligence. In this course, you will learn how to turn raw data into interactive, visually appealing dashboards that help uncover insights and support smarter decisions. We will start with the fundamentals of Power BI, understanding the interface, loading data, and transforming it using Power Query. Then we will move on to the most advanced topics like data modeling, DAX formulas, and creating dynamic reports. You will also learn how to build stunning dashboards, not only look great but also provide real-time insights at a glance. These dashboards will allow you to slice, filter, and drag and drop into data with ease, whether you're tracking sales, performance, or any business metrics. But before we begin, please like, share, and subscribe. Remember to hit the bell icon to stay updated with the latest tech content from Edureka. Also check out Power BI certification course offered by Edureka in collaboration with PwC Academy, designed to equip you with comprehensive skills in business analytics. This program covers key concepts such as Power BI Desktop, data architecture, DAX, Power BI Service, mobile apps, data transformation, modeling, reporting, and natural language Q&A, all through real-time industry applications. Delivered through live instructor-led sessions. This course provides extensive hands-on training using practical and real-time projects. Learn from seasoned professionals with 10+ years of industry experience and prepare effectively for the PL 300 certification exam. Check out the course link in the description box below.
Now, before we dive into the topic, I have added a screenshot of the dashboard that we will be creating from the scratch in this tutorial. So stay tuned to learn how to create an interactive dashboard. So let's see the Power BI use case, that is the Airbnb, having the market analysis and real estate sales data. If you're planning a trip and looking for a unique place to stay, the first thing that comes to mind is finding a place that provides more than just a place to sleep. Naturally, you'll turn your phone and search for a homestay platform, and Airbnb will be among the top results. Airbnb, an American company, operates an online marketplace that connects travelers with short and long-term stays in homes, apartment, and hotel rooms across multiple countries and regions. Now, what if I told you that this company faces many challenges in market analysis and real estate sales data? Let's see the previous tools the team was using before adapting to Power BI were, firstly, limited collaboration and real-time updates, where Excel, despite being a primary tool for data analysis and reporting, it often left frustrated. Next comes lack of advanced data modeling. It struggled to handle large data sets efficiently, needing more advanced data visualization capabilities and required manual integration of multiple data sources. Moving on to minimal visualization capabilities, where this made the reporting process time-consuming and led to a sense of urgency for a more effective solution. Excel didn't provide the advanced data modeling or interactive dashboard features needed for complex analysis. Managing multiple data sets and creating unified reports was difficult. The limitations of these tools, particularly in handling large data volumes, were performing real-time analysis and generating interactive visualizations, led the team to transition to Power BI. Now, let's see why did they choose Power BI and how did they overcome the challenges. Power BI's data integration and visualization capabilities made it ideal for managing complex data sets in the real estate and Airbnb industries. Data modeling enabled seamless connections between tables such as market analysis and sales properties via unified identifiers, whereas Power Query ensured clean, unified data. Stakeholders could use interactive dashboards and advanced visualization to explore key metrics such as revenue and occupancy in real time, using filters for zip codes and property types. Automated data refreshes and centralized access to multiple sources improved workflows by eliminating manual updates and allowing for faster data-driven decisions. Now, let us see how did they implement the solution. The Power BI dashboard provided a clear, easy-to-use solution by offering the following. Firstly, customizable dashboards. Users can easily explore key data such as rental performance, sales figures, and location details through interactive visuals like charts, graphs, and maps. This made it simpler for stakeholders to make smarter decisions about optimizing property listings, setting the right prices, and also identifying potential investment opportunities. Next comes the predictive analytics. The dashboard's built-in forecasting helped users predict future trends like occupancy rates and revenue. This allowed them to stay ahead of market and make well-informed choices about where and when to invest. Last comes the geospatial analysis. By mapping out the property locations and analyzing demand in different regions, the dashboard gave users a clear view of which area were best for investment or adjusting prices, helping them make decisions based on the geographic insights. Now, let's see the conclusion for this use case. Excel is great for small, simple analysis, but it has limitations when it comes to handling large or complex datasets. It lacks scalability, advanced data visualization options, and automated workflows, which can make managing bigger projects difficult. Power BI, on the other hand, excels in these areas. It can handle vast amounts of data, offer real-time interaction with visuals, and integrate seamlessly with various data sources. For large-scale tasks like analyzing the Airbnb market, Power BI's advanced tools, flexibility, and ability to model and visualize data make it much better choice than Excel. Have you all ever imagined why should one choose Power BI? Power BI provides industries with real-time data visualization and interactive dashboards, allowing for faster and more informed decision-making at all organization levels. Its scalability and low pricing make it accessible to businesses of all sizes. It provides robust analytics and reporting capabilities without the high costs associated with traditional BI solutions. Power BI integrates seamlessly with existing systems and promotes collaboration through shared dashboards and reports. It streamlines workflows and ensures consistent, up-to-date data across teams. Now let's learn what is Power BI. Microsoft created Power BI, or Power Business Intelligence, a platform for data visualization and business intelligence. Its primary goal is to assist users in gathering, analyzing, and visualizing data to access the effectiveness of marketing activities and make decisions about the next steps. This tool allows you to upload raw data from a variety of sources, including CSV files, spreadsheets, databases, cloud services, and apps, and also transform it to interactive reports and dashboards. These reports present data in an understandable format, allowing businesses to deal with complex information. Have you all thought, how does Power BI work? Power BI works by enabling users to connect, visualize, and analyze data from various sources in an interactive and user-friendly way. Here's how it operates in 3 key steps. First, data connection and integration. Power BI connects through various data sources like SQL Server, Excel, and cloud services. It allows users to import and connect directly and uses Power Query to automatically integrate and transform the data through ETL, that is, extract, transform, load processes. Next comes the data modeling and visualization. Power BI allows users to create relationships between datasets, build calculations with DAX, and create interactive visualizations like charts, graphs, and maps. Users can customize visuals, drag and drop fields, apply filters, and drill down for deeper analysis. Last comes the sharing and collaboration. Power BI enables the sharing of reports and dashboards via the Power BI service or report server. Users can publish, set permissions, and collaborate with reports accessible across devices like smartphones and tablets for seamless teamwork and decision-making. Now let's see the key components of Power BI. The first key component is the Power Query. Power Query is an important component of Power BI. This can be added to your Excel spreadsheet or used as a component of Power BI desktop. You can use Power Query to delete data from multiple data sources and extract data from a variety of databases, including Oracle, SQL Server, MySQL, and others. Next comes the Power Pivot. Power Pivot is a data modeling and calculation tool. It is used to model both simple and complex data. Power Pivot allows you to set or create relationships between tables and calculate values that can be displayed in pivot tables. It gives you a large area to create your design. The next component is the Power View. Power View is the core data visualization component in Power BI. It is an interactive component that connects to data sources and gathers metadata for further analysis. The Power View lists contain a large number of blueprints for visualizations. PowerView allows you to filter data for individual visualization components or the entire report. Moving on to the next component, that is the Power Map. Power Map is used to display geospatial data in 3D. When the visualization is rendered in 3D mode, it adds another dimension to it. In Power Map, you can define one attribute as the length of the column in 3D and enable as a heat map view. The data can be highlighted according to the geographical location. Geographical locations include a country, state, city, or street address. Next comes the Power BI Desktop. Power BI Desktop is a new component of the Power BI package. It is a complete creation tool for Power Query, Power Pivot, and Power View. It allows you to create advanced queries, models, and reports. With Power BI Desktop, you can easily advance your BI skills and data analytics knowledge. The next component that I'll be telling is Power Q&A. Power BI Q&A is a standard language motor for your data models, question and answers. After assembling and updating your data model on the Power BI website, you or your users can ask questions and receive answers to those questions. There are some shortcuts and hints to help you build your model so that it can answer questions as effectively as possible. Power Q&A integrates with Power View to allow users to ask questions about data visualizations such as number of customers by state and receive answers in the form of map view with numbers represented as bubbles by the Power Q&A. The last component is the Power BI mobile apps. Power BI mobile apps offers 3 mobile operating systems: Android, iOS, and Windows. These applications give an interactive view of reports and dashboards from the Power BI website. You can even share them through your mobile apps. A portion of the reports can be highlighted and a note can be written about it and shared with others. Now let's see how to install Power BI. So moving on to the search bar, let's go to Microsoft Store to install the Power BI. In the search bar, type Power BI Desktop. So you can see the Power BI Desktop app here. So just click on Get. So it takes time to load. Okay, so now as you can see, the Power BI Desktop is installed. So you can click on the button Open. So once you click Open, you can see this on the screen. So towards the left hand side, you can see a blank report. Click on the blank report. So this is how the home screen of your Power BI Desktop looks like. So here you can create your innovative dashboards. So now I will be teaching you all how to import the data in Power BI. So the first step for importing the data in Power BI is, so on the home screen, you can see on your left hand side the Get Data function. So in the Get Data function, you have many common data sources where you can source multiple data from. So it can be from Excel workbook, Power BI semantic models, data flows, data wars, or so many. So we'll be using the data CSV file. So the next step is connect to the data source. So once you're clicking to the data source, you can see, for example, I'll be taking the text and CSV. So once you clicked on it, you can move to the page called the Navigator. So as you can see on the screen, it'll take you to the page Navigator. Then select the fields from the Navigator and load the data. That will be your fourth step. So now we have already seen how to import the data in Power BI. Now let's see the different views in Power BI. So the first view is the report view. The report view allows you to create any number of report pages with visualizations. It also allows you to move visualization around, copy, paste, merge, and so on. The next view is the table view. Table view in Power BI displays data in rows and columns, allowing sorting, filtering, conditional formatting, and detailed analysis. It is also used for reviewing raw data alongside visualizations. Here comes the next view, that is the model view. The model view shows all the tables, columns, and relationships in your model. It is also applicable when your model has complex relationships between many tables. The next view is the DAX view. The DAX view in Power BI is a query language used for custom calculations. It creates measures, calculated columns, and supports time-based functions, allowing dynamic data analysis and transformations. Now, as you are familiar with different views in Power BI, now let's see the query editor in Power BI, which allows you to edit any data in Power BI. And the query editor is also known as the transform data, which is a powerful tool for shaping and transforming data. With Power Query Editor, you can make changes in your data, such as changing a data type, removing columns, or even combining data from multiple sources. Now let's see the types in transform pane, which comes under the Power Query Editor. So the first transform pane is the table. It is a data structure with rows and columns for storing and managing data. You can filter and sort tables to prepare data for analysis. Next comes any column, which is a column type in the transform pane, allows for data of any type, providing flexibility for mixed data formats. Next is the text column, which is used to store and manage data consisting of strings such as names, descriptions, or any other alphanumeric data. Next comes the number column, which stores and manages numerical data such as integers and decimals. Then is the date-time column, which stores both date and time information. This column type allows for detailed time-based data management. Last is the script column. It is custom code for advanced data tasks. Now let's see how to create a visual in Power BI. So this screenshot is an example of how I have created a graph using the Power BI. So in the right hand side, you can see a visualization column where you can choose any graph you want to. So in the visualization column, you can see the x-axis and the y-axis for the range for the graph. So this data is taken from the get data, which you can see again in the right hand side. This is how you create the visuals in Power BI. So I'll be teaching you all how to share reports in Power BI. So in the home screen towards your right hand side, you can see an option called Publish. So this Publish is used to share the report to Power BI service only for the licensed users. Next comes a Copilot option. So again towards the right hand side of your home screen, you can see a Copilot option. Copilot in Power BI uses AI for report creation, insights, visualizations, and DAX queries. Now let's learn how to create dashboard of Airbnb in Power BI. And I'm using the data from an open source where you can get the data set, and I will also add the link in the description box as well. Now, go to Get Data on your home screen, which is on the left hand side, then click Text CSV file. I have chose the text CSV file because my data set consists of text and CSV file. Then, all the data will be visible on the screen. By default, it will be shown based on the first 200 rows. But make sure you click on the entire data set. Then wait until the data is loaded. Then click on Load. Then your data will be loaded. I'm using 3 files here, which consist of data, as the first file is already loaded, which you can see on the right hand side below the data. Now, let me get the other 2 files also. Now you can see all 3 files are loaded and they are visible under the data option in the right hand side of the screen. Now let me go to the table view. You can see the columns under each file. In the first file, we have name, host ID, host name, and so on. And in the second file, we have month, zip code, city, and so on. And in the third file, we have URL, price, home type, broker name, and so on. So, I will be giving the dataset links in the description box below. So, I will teach you how to edit data in Power Query Editor. So, as you click on Transform Data, then you can see we have come to a different window, which is a Power Query Editor. So, in this, you can choose Remove, Keep, or even split the column. We can do this under Transform Data. And I will show you an example in the name column. So under name column, right click on it. We can see many options like remove, duplicate, and also we can see the change type. So in the change type, under it we have many types like decimal number, fixed decimal number, and so on. So you can change them accordingly to your preferences. Now I will duplicate this column and show you. So just click on duplicate, and here the column is duplicated as name copy, which is seen in the green color. You can also click on the red crossed mark on the right hand side under Apply Step to delete the column which is duplicated. This is how transform data is actually used. Okay, now let's get started by creating a dashboard. First, let me choose a graph type. So I have chosen a graph type, that is the bar chart. Under Visualizations, I will add the value in the y-axis Drag the last review from the data and drop it in the place of y-axis in the visualization column. And below that we have 4 options, that is year, quarter, month and day. But I need the graph in month. So let's only add month. And again in the x-axis, let's drag the last review from the data column and drop it in the x-axis. So we have got a graph on the review value based on the count of each month that is seen on the screen. So let's edit this graph. I will go to format your visual. So below that we can see many options like x-axis and y-axis and so on. So I'll click on the y-axis. Below that I have a column called as values. So under that you can see the color. I will change the color into white so that my y-axis is also changed into white. So for same as for the x-axis, below that we have different values so that I will change the color into white in the x-axis too. Now as you can see, my values are not much visible because of the color white, and even my panel is also white. So that I will add a background for the panel now. We should go to format your report page to change the background color. Under that we have canvas background. Click on that. We can find an option called as color. So we can choose the preferable color you want to for the panel actually. Or there is an option here as browse. Click on that and I have downloaded an image. So you can also download any image you want to. I will click on the image and open. Now decrease the transparency percentage. So you can see the background color is changed. Now let me change the background color of the graph. For that, click on graph. Go to format visuals. Below that we have 2 options, that is visual and general. Then go to general. Then go to option called as FX. Click on that. Then we can see the background color. Choose a color that you want to. You can choose any color which you want like blue or orange. But I want the background color to be synced with the panel color. So I will just click on white and even increase the transparency. So as you can see that my background color of the chart is changing. I will again increase the transparency to 99% so that it will pair with my panel background color. So now we will add the border for my chart. So we can see an option called as visual border. Click on that. Make sure you on it. You can see that the different color options are there. Choose any color that you need. But I will choose white. Then I will increase the border corner to 9 pixel and also the width to 2 pixel. Now you can see the graph is much visible than before when I give a proper border to it. Again go to visuals and click on y-axis. So below y-axis there is an option called title. I'll off the title because I don't want my months to be displayed on my x-axis also. So I'll remove the title. Same way we will also do it in the y-axis. Go down, you have a title. Here just off the title. So the title will not be visible. Then go to general. In general, you have an option called as title. Click on that. You can see the title name as count of last review by month. I want to change the title to review by month. So let's change the title to review by month. In this, you can also change your text color. I'll choose my color to white. I will align it in the center and then give bold. So as you can see in the graph, I have grid lines. So to remove this, I will go to visuals, go to grid lines. I will off the grid lines so that I will not be having any grid lines on my graph. So now my review by month graph is created. Let's align the graph. So in case you want to duplicate this graph, you can just do Ctrl+C and Ctrl+V, just copy and paste it. This is just for you all to know it. I am not going to duplicate any of my graph. It's not necessary for me anyways. So let's remove it. Now let's create a new graph. So now to create another chart, let's go to visualizations. In that, let's choose a chart as column chart. Click on it. So you can see a column chart is displayed on the screen. So now for the values, for the x-axis, let's drag it from the data, that is the neighborhood. And then for the y-axis, let's take the name from the data and then drag and drop it in the y-axis. So as you can see, the graph is created. So as you can see in my graph, there's a lot of neighborhood values here. So I want to lessen down the neighborhood values. So for that, I need to add filters. So go to filters in the right hand side. Then you can see neighborhood is. So click on neighborhood, filter type. In that you can see the last one, the top n. Click on top n. N considers that number of values you want to add. So for that, I'll be giving as 5. So then by values, you should take it from your data, drag it and drop it. So it will be showing as first neighborhood. So that means it will take your first 5 neighborhood values. So then apply filter. So as you can see that my graph is illustrating first 5 neighborhood values. So now I need to change the background color of my neighborhood chart. So for that, I'll be going to my previous chart, that is the review by month chart. Choose the background color of it. Go to Format Painter in the left hand side of the home. Then click on the neighborhood chart. So you can see that both charts have the same color. So now I need to change the column color as well. So let's go to Visuals. In that, columns. So let the categories be all, because I need to change all the column colors, not only individual or each. So for that, go to colors, choose any color you want to. I'll be choosing pink. So you can see that the column colors have been changed. So now even let me change the title name. So for that, let me go to General again under Visualizations, then go to Title. In the text, change the title name. So I'll be giving the title as Total Booking by Neighborhood. So I've changed the title name as well. So now we have finished the total booking by neighbor graph. Let's align the graph. Okay. So once it's aligned, let's move to the new graph by taking the chart from Visualizations, that is the area chart. So by choosing area chart, we need to obviously add the values. So let's take the values for the x-axis from data. That is the broker name in the x-axis. Moving down, you can see the broker name. So in the y-axis, let's take count of country. Okay, so now you can see that the chart is created. So as you can see, the chart is created and the chart depicts about the brokers in each country. Now let's change the background color and make it into the previous color itself. I'm choosing the previous color of the graph. Then go to Format Painter. Then select it in the brokers in each country graph. Click on it. So you can see that my new chart is also has the same color of the previous chart. So now I want to change the color of the area chart. So to change the color, we will go to Visuals and you can see lines under it. And in lines, we have color. So in the color, you can choose any preferable color you want to. So I'll be choosing a color which I want. And you can see that my area chart color is changed. Next, let's change the title name. So for the title name, same as before, let's go to General, Title. I'll change the title name into Brokers in Each Country. So let's type Brokers in Each Country. So we can see that our title name is changed into Brokers in Each Country. Now you know how to create an area chart. So we've aligned it as well. So let's create a next graph, that is the home type. So for home type, I'll be taking the pie chart. So let's add the values for it. So in this, instead of writing X and Y values, we have legend and values. So in legend, I'll be choosing the SGAPT. So let me tell you guys what is SGAPT. So for that, let's go to table view. That's in your left hand side. So let's search for the SGAPT value in the table view. So for that, let's scroll down and search for SGAPT. Okay, here is SGAPT. So clicking on that, you can see that the column of SGAPT is seen. So all the values in this consist of that whichever houses have been sold and even which houses have been under construction as well. So I hope you have known what is SGAPT. So now moving on to values, let's drag from data. That is the count of home type. So home type will be the values. Okay, so as you can see that the pie chart is created by our values. Now let's change the background. So let's keep it as a previous graph itself. So let's go to Format Painter, selecting from a previous graph, then click onto our pie chart. So you can see that Our pie chart background is also changed. So now let's change the title. So for that, let's go to General, go to Title, change the title name. So let's change the title into Home Type. So as you can see, our graph is named as Home Type now. So as you know, the graph is created, but the values in this is not visible. So for that, let's go to Visuals, Slices, and let's change the color of the graph. You can choose any color you want to. Then let's change the value to percentage. Going to Detail Labels. As you can see that my value first is data value and percentage. I don't want the data value. It should only be in percentage. So I'm clicking on category and percentage off. Then changing the color of the percentage as well. So now you can see that my color of the percentage is also changed and even the graph color. So you can see that in the home type, there are some, in right hand side of the home type graph, there is some values. So I don't want those values to be on my graph. So to off that, let's go to Legend and Visuals and off. So now you can see that those values are disappeared. So as we have aligned the home type graph, let's create another graph that is by clustered bar chart. So let's add the values as well. So on the y-axis, let's add the host name by dragging from the data. Same way for the x-axis. So let's drag the sum of host ID from data and drop it in the x-axis. Now let's change the background color, taking from the previous chart, format painter, and then click it onto your new chart. So you can see that the background has changed. Let's align it. So now let's change the color of the bars. For that, go to Visuals, under bars, change the color. So I'll be choosing yellow. Now let's also change the title. Go to General, Title. Let's give as host name by host ID. So let me show you how to even add filters. So let's go to Filters, Host Name. So basic filters. Let's give top n. So n considers as the number of values, how much ever you want to. So I'll be giving 6. So let's drag the host name from the data. So it will be showing the first 6 values. So let's apply the filters. So you can see that my bar consists of first 6 values of the host name. Now let's align these graphs. So as we can see that the graphs have been aligned, let's create another graph. So in visualizations, let's select table. So under table, let's see the values. So we only have one value, that is columns. So let's not choose this graph. So let's consider matrix as a graph now. So let's also see the values for it. So we have rows, columns, and also values. So anytime you choose any graph, there should be more than one value. So for rows, let's select the broker name, drag it from the data column. So for the columns, let's take the value of status text from the data column. And then for the values, let's take the sum of price from the data column. So as you can see, our graph is created. So now to change the style of the graph, let's go to Visual, go to Layout and Style Presence. So under Style, it is in default. So let's choose None. So we have many other styles like bold header, minimal, and so on. So you can choose whichever preferable style you want to. So I'll be choosing None as a style. So you can see that the background is fully in white. Now let's change the color of the value. So moving to values, the text color. So let's change the text color into white and also the alternative text color into white. So now you can see that the text is not visible. So we need to obviously change the background color now. So go to General, FX. So let's push the transparency into 89%. So you can see that the text is visible now. So as you can see in the graph, we can't see the color of the headers in the column and in the row as well. So let's change the color so that it's visible. So for that, let's go to Visual, go to column headers and change the color of the text. And I'll change it into white. Same as, let's go to row headers change the color of the text to white. So you can see that the text is visible. Now, let's also change the color of the text in the column total. So in the search bar, let's type text color. Scroll down. Make sure that you're changing in the column grand total and in the row grand total. So let's change the text color to white in the column grand total and in the row grand total as well. So you can see that all the values are visible. Now also let's change the font size of the row and the column headers. So let's go to column headers and change the font of the text. Same as in the row header. So in the row header, let's go to font and change the text. So as you can see that the changes have been seen in the graph. So as our matrix graph is created by giving the broker name and how many houses have been for sale and how many houses are under construction and the total as well. So now let's align all the graphs. So we have aligned all the other graphs. Now let's create a new graph by adding a slicer chart. Okay, by clicking on slicer, we have the values in field. So there's only one value. So let's choose it from the data column, that is neighborhood group. So I want my graph to be in drop-down position. That is, the style of the graph should be in drop-down position. So for that, I will go to Visual, Slicer Settings, then choose the drop-down option. So as you can see that my graph is in the drop-down style now. So let's also change the background of the graph. For that, as previously done, choose any of the background from any of the graph which you have previously done. Format Painter, click on the present graph. So you can see that the background is already changed. Now, you can also see that the text is not visible. So we have to change the color of the text. So for that, let's go to Slice Header in Visual. Change the font color. So let me make it into white. So now my graph text is visible. So by clicking on the drop down, you can choose any values you want to. That is why we have choose the style as drop down. So now to create another graph, I will be just copying and pasting the same graph. So let's copy and paste. So just that I'll be needing to change the value of the graph. So in place of neighborhood group, I'll be changing it to room type. So another graph is also created. That is how you duplicate from another graph. So now let's align this graph properly. As we've aligned all the other graphs, let's create a new graph by adding the card chart. So we have the value of fields. So let's add the value from the data column. That is the room listing. So the value of field is added as room listing. So now let's change the background of the graph as previously done by Format Painter. Click on it and you can see that the background is changed. So now let's change the color of the text. Go to Visuals, call out value, change the color. So let's make it into white. So text color is also changed. Now go to Generals, Title. Let's on the title so that we can change the title. Now let's give the title for it as room listing. Row listing. So now the graph is created. Let's align the graph. Finally, we have created the dashboard. Now to make it visually appealing, I will add the logo to it. So I will show you how to insert the logo. Go to Insert, move to Images, select the image that you have downloaded, open, align the logo accordingly. As we have taken the data set of A, B and B, we are adding this logo. Finally, let's give the name for the dashboard. So, for giving the name, let's choose the text box, write the text into it. I will be naming it as Airbnb Data Dashboard. Let's also increase the font and make it bold. Let's align it to center, then align the text box as well. So now let's change the text color and also the background color by using the Format Painter. Now the text box is created. I hope you understood how to create an interactive dashboard in Power BI Desktop from scratch. what is Power BI Desktop? Power BI Desktop is a free application for your local computer that allows you to connect to, transform, and visualize data. It enables you to connect to multiple data sources and combine them into a data model. This data model allows you to create visuals and collections of visuals that can be shared as reports with others within your organization. Most users who work on business intelligence projects develop reports in Power BI Desktop and then share them with others through the Power BI service. Have you all ever imagined why is Power BI Desktop used? Power BI Desktop simplifies the process of connecting, transforming, and visualizing data for better decision making. It allows users to pull data from multiple sources, databases, cloud services, Excel, and more, and then clean, combine, and model that data within a single environment. Power BI's desktop drag and drop interface enables users to create interactive reports and dashboards without requiring deep technical skills, making it ideal for both data analysts and business users. Now let's learn how to install Power BI in our desktop. And now this is the home screen of the Power BI desktop. In the Home tab, we have Get Data. Under Get Data, we have Common Data Sources, where we can source a file in Excel workbook or in Power BI semantic models, or it can be text or CSV file too. We have Transform Data, that is also known as the Query Editor. Power Query Editor is a powerful tool for shaping and transforming data. With Power Query Editor, you can make changes to your data, such as changing a data type, removing columns, or combining data from multiple sources. So under Insert, we have New Visuals, Text Box, and More Visuals. New Visuals is nothing but you can create or add any visuals that is needed. Text Box is that you can add any of the text that is needed in the report. Now, on the left-hand side of the Power BI desktop screen, you can see a report view. Report view is that which allows you to create any number of report pages with visualizations. You can move visualizations around, copy and paste, and even merge and so on. Next is a table view. The table view in Power BI displays data in rows and columns, allowing sorting, filtering, conditional formatting, and detailed analysis too. Next comes the model view. Model view is that which shows all the tables, columns, and relationships in your model. It is applicable when your model has complex relationships between many tables. The DAX query view in the Power BI is a query language used for custom calculations. It creates measures, calculated columns, and supports time-based functions, allowing dynamic data analysis and transformation. Now I will teach you how to source a data. Go to Get Data. Under Common Data Sources, we have Text and CSV. I'm selecting Text and CSV because my file format is in Text and CSV. So here under Downloads, so I have two files, that is Sales and the other one is Details. Let's select it one by one. So I'm clicking on Sales and opening the file. So here we have Load and Transform Data. As mentioned before, Transform Data is nothing but you can edit the data as well. I will be showing you how to transform data in this video further. So now let's load the data by clicking Load option. Now let's source the other file as well. That is the Details. Similarly, click on Load. Now to check whether our files have been loaded or no, towards the right hand side of the screen we have Data. Under that we can see the files that we have extracted. Now to check the data in each file, click on Table View. Here, clicking on Details, you can see the details consist of many columns like Order ID, Amount, Profit, and so on. And even we have the data under it. Similarly, in Sales, we have columns like ID, Age, Sales Made, and so on. And even the data are provided under it. Now let's see how to transform the data. Click on Transform Data. Transform Data. So it will take you to the Power Query Editor. Now in Power Query Editor, you can enter data, choose columns, remove columns, keep rows, and even remove rows. This is similar as the Excel, but in Excel you can only extract minimum number of datas. But in Power BI, you can extract huge number of datas. Now, right click on the ID column. We can see many options like remove column, duplicate column. We can also see the change type. Change type means the values type. So my values are in whole numbers. You can also change the values to decimal numbers, fixed decimal numbers, percentage, date, and so on. To duplicate a column, right click on the ID column and select duplicate column. You'll notice that the duplicated column appears on the screen and is automatically named as ID copy to reflect the duplication. On the right-hand side in the Applied Steps pane, you can track the actions taken. To remove the duplicated column, simply click on the small X next to the corresponding step. After clicking, the duplicated column is removed and deleted from the data. Now let's see how to add a new column. First go to Add Column tab. Now let's select the data from the Details file and select the Custom column under the Add Column tab. There is a box for the new column's name. By default, a name is provided as Custom, but you can change it to something you prefer. Let's call it Result. Next, we need to create a formula. In this case, we'll multiply amount by quantity. Once the formula is entered, click on OK. After clicking, you will see the result column added, displaying the values from multiplying amount and quantity. Now, let's go to the Home tab. In Home tab, we have Close and Apply. Under that, we have options like Close, which allows you to close the Power Query editor, and Apply, which allows you to apply the changes in the data. Now, by clicking on Close and Apply option, it will apply the changes that we have made and even close the Power Query editor. Now, I hope you have understood how transform data works. Now, let's move ahead and create visuals. Before creating the visual, let's choose text box to give the name for the report. So here I'll be giving it as Sales Dashboard. Let's change the font size and let's give the font size as 20 and make it bold and let's align it. Now that our title is created, let's choose a graph that is stacked column chart. Let's just align the graph. Now let's give the values for the graph. So for the x-axis, I'll be taking the result by dragging and dropping it from the data. And for the y-axis, let's give the subcategory as the y-axis value from the data. Now let's align the graph. Now let's change the color of the report. For that, go to Format Your Report page. Under that, we have Canvas background. Go to Colors. Choose the preferable color. But I have downloaded an image, the color which I needed. So browse. You can increase or decrease the transparency, but I'll be decreasing the transparency to make my background very darker. So I'll be making it into 9%. So here you can see that the color of the report is seen. Now let's make the changes for the chart. For that, go to Visual. In x-axis, we have values and color. So let's change the color of the values of the x-axis to white. Similarly, in y-axis, we have values. In colors, let's change the color of the y-axis values to white. As the color of the values are not visible, let's change the background color of the chart as well. For that, go to General. Under General, we have FX. In FX, we have background. So let's increase the transparency so that it pairs with the background color of the report. So here you can see that our values are visible. Now let's remove the text from the x-axis and y-axis by keeping only the values. For that, we need to go to Visual. Under x-axis, we have title, so let's off the title. So here you can see that the text of the x-axis is invisible or it is removed. Similarly, under y-axis, let's off the title. Now even the y-axis title is removed. As my title for the graph is given as count of subcategory by result, let's rename the title as well. For that, go to General. Under Title, let's change the text of the title to subcategory by result. Let's also change the color of the text to white. Let's make it bold and let's align the text to center. Now you can see that the graph is created perfectly. Let's just align the graph. As you can see that the grid lines are visible in the graph, let's remove that as well. For that, go to Visuals. Under Grid Lines, let's off the grid line. So now you can see that the grid lines have been removed. Now let's add the border for our chart. For that, go to General. Under General, we have FX. In FX, we have Visual Borders. Let's on the Visual Borders and give the color for the border. You can give it according to your preference as well. I'll be giving it as white and increasing the rounded corners to 9 pixels. And let's increase the width as well. I'll be giving it to 2 pixels. So now you can see that the border is created. Now let's create another graph. For that, Let's take the clustered bar chart and let's add values to it. So for the y-axis, I'll be adding the category value by dragging and dropping it from this data. And for the x-axis, I'll be taking the value profit. As you can see that a graph is created. Now, remember that you do not need to make changes for each chart. Just click on the previous chart, click on Format Painter option and just apply to the chart which you need to change. Now you can see that the sum of profit by category chart is created. Now I will show you how to change the color of the bars. For that, go to Visuals, go to Bars. Under that we have Colors. I'll be changing the color to pink. So now you can see that the color is applied. This is how you change the color for the bars. Now you can see that a graph is created. Now let's create another graph by selecting the pie chart. Let's give values for the pie chart. For the legend, let's give payment mode. And for the values, let's give profit. So as you can see that a graph is created. Similarly, let's give the changes for the graph by clicking on the Format Painter and selecting the pie chart. So now you can see that our graph is created and the background color and all the changes have been done. Now as you can see that our values are not visible, let's change the color of the values. For that, go to Visual. Under Visual, we have Detail Label. In Detail Label, we can see values. Let's change the color for the values. So I'll be giving it in white. Now let's also change the label content for the values. So moving to Options. My label content is in data and percentage. So let's only give it in percentage. So I'll be selecting category of percentage. So now you can see that my values have been changed to percentage. So there are some values on the right hand side of the graph. So I'll just remove all of those. For that, let's go to Legend. Under Visual, let's off the legend. So here you can see that those values have been removed. In case you need to change the color of the pie chart, you can go to Slices. Under Colors, you can change or you can add any preferable color you need to for your pie chart. So I'll be not doing any changes because I do not need any changes in my pie chart. As my color of the title is also not changed, let's change the color of the title by clicking on the previous graph and giving the option as Format Painter. So here you can see that my title's background color is also changed. Let's also change the font color. So I'll be giving it as in white. So now that my title is visible, let's align it. So I hope you have understood how to create visuals in Power BI Desktop. So after the dashboard is created, let's make sure that a dashboard is saved. For that, go to File, click on Save and give the file name. So I'll be giving here it as Sales Dashboard and click on Save. So now my dashboard is saved. I also want to share and collaborate with my colleagues on this. So I need to publish this report up to the Power Service. So let's click on Publish. Here it will ask you for the email address. So if you're privately doing it, you can give your private address, or if you're working professionally, you can give your office email address as well. So after you give the email ID, click on Publish. And here I choose the workspace destination as workspace and publish it. And when I open my report in the Power BI service, in the Power BI service home screen, I can see my sales dashboard visible here. Click on it. So here you can see my sales dashboard. I can also see what my report readers will see and also can interact with my report. Power BI Desktop is a powerful tool for businesses. It offers an easy way to connect, analyze and visualize data. Its intuitive features allow users to create interactive reports and dashboards, enhancing decision-making across the organization. If you are eager to start your career in IT, but coding isn't your strength, don't worry, you can still break into the tech world without any coding skills. And one of the best fields for this is Microsoft Power BI. Hello everyone, welcome back to another interesting video on Power BI Roadmap by Edureka. Let's dive into the amazing opportunities to learn more about the Power BI Roadmap and to become a successful Power BI developer. Now, let me give you an example of Power BI use case. Imagine you're feeling hungry but too tired to cook. What's the first thing that comes to mind? Chances are you will grab your phone and open a food delivery app like Swiggy or Zomato. You're not alone. Many people do the same. Let's focus on Swiggy as our example. As India's leading hyperlocal food ordering and delivery platform, Swiggy handles millions of customer orders every month. But what if I told you that Swiggy also has several challenges in its company because of sales and foot traffic? The real twist is that Swiggy faced problems with data loading and infrastructure issues because of its BI tool, which was used to create dashboards that track sales and traffic around cities. The previous BI tool was complex and slow, with dashboard delays caused by data loading and infrastructure issues every time it refreshed. This data delay limited stakeholders' ability to gain timely insights and make decisions. Swiggy grew with increased order volumes and app expansion across cities. But the BI platform struggled with accessibility, functionality, and security, resulting in an unstable environment. These challenges prompted Swiggy to look for more efficient and better BI solution to support its rapid growth. Now, as you have got a clear understanding of the challenges, let me tell you how did Swiggy find the right BI solution for this problem. Swiggy began transforming its BI platform in mid-2017 to provide critical insights for business execution. The internal BI team gathered detailed requirements from cross-functional teams to determine the best tool, with a focus on improved features, user experience, and advanced access control. After running proof-of-concept tests and stress testing various tools with 5x data volume increase, PowerBI was chosen as the best solution due to its dependability, scalability, and ability to support Swiggy's growing data-driven culture. Let us also see how did Swiggy started developing a strong data pipeline. The transition to PowerBI went smoothly. Swiggy's internal analytics team collaborated closely with BI experts to quickly migrate existing dashboards to minimal PowerBI dashboards. The new architecture allows analysts and authors to securely access data and create custom reports in PowerBI through workspaces. Swiggy's next step is to improve self-service reporting. Now, let's see how Swiggy sourced their data. Data is sourced from Snowflake, MySQL, Excel files, and PrestoDB using open database connectivity. PowerBI datasets use aggregated tables to create metrics and dimensions for visuals and reports. Now, with the help of PowerBI, Swiggy started effectively leveraging PowerBI's open platform tools to prevent problems and build better models the first time. Swiggy used DAX Studio to develop, execute, and analyze DAX queries. Then Vertipax Analyzer, which is used to enhance the data model. Also PowerBI Helper that helps to simplify day-to-day PowerBI scenarios. Data is imported and scheduled to refresh at specific intervals based on the report's requirements. Now, I will show you some of the dashboard used by Swiggy, which was created by the use of PowerBI. The real-time metrics dashboard was used to track the trends hourly for the day. The report allows users to view the amount of traffic per hour by city. The supply sales dashboard highlights order performance at the restaurant level by tracking 10 various indicators. The traffic and conversion dashboard provides report to the consumers with an overview of app user behavior and app adoption rates. Moving on to the conclusion for this use case. Swiggy's BI transformation has streamlined operations, providing key insights across verticals and improving efficiency. The single platform simplifies reporting, allowing users to focus on one tool instead of multiple reports. Swiggy's team can use PowerBI to track metrics in near real time, allowing for faster actions and better decisions. Swiggy grows and PowerBI scales with it, delivering value while lowering costs. The platform's time-saving features enables analysts to focus on more strategic tasks. Now that you know, PowerBI helps Swiggy to overcome these problems and bring out better solutions. Now we will take a look at popular PowerBI job profiles. The first job profile is PowerBI Developer. The role of a PowerBI developer is to design, develop, and deploy PowerBI reports and dashboards. This role involves data modeling, transforming raw data into meaningful insights, and creating interactive visualizations. The next job profile is a PowerBI Analyst. The role of a PowerBI Analyst is to analyze data and generate insights using PowerBI. It often requires working closely with business stakeholders to understand their needs and translate them into actionable reports. Next comes a PowerBI Architect. The role of a PowerBI Architect is that to focus on overall design and architecture of PowerBI solutions. It requires a deep understanding of data integration and best practices in BI implementations. Moving on to PowerBI Consultant. The role of a PowerBI Consultant is that they work with multiple clients to implement PowerBI solutions tailored to their specific needs. This may involve training clients, designing custom dashboards, and optimizing data workflows. Let's see the last job profile, that is Business Intelligence Manager. The role of a Business Intelligence Manager is that they oversee the BI team, including Power BI developers and analysts. This role is responsible for strategic planning, execution, and management of BI industries within an organization. Let us learn how to become a Power BI developer. Skills required for a Power BI developer are: first, data management and querying, skilled in SQL and query performance, skilled in connecting data sources, importing and transforming data for business intelligence using Power BI, advanced knowledge in making DAX queries in Power BI desktop. Second is the reporting and visualization, expertise in developing visual reports, KPI scorecards, and dashboards using Power BI desktop. Strong analytical thinking skills in translating data into informative reports and visuals. Proficiency in building analysis service reporting models. Third comes the security and application layer, capable of implementing row-level security on data, understanding of application security layer models within Power BI. Next comes the development and integration, design, develop, and implement custom applications using Power Apps, ensuring high performance, scalability, and usability. Experience in integrating Power Apps and Power BI with other systems and data sources such as SharePoint, Dynamics 365, and SQL Server. The last skill is attention to detail and organization. Well organized with a strong focus on accuracy and attention in detail in all tasks related to data visualization and BI solutions. These skills form the foundation of an effective Power BI developer, capable of handling end-to-end business intelligence and application development tasks. Here I have taken a popular company which is Deloitte, which is hiring for a Power BI developer. The skills that I have highlighted here, which I have already explained in the skills part. So, if you are interested, you can apply for this post through LinkedIn. Here are the salary ranges of a Power BI developer in India. And this can vary based on the factors such as experience, location, and industry. So, the average annual salary in the entry level is 6 lakhs per year, and in the mid level, it is 19 lakhs per year. Moving on to the senior level, it is 26 lakhs per year. The source is taken from Glassdoor. Let's see the average annual salary in US. For the entry level, it is $95,000 per year. And in the mid level, it is $98,000 per year. And in the senior level, it is $100,000 per year. And the source is taken from PayScale. Now, let's see how to become a Power BI analyst. And the skills required are: first, programming language. In programming language, we have primary skills and the secondary skills. The primary skills include SQL, Python, Power Query, PLX script, DataSite, Looker, Tableau, Power BI. And in the secondary skills, we have Java, HTML, CSS, C++, Angular, and BigQuery. The next skill is advanced SQL, expert in writing complex queries for data extraction and manipulation. Next comes the Python, expert in building data pipelines and conducting data analysis. Then, BI dashboard development, proficient in designing and developing dashboards using tools like Tableau, Looker, and Power BI. Data visualization and storytelling, skilled in creating effective visualizations and dashboards following best practices. Next comes the Excel and Google Sheets, power user with advanced capabilities. Lastly, the data engineering, experienced in data processing and building data pipelines. Here I have taken a popular company which is Concentrix, which is hiring for a Power BI analyst. The skills that I have highlighted here, which I have already explained in the skills part. So if you're interested, you can apply for this post through LinkedIn. Moving on to the certifications. Consider undertaking pertinent Power BI certifications to showcase your ability and commitment to your work. Microsoft Certified Power BI Data Analyst Associate to demonstrate methods and best practices for modeling, visualizing, and analyzing data that are in line with business and technical requirements. So, for the certification, the cost of the exam is $165 and the pattern consists of 40 to 60 multiple choice questions. And the duration for this exam is 100 minutes, followed by the passing criteria is 700. So, Microsoft Power BI certification training by PwC Academy, which is provided by Edureka, Power BI certification course by PwC offers dual certification in business intelligence. It covers concepts such as Power BI Desktop, DAX, Service, Reports, and more with real-time industry use cases. The course will prepare participants for the official PL 300 exam. Let's see the salary for a Power BI analyst that can vary based on the experience, location, and industry. So, the average annual salary in India for the Power BI analyst is, for the entry level, it is 8 lakhs per year. And for the mid level, it is 12 lakhs per year. Then for the senior level, it is 17 lakhs per year. And the source is taken from Glassdoor. Let's also see the average annual salary in US. For the entry level, it is $85,000 per year. And for the mid level, it is $87,000 per year. Then for the senior level, it is $175,000 per year. And the source is taken from PayScale. Now, let's also see how to become a Power BI architect. So the skills required are, first, Power BI and data integration, proficient in Power BI report development and expertise in migrating ClickView reports to Power BI, skilled in integrating Power BI and building efficient data models and importing data. Second comes the leadership and client management, experienced in leading teams for deployment activities and meeting project deliverables, strong client satisfaction awareness, ensuring that solutions meet or exceed customer expectations, capable of leading technology decisions, facilitating discussions, and articulating alternatives and direction to senior IT and business management. Last comes the project management. Strong project management skills ensuring the projects are delivered on time, within scope, and aligned with business goals. These skills highlight your ability to deliver complex Power BI solutions, lead teams, and manage projects effectively while maintaining strong client relationships. Here I have taken a popular company which is Tech Mahindra, which is hiring for a Power BI architect. The skills that I've highlighted here are, which I've explained in the skills part. So if you're interested, you can apply for this post through LinkedIn. Let's also see the salary for a Power BI architect, which can vary based on the experience, location, and industry. So the average annual salary in India for Power BI architect are, for the entry level, it is 9 lakhs per year. And for the mid level, it is 19 lakhs per year. Then for the senior level, it is 34 lakhs per year. And the source is taken from Glassdoor. Let's also see the average annual salary in US. For the entry level, it is $127,000 per year. And for the mid level, it is $155,000 per year. And for the senior level, it is $191,000 per year. And the source is taken from PayScale. So, I hope you have a clear understanding about how to become a Power BI developer, architect, and an analyst, and even the skills and the salary range. Now, let's move on to the future scope for Power BI. The future scope of Power BI and BI tools looks promising, with IDC predicting a 5-fold increase in opportunity for firms using effective BI by 2024. According to Statista, the BI market will reach $27.36 billion in 2024, growing at a CAGR of 5.71% to $34.16 billion by 2028. All businesses are becoming more data intensive and rely heavily on data analytics and visualization tools to provide real-time and actionable insights. Power BI will assist business owners in making data-driven decisions faster than ever before. Now let's also see the top companies hiring for Power BI professionals. Because of the growing demand for data-driven decision-making, several major corporations are actively seeking for Power BI developers. Some of these companies are Microsoft, Amazon, Google, Tech Mahindra, Deloitte, Concentrix, and more. Mastering Power BI requires a methodical approach and a hands-on experience. By following a systematic Power BI roadmap, you can become an expert Power BI user and provide valuable insights to businesses.
In the Power BI desktop, a data set is basically defined by a single query that specifies what data to include and how to transform that data. Power Query is a data connection technology that enables you to discover, connect, combine, and refine data to meet your analysis needs. It basically helps you take your raw data source and convert it into something more usable, more workable, on which you can build your analytics and then draw insights from it. The query is made up of related steps that build on each other to produce the final data set. And once you've defined that particular data set, you can use it to create visualizations that you add to your reports, which then you can publish to the Power BI service. Now, the heart of the query is the Power Query M formula language, which is based off of a language called F#. And just like it is a case-sensitive data mashup language which is available to many of the Microsoft softwares, such as the Power BI desktop, Power Query in Excel, as well as the get and transform import feature in the Excel versions post 2016. As with many languages, Power Query statements are made up of individual language elements such as functions, variables, expressions, as well as values, both primitive and structured, that together define the logic necessary to shape the data. Now, each query in the Power BI desktop is a single Power Query let expression. It basically contains all the code elements that are necessary to define your data set. A let expression is made up of a let statement and an in statement, as you can see in the syntax before you. So the let statement includes one or more procedural steps that define the query. Each of these steps is essentially a variable assignment that consists of a name as well as an expression that provides the variable's value. Pretty simple, that is what a variable is in most cases. It's fifth grade math, right? Variable is a name to which you assign a value. Now, this expression defines the logic for adding, removing, or transforming the data in a specific way. This is where you will be doing the bulk of your work, as you are going to see in the examples I'm going to give you later in this module. Now, the variable can be of any supported Power Query type. Each variable within a let expression must have a unique name, but again, the Power Query is fairly flexible about what you call it. Just make sure it makes sense and it's easy to remember for you. Now, you can include spaces in the name, but you have to enclose it within double quotes and precede it with a hashtag. Now, that is a somewhat cumbersome naming convention and one that I particularly prefer to avoid. It's honestly a mystery to me, even now, why it is the way it is, but let's just move on. Now, the variable names are also the same names that are used to identify steps in the applied steps section in the query editor's right pane. So I think it would be wise to use names that make sense. Now, strictly speaking, you do not have to define your procedural steps in the same physical order as the logical order. As in, for example, you can reference a variable in the first step of your procedure and then define it at the last step of your procedure. Now, this is something which is unlike the regular coding. However, this approach can make the code very difficult to debug, as well as cause unnecessary confusion amongst the coders. The accepted convention when writing a let statement is hence to keep the physical and logical orders in sync. Now, we spoke a lot about the let statement and none about the in statement. So a little input here. The in statement is basically like a return function. It returns a variable value that defines the dataset's final shape. Now, in most cases, if not all, this is most likely to be your last variable that you defined in your let statement. You can specify a different variable from the let statement, but there's usually very little reason to do so. So if you simply need to see a variable's value at any specific point in time, you can select its related step again in the applied steps section in the query editor. If you are not familiar with what it looks like, I'm going to show you in just a while once we open the demo machine. Now, when you select a step, you're essentially viewing the contents of the associated variable. With that, let's move on to our problem statement. Now, this session is going to include a number of examples that demonstrate how to define the procedural steps necessary to build a query. All of the examples are going to be based off of a data set, the link to which I will leave in the description box below. Now, the data set I'm going to use is the Titanic data set, which lists the passengers on the infamous Titanic voyage. It basically shows who survived it and who did not. Now, if you plan to try these examples for yourself, you need to create a titanic.csv file from the dataset that I'm going to link in the description box below and save it to a folder that you can access from the Power BI desktop. On my system, I saved it to a local folder in my C drive. Now, understand what we are trying to do here is to make this particular dataset a little more usable for you to lay analytics on top of. Yes? So now let's move on to Power BI and see how to do that. So the first step into building your own Power Query script is to add a blank query to the Power Query desktop. Now, to do that, what we're going to do is we have this Get Data button on the home ribbon in the main window. So I'm going to click on that. All right. Then I am going to navigate to the other section. And towards the very end, I'm going to find this option called a blank query. So I'm going to double click on this, or you can even click on connect. Now what it does is that it launches this query editor with a new query listed in the queries pane on the left. Now it's conveniently named query 1, or you might have a similarly numbered name with a different number depending on how many queries you've created. Now to rename this query, what we're going to do is we are going to right click and select rename and maybe give it a fitting name like survival log. Okay. And then we are going to press enter. As simple as that. On the right in properties, you see the name has changed, which earlier was query 1. Next, let's go to the view menu. It opens up this ribbon and then click on advanced editor. Then it opens the advanced editor. Now, as this editor opens, you can see that there is a new let expression here, which is already defined. The let statement includes a single procedural step in which the variable is named source and the expression is an empty string. As you can see, it is indicated by double quotes. Notice that the variable is also listed in the in statement, again, source. And if I move this advanced editor a little to the left, you can see that the variable is even listed as a step in the applied steps section. Now, this is the part I was talking about earlier when I talked about applied steps. Now, this is that section. Here you can see all the steps that have been applied to your query editor, and you can click on each step to see what that variable holds. Now, for this exercise, we'll be changing the variable name to get passengers. So the first procedural step that you'll add will retrieve the contents of the titanic.csv file and save them to get passengers variable. Now, to add the procedure, we are going to replace the current let expression with a different one. Notice that this get passengers variable is specified in the procedural step in the let statement as well as in the in statement. Now, in this way, the variable's value will be returned when the let statement runs. It's as simple as that, as I had earlier mentioned, that the in statement is basically like a return function. Now, this expression in the procedural step includes everything after the equal sign. The expression uses csv.document as a function to retrieve the file's contents as a table object. It supports several parameters, but only the first one is required to identify the source data. As a part of the first parameter, you must also use the file.contents function right here to return only the documents data. And here you can see the location of my dataset. As I had already mentioned, it is saved in my C drive in a local folder called data files, and my file name is titanic.csv. Now, the second parameter can be specified as a record that contains optional settings. So in Power Query, a record is basically a set of fields which is made up of name value pairs enclosed in brackets. Now, the record in this example includes a delimiter and encoding options for the values. Now, the delimiter option specifies a comma, as you can see right here, as the delimiter in the CSV document, and the encoding option specifies the text encoding type 1252, as you can see right here. This is basically the Windows Western European code page. Yes? And that's all there is to know and all there is to setting up a basic let expression in your Power Query. After you've entered your code, click on Done and close the advanced editor. And as you can see, that has run the procedural step, and the data set appears in the query editor, and it should look similar to what you can see right now. It's got a couple columns, it's got the survived, it's got names, it's got sex, age, passenger class, so on and so forth. Notice that the first step in the applied step section is now named get passengers, which is the same as your variable name. The procedural steps expression is also displayed in the small window above the data set right here. Now you can edit the code directly in this window if you want to. Whenever you add, modify, or delete a step, you should apply and save your changes. A simple way to do that is to click on this little save icon at the top left corner of the menu bar. When prompted, if I click on this, I will be prompted to apply my changes. And here I am going to click on apply. And with that, my query is saved. Moving on, another important thing is removing a column from the data set. Now, the next procedural step that you are going to add to your let statement basically will remove your duplicate column or column 6 from your data set. Now, because your data set is saved as a table object, you can choose from a variety of Power Query table functions to update the data. For this step, you'll use something known as remove columns function to filter out that specific column. So again, I'm going to click on the advanced editor and I'm going to get back to the query. Now basically to remove the column, I am going to add a comma, give a space, and on a new line, I'm going to define the next variable or expression pair. Now to remove the column, add a comma after the first procedural step, and then on a new line, define the next variable expression pair as you can see on your screens. The table.remove function requires two parameters. The first parameter specifies the target table that you will be updating, which in this case is the getPassengers variable from the previous step. Second argument specifies a single column or a list of columns to be removed. This example specifies only column 6 from getPassengers table. The important takeaway here is how the second step builds on the first one and then returns a new result, which is assigned to the remove calls variable. The new variable contains the same data set as getPassengers variable, just without the column 6 data. After you add this particular procedural step, replace the getPassengers variable in the in statement with remove calls variable and next click done to close the advanced editor. You can then save and apply your changes. Your data set now should look something like this with 5 columns only. As you can see, the remove call step has been added to the applied steps section as well. And column number 6 is no longer included in the data set. To add more procedural steps, we follow the same logic as here, continuing to build on our growing foundation. The next step is to promote the values of the first row of your data set to the header row. So these values become the column names. So to carry out this step, again, go to the advanced editor. Now to carry out this step, add a comma after last step that you defined, and then on a new line, you can put the expression in front of you. This expression uses the table.promote headers function to promote the first row of the column headers. The function's first parameter is required and specifies the table to use as the source data. This is just like you saw in the previous example, in which the new step builds on the previous step. The second parameter, promote all scalars, is optional but a good one to know about. By default, Power Query promotes only text and number values. When promote all scalars parameter is included and set to true, Power Query promotes all the scalar values in the first row to headers. The expression results are assigned to the promote names variable. Be sure to update the in statement with this variable name. Again, I'm going to click on done. And as you can see, our entirety of first row has turned into this header row right now. The rename columns function requires two parameters as usual. The first is the target table, which is the promote names variable from the previous step, and the second is a list of old and new column names. This is a list of an ordered sequence of values separated by commas and enclosed in curly brackets, as you can see before you. It's this entire line. And in this example, you can see each value in the list is its own list containing two values, the column name and the new column name. So I'm going to click on done. And voila, you can see all the names have been changed. Now the next task is to filter out rows that contain not applicable in the age columns, and then filter out rows with age values 5 or less. Now, because the age column was automatically typed in as text when imported, you will need to filter the data in 3 steps, starting with the non-applicable values. Now, to filter out these values, you will need the select rows function. Now, this function returns a table that contains only the rows that match the defined condition, age not equal to NA. As you saw the previous examples, the function's first argument is the target table, which is rename columns from the preceding step. The second argument is in each expression specifying that the age value must not equal NA. The each keyword indicates that the expression should be applied to each row in the target table. As a result, the new table, which is assigned to the filter NA variable, will not include any rows with the age value of NA. Clear? Now, once you remove the NA values, you should convert the age column to the number data type so you can work with the data more effectively, such as being able to filter the data based on numerical age. While changing the type of the age column, you can also change the type of passenger ID column to an integer 64 type. This way, you're referencing to the IDs by integers rather than text, as you can see right here. Now, to convert to the new data types, you should use this particular expression. Now, this uses the transform column types function to change the data types. The first parameter is the name of the target table, which is filter NA, and the second parameter is the list of columns to be updated along with the new data types. Each value is its own list that includes the name of the column and type. Once the age column has been updated with the number type, you can filter out the ages based on numerical value. Your dataset should now include only the desired data as it exists in the filter kids variable. Now, another handy transformation you might need to do at all times is to replace one column value for another. For this example, you will be replacing the 0 value in the survived column with no and the 1 value with yes using the table replace value function. Now, kindly refer to the syntax that is shown to you and try to transpose the following elements that I'm going to discuss with the syntax on your screen. Now, the table replace value function requires 5 parameters in total. First, you have the table, which is the target table, in this case, the variable from the preceding step. Second, you have the old value or the original value, which has to be replaced. Then you have the new value, which you will replace the old value with. Then you have a replacer that carries out the replacement operations. And finally, you have columns to search. Now, the column or the columns whose values should be replaced. Now, most of the parameters should be self-explanatory except perhaps the replacer parameter. For this, you can choose from the several functions that work in conjunction with the replace value function to update the values. In this case, the replace text function is used because text values are being replaced. So first, what we're going to do is that we are going to replace the 0 values with no. And after you replace the 0 values, you can replace the 1 values with yes using the same construction. Here you have your old value, which is 1, your new value, which is yes, the table, which is the replace 0 table, the replacer, which carries out the replacement function in the column survived. And then finally, I'm going to change variable at in. As you can see, I have changed the variable for replace 0 and hence all the 0 values have become no. Now let's go ahead and do the same thing for 1. And there we are. Now another way you can modify your column values is to change how capitalized they are. For example, you will update the values in the gender column so that the first letter of each of the words is capitalized rather than all being in lowercase. To make these changes, again, let's go back to our advanced editor, add a comma. Now again, This expression uses the transform columns function to update the two values. The function requires two parameters. The first is the table to be updated as usual, and the second is the list of operations to carry out. At times, you might need to provide additional information, but that's not the case always. For this example, there's only one operation, so you need to specify that the gender column and the text.proper function are enclosed in curly braces. The function converts the first letter in each word in the gender column to uppercase. At this point, your let expression in its entirety should look similar to what you see on the screen right now. The let statement includes all those steps and makes up your query to this point. Now, with each step building on the preceding step, let's click on Done, and you see the gender column with capitalized first alphabets. And on the right, you see the applied steps. And notice that the applied step section includes one step for each variable defined in the let statement. And all of them are specified in the same order that they appear in your statement. If you select a step, let's say this, the data displayed in the main windows will reflect the contents of that particular related variable. If I click on this, you see, we are back to the step where the ones were not replaced with yeses. Now, up to this point, each procedural step in your let statement represents a discrete action that is built on the preceding step. In some cases, however, you might need to structure your steps in a way that is not quite so linear. For example, you might want to create a calculated column that shows the difference between, say, a passenger's age and the average age for that person's gender. So for that, we need to first calculate the average age of the female passengers and save it to a variable, then calculate the average age of male passengers and save it to another variable, or you can do it vice versa as well. This is optional. Then you can add a column that uses the two variables to calculate the age differences and round the age differences to a more readable number of decimals. Now, this step is purely optional. Now, to carry out these steps, again, I'm going to put a comma, go to the next line, and add a couple of steps. Now, this suddenly might have caused a lot of confusion. So what I'm going to do is I'm going to walk you through these steps in smaller chunks so you can better understand how they work. Now, the first line, which is preceded by two slashes here, which says add calculated column based on average ages, indicates a single line comment. Anything after the slashes to the end of the line is purely informational and does not get processed. Power Query also supports a multi-line comment that begins with a slash and a star and ends with star and slash, just like the multi-line comments in the SQL server if you might be used to that. It's up to you whether you want to include comments or not. Whether or not you do, the next step is to calculate the average age of female passengers. So these are the two steps. The first step uses the select rows function to generate a table that includes only rows with a gender value of female. The function is being used here in the same way you saw earlier, except that different data is being filtered out and the results are being saved to female variable. Notice that the source table for the function is the change case variable from the preceding step. The second step uses the list average function to calculate the average for the age values in that particular table, which is the female table. The expression returns a scalar value, which is then saved to the average female variable. The function requires only one parameter. The parameter includes a second function, which is the table.column, which passes the values from the age column to the list average function. All right, so let's run these two and see. Now you can see we have the average female age right here, which is 30.7, a lot of 2s and 1. Moving on to the next two lines. Now we're doing the same thing for the male passengers, and for this you can use the same construction with a few minor changes. Notice that you must again use the change case variable for the source table when calling the table.selectRows function. Even though it's no longer the step directly preceding the new one, you can in fact use any of the previous variables in your expressions as long as it makes sense to do so. With the average female and the average male variables in place, You can now also add a column using the add column function, which is this one. The table.addColumn function requires 3 parameters. The first is the target table, which is again change case, and the second is the name of the new column, of course, which is the age difference column or age diff. So let's run all of that and see. And now you can see the average male age is around 32 years old. Finally, let's run our add column variable. And if we go to the extreme right, we see our new column with age difference is right here. But then there is an issue, isn't there? Let's go back to the advanced editor. Now, as you can see, this particular argument, the third argument, is the expression used to generate the column's values. The expression starts with each keyword which iterates through each row of the target table. Now, this is followed by an if-then-else expression that calculates the row's value based on whether the passenger is male or female. If the gender value equals female, then the age difference value is set to the age value minus the average female value. Otherwise, it is set to the average male value. But as you saw, all the values are in negative and have way too many decimal values specified. So after defining the new column, the final procedural step rounds off the age difference values to 2 decimal points. The expression includes the transform columns function, which you saw earlier, but it uses the number round function to round off the values rather than changing their case. The number round function takes 2 parameters. The first value is an underscore, which represents the column's current value, and the second is the value 2, which indicates that the value should be rounded off to 2 decimal places. That completes the steps necessary to create the calculated column. Your let expression in its entirety, after you change this to round diff, your let expression in its entirety should look something along the lines of this. All right. It should look something like this. This code I will also leave in the description box below. I'm going to click on done. And here you can see the age difference in plus and minus, whether people go above the age average or below. Now notice that the applied steps section includes variables used to find the average ages, even though the add column step in the code builds on the change case variable. You can view the contents of these variables by selecting each step as I had done before. And if you select one of the variables used to store the actual average, the query editor will display it on its scalar value, as again I had shown it to you before. But again, if I click on average male, it shows a scalar value. Now the query only shows the contents of the average male variable, a rather lengthy number. And now you can see why I included the final procedural step to round the values in the calculated column. Not surprisingly, there's much more to Power Query than what was covered in this particular module. But this should give you the foundation you need to start building your own queries in the Power Query desktop. It should also give you a better understanding of how these queries are constructed when using a point-and-click feature to import and transform your data. In this way, you can examine the code to better understand why you might not be getting the results that you expect. You can also start building your own query by using point-and-click operations and then use the advanced editor to fine-tune your datasets or to introduce logic not easily achieved through the interface version. To make the most out of Power Query in the Power BI desktop, you'll need to dig a lot deeper into the M language's various elements than what we've covered here, especially the built-in functions. Keep in mind though, the Power Query was built with Excel in mind. So you might run into elements that don't transfer easily to Power BI desktop environment. Even so, the basic principles that define the language and its syntax are fairly the same. And the better you understand them, the more powerful a tool you have for working with the data in the Power BI desktop.
Imagine having a massive database filled with valuable insights. but you struggle to extract the right information efficiently. This is where the SQL structured query language becomes a game changer in Power BI. SQL acts as a data gatekeeper, helping you filter, transform, and optimize datasets before they reach your Power BI reports. So whether you're pulling real-time sales figures or analyzing custom trends, SQL ensures your data is clean, fast, and ready for visualization. Now, let us understand what is SQL in Power BI. Well, structured query language in Power BI extracts, transforms, and manages data before visualizing it in reports and dashboards. Power BI connects to SQL databases, allowing users to fetch relevant data, optimize queries, and enhance performance. But why SQL is crucial for Power BI? SQL plays a vital role in Power BI by enabling efficient data extraction, transformation, and optimization before visualization. Since Power BI is a data-driven tool, having clean and well-structured data significantly improves performance and reporting accuracy. SQL helps query large datasets, perform complex joins and aggregations, and optimize data loads before bringing them into Power BI. Now let us see some of the key reasons. So first, here we have efficient data extraction. SQL allows you to fetch only the necessary columns and rows, reducing the data loads on Power BI. Also, using join and group by in SQL minimizes data processing inside Power BI. The next key reason is performance optimization. Here, the large data sets slow down Power BI if not optimized. So SQL pre-aggregates data, reducing the need for complex DAX calculations. Indexes and views in SQL help speed up query performance in Power BI. The next key reason is handling complex data models. So SQL simplifies many-to-many relationships and data normalization before loading into Power BI. Using CTEs, subqueries, and window functions, SQL ensures clean data for efficient Power BI modeling. The next key reason is direct query versus import mode benefits. So with direct query, SQL ensures that Power BI always fetches real-time data from the databases. In import mode, SQL pre-processes large tables, reducing Power BI's memory consumption. Alright, I hope now it's clear what is SQL in Power BI and also why it is crucial in Power BI and its key reasons. So now we will see how to import data into Power BI with the use of SQL. So first, let me connect to MySQL and then create a new database. So here I'll select new database and create a database called Power BI DB and then click OK. And if you expand the Power BI DB and right click on it, you will get the following options. So go to new query. We will be using a new query to create the table. So before creating the table, let me show you the dataset first. So this is my CSV file. The columns in this dataset are ID, product, region, sales, and profit. So that we will create a table for this dataset now. Now here, coming back to SQL, let's type create table sales data. And then I will type the column names and their data types such as ID and its data type int. And then the same way for the product and its data type as varchar 255. Then the next column region varchar, followed by sales and its data type as decimal. And finally the profit and its data type, again decimal. And now let's close the bracket. Now let us select all and click execute. And you will see that the comments were successfully executed. Now we will insert the values in the columns. So we will type insert into sales data value because we have named our tables as sales data, and open the bracket, and then type each column value in and close the brackets. And then let us type select star from sales data, and now select the first line and execute it. Followed by let's execute the second line, and you can see that our columns and values have been executed. Let us follow the same step, select and execute it. And to import data into Power BI desktop, click on Get Data and select SQL Server. And in the Database tab, you can add this server name by right-clicking on the server and selecting Properties. Now copy the server name and paste it into Power BI and then click OK. And then click on Connect and then click OK. So the data is now displayed and you can also select and load it into Power BI. So as you can see, this is the data that we have loaded using SQL. And now to view this data set, Click on table view and this is how it is presented. Here it is. So now let us create a chart and present these values. So for that, go to report view and let's do a small example. So I'm going to select this chart and in this I'm going to drag and drop the columns. Okay. So in the y-axis I'm going to drag and drop the product column and in the x-axis I'll be selecting profit. So that's it. It's simple, right? And I hope it's pretty much clear now. So this is how the Power BI and SQL integration simplifies the data analysis by enabling seamless connectivity and transformation. So here the users can choose between direct query for real-time access or import mode for performance optimization. Also, the strong SQL skills enhance data modeling and querying capabilities. And together, these tools empower businesses with insightful, data-driven decision making.
When we think of Power BI, we immediately think of the platform's visuals and reports. While the front-end report visuals are important and visible to end users, a lot happens behind the scenes that significantly impacts the final product, including data modeling. Have you all ever imagined why does data modeling matter in Power BI? Firstly, it supports data exploration, where data modeling allows users to create hierarchies and drill down paths for more efficient data exploration. Users can quickly navigate through data to find insights and trends. Then the affects performance. The speed and efficiency with which data is retrieved is directly related to how a data model is designed. Poorly designed data models, such as those with complex relationships and data redundancies, can result in slow query performance, causing delays in report rendering. Next is promotes more accurate reports. When a data model is properly designed, it ensures that the data used in reports is accurate, consistent, and reliable. This in turn can lead to more accurate insights and better decision making. The last we have is the easier future maintenance. A well-designed data model ensures that reports are scalable, lowering the effort required to maintain reports as the company grows and evolves. Creating reusable components, improving documentation, and standardizing data can all help to make reports easier to maintain and update over time. Now let's take a look at what is data modeling. In essence, data modeling is a process of defining the structure, properties, and relationships of a data model. A data model in Power BI is a logical representation of how data is organized and linked within the tool. It is a collection of tables and the relationships that are used to generate reports and visualizations. A data model typically consists of one or more data sources, which can range from Excel spreadsheets to cloud-based databases, as well as one or more tables containing the data from those sources. The relationships between these tables are the foundation of data modeling. Now, we will see the benefits of data modeling. Modeling your data allows you to document the types of data you have, how you use it, and the data management requirement for its use, protection, and governance. The advantages of data modeling are developing a framework for collaboration between your IT and business teams. By defining data needs and uses, we can identify opportunities to improve business processes, saving time and money on IT and process investments with proper planning. Then, reducing errors and improving data integrity. Next, planning for capacity and growth helps to improve the speed and performance of data retrieval and analytics. Lastly, setting and tracking target key performance indicators that are specific to your business objectives. Moving on to the relationship fundamental concepts. First, we have the primary and alternative keys. Primary and alternative keys create a relationship between two tables that share a column. Primary and alternative keys are the table columns that define a relationship between two tables. Now let me explain you in detail what is primary key. A primary key is also known as a surrogate key, is a column or group of columns in a table whose values uniquely identify each row. The primary key's distinct count is equal to the number of rows in the table. Next is the alternative key. An alternative key is also known as a foreign key. It is a column in one table whose values match those in another table's primary key, as shown in the screenshot. Next, let me tell you what is a cardinality. Our fact and dimension tables are linked through the primary and alternative keys, but we need to define the relationship further. Each relationship in a model is identified by its cardinality type. It describes the relationship between the number of unique values in one table and the number of unique values in another. In Power BI data modeling, cardinality relationships are classified into three types. First we have is one-on-one. This happens when one record in the first table is related to exactly one record in the second table. This type of relationship is relatively uncommon in Power BI data modeling, as shown in the image. Next we have is one-to-many. This happens when one record in the first table can be linked to multiple records in the second table. And it is the most common type of relationship in Power BI data modeling. This cardinality type connects a fact table to one or more dimension tables, with the dimension table typically on the one side of the relationship and the fact table on the many side, which is again shown in the picture. The last we have is many-to-many. This happens when many records from the first table can be linked to the many records from the second table. This relationship type is not natively supported in Power BI data modeling and is rarely used, which is shown in the picture now. Now let me tell you what is cross-filter direction. Each relationship in a model is also assigned a cross-filter direction, which specifies the direction in which filters will propagate. The cross-filter direction can be either single, also known as single direction, or both, also known as both directions or bidirectional. In that we have the first is single. When a single directional cross-filter is used, only one of the tables in the relationship can filter data to the another. This means that filtering data in one table influences the data shown in the another table. By filtering in the other side has no effect on the data shown in the first table. The next we have is the bidirectional. When a bidirectional cross-filter is used, data can be filtered in either direction along the relationship between the tables. This means that filtering data in the one table affects the data displayed in the other and vice versa. This type is less common and can also have a negative impact on performance while also creating ambiguous filter paths. These are the things that you have to mainly know if you want to learn the data modeling. Now let's see how data modeling works in Power BI. As you can see, we have come to the home page of the Power BI desktop. Now let me show you how to extract the data. For that, go to Get Data. As you can see, under Get Data, we have common data sources such as Excel workbook, data flows, Dataverse, and so on. So I will be selecting text and CSV as my file contains text and CSV format. So now let me select the file that is needed and open it. So now click on Load to load the data. Now to check whether data is loaded or no, towards the right hand side you can see Data. Under Data we have the file that we have extracted. Similarly, I have extracted all the other 4 files, that is Channel, Geography, Product, Sales, and Stores. So if you have a doubt what is the type of the file that we have loaded, in Power BI all the files are queries and we do not specify it as a text or CSV file. Now towards the left hand side we have Table View. When you click on Table View, we have our files that is loaded here. So when you click on each file, we have its columns and the values that is existing. Similarly, under Table View, we have the Model View. So when you click on Model View, here you can see that there are relationships between each file. Now let me show you how data modeling works. So here the relationship is already created because the column of one file is present in the column of the another file. Now for example, let me show you one. Here, under the file of stores, the column name store key is present. Similarly, under the file of sales, you can see the sales key is also present. This is how the relationship is created. But you can see in the channel file, there is no relationship created. So I will teach you how to create a relationship using data modeling. This relationship is automatically created when the column name of the first file is present in the another file. As you can see, channel file does not consist of any relationship. That is because it does not have any common columns. So now to create a relationship, I will be dragging the channel key from the sales file to the channel file. So here you can see that the channel key and the channel have been highlighted because we have created the relationship between them. Now if you see in the cardinality, this talks about the nature of the relationship. So when you click on the cardinality, here you can see we have many to one, one to one, one to many, and many to many. Here I have got it many to one is because that is my nature of the relationship. So here you can see in the cross filter direction, we have single and both. So I will be keeping it as single itself. Now we will click on save. So now you can see the relationship between these two files have been created. This is how the data modeling works. Here you can see we have a lot of options. So one of the options that we're going to see is manage relationships. So when you click on that, so here you can see the nature of relationships, from which column to which column it is connected in the file, and also the status. And the nature of my relationship is many to one, and even the status is active. So here you can see we have another option is the auto detect. It will automatically map the tables. So here we have another option as well, that is new relationship, which allows you to create relationship between two tables or two columns as well. So here towards the right hand side under data, we have an option called model. So when you click on that, here you can see that the relationships that we have created from each file. Now I will teach you how to create the graph. For that, go to report view, choose a chart that is matrix. So to add the values, we have rows, columns and values. For rows, let me drag and drop the product key. And for columns, I'll be dragging and dropping the status. And similarly for values, let me drag and drop the total cost. So now you can see here a graph is created. Now let me show you another example. For that, go to model view. For this example, we'll be using 4 tables. That is sales, product, geography and stores. So let's destroy the relationship for channel now. So keep the cursor to the single directional cross filter. Right click on it. Here you can see the delete option. Click on delete option and click on S. So here you can see that the relationship is destroyed. Now go to report view. Let's create another chart. Now let's create the chart for this example. Under visualization, I'll be choosing the clustered bar chart. Let's align it. Let's add the values for it. So for the y-axis, I'll be dragging and dropping the product name. And for the x-axis, let me drag and drop the sales amount. So here you can see that our chart is created. So for this example, let me create another chart by using slicer. Let me align the slicer now. So here under the field, let me drag and drop the region count. So here for the value for fields, let me drag and drop the region country name. So here you can see that the chart is created. So once I click on any country, for example Australia, here you can see that the product name according to the sales amount is changing. So now you know how this relationship works. Let's go to the model view again and destroy the relationship between the stores and geography. Let's delete it, like how we have done it previously. Click on S. Now you can see that the relationship between the stores and the geography table is destroyed. Now let's go to the report view and just check. So if you click on any of the country, for example France or Denmark or anything, you can see that the graph is static and it's not changing. This is because we have destroyed the relationship between the geography and the stores that you have already seen. So data modeling is that which works in the background to give a proper report to any organization or a company. So to conclude, data modeling in Power BI is critical for transforming raw data into actionable insights, establishing clear relationships, optimizing performance, and utilizing DAX measures, ensuring that your reports are both accurate and actionable. A well-designed data model not only improves the user experience, but also drives more informed, data-driven decisions.
So what is DAX? Now DAX is a collection of functions, operators, and constants that you can use in a formula or an expression to calculate and return one or more values. It is the native formula and query language for all of the data analytics tools in Microsoft, and it is also a very highly versatile and functional language designed to work with relational data and perform dynamic regressions. Simply put, DAX helps you create new information from the data already present in your model. But why is it so important? Now, it's easy to create a new Power BI desktop file and then just bring some data into it. You can even create reports that show some valuable insights without using any formula at all. But what if you need to analyze growth percentage across different categories for different dates? Or you need to calculate year-over-year growth compared to market trends? Data Analytics Expressions, or DAX, will provide you with this capability and many other important capabilities as well. Learning how to create effective DAX formulas will help you get the most out of your data. When you get the information you need, you can begin to solve real business problems that affect your bottom line. This is the power of Power BI DAX, and this is the part of the technology that will help you get there. Now, you might already be familiar with creating formulas in Microsoft Excel. I am hoping most of you have actually migrated from Excel to Power BI. That knowledge will be very helpful to you in understanding DAX. But even if you have no experience with these Excel formulas, the concepts that are described throughout the session here will help you get started with these formulas and solving real-world BI problems right away. We'll focus on understanding DAX formulas used in calculations, more specifically in measures and calculated columns. You should already be familiar with using the Power BI desktop at this point so that you can import data and add fields to the report. And you should also be familiar with the fundamental concepts of measures and calculated columns. If you haven't, I will also link a basic tutorial for you guys in the description box below. Now, we'll frame our understanding of DAX around three fundamental concepts. You have syntax, functions, and context. These are some of the more important concepts in DAX, and understanding these three things will provide the best foundation on which to build your DAX skills. So first of all, you have syntax. Now, before you create your own formula, let's look at the DAX formula syntax. Your syntax includes the various elements that will make up a formula, or simply put, it's how you basically code or write a formula. This is a simple DAX formula for a measure. Now keep a couple of things in mind. This formula includes certain syntax elements. Now, people who are from a coding background will understand what syntax is. It's a grammar for using a certain programming language. And it's the same thing in context of DAX as well. Now, first part, the measure name is total sales. Second, the equal sign operator indicates the beginning of the formula, and when you make a calculation, it will basically do the role of giving you a result. Then sum is your DAX function. This is going to add up all of the numbers in the sales amount column, and this is something that we are going to discuss later. But for now, I have taken sum because everybody understands what a sum is. Then you have your parentheses or your round brackets, which surround an expression that contains one or more arguments. All functions require at least one argument to run, and in an argument, you basically pass a value to the function. Sales here is the table that you are trying to reference, and sales amount, as I had mentioned before, is your column in that particular table. With this argument, the sum function knows on which column to aggregate a sum. Now, when trying to understand a DAX formula, it's often helpful to break down each of the elements into a language you think can speak every day. For example, you can read this particular formula as the sum of values in the sales amount column in the sales table will give you the total sales measure. When you add this formula to your report, this measure will calculate and return values by summing up the sales amount for each of the other fields. Now, you can always go ahead and create your own measure that sums up the values from the sales amount field, but the good part about this method is that this measure will make your formulas and your model more efficient. Now, the best way to learn DAX is to create some basic formulas, use them with actual data, and see the results for yourself. So let's go ahead and create a simple formula, and this task will basically help you understand your formula syntax and how the suggestions feature in the formula bar can help you while creating your formula. Now here I'm using the Contoso Sales sample Power BI desktop file, which is an open source file that I've gotten from the Power BI website. If you go on to their website, you can get it too. but for your convenience, we are going to link this also in the description box below. So this is what your data model looks like. Couple of complicated relationships here. If you do not understand the concepts of relationships, do refer to the tutorial link I'll leave in the description box below, and then come back to this and finish this video. But it's not that important. We are here to learn DAX. So let's go back to our report view. Now this is our report view. This is where we create our visuals. So in the fields list, I am going to right click the sales table and select new measure. This is where we are going to be creating our new measure. Let's go ahead and name this sales for previous quarter or previous quarter sales. All right. Now after the equal sign, which will appear automatically, let's type calculate. Now you'll see this wonderful thing that Power BI is smart enough to suggest a bunch of things which start with CA. The Smart Complete helps you use DAX in Power BI even if you're new to DAX or programming in general. It will also give you a suggestion on how to use this particular function. Now that's brilliant. So what you're going to do is you are going to use the calculate function to filter the amounts we want to sum by an argument that we are going to pass through the calculate function. People who understand coding will refer to this as a nested function. Now, as you can see in the suggestion below, the calculate function has to have at least two arguments. The first is the expression to be evaluated, and the second one is a filter. Now, after this parentheses, we're going to type sum, okay? And then begin by typing sales, through which sales will come up, and let's see, yeah, this is what we want. We want sales amount. And then I close the parentheses. Now this is the first expression argument for our calculate function. Now after the comma, I'm going to keep a space to specify the first filter, and then I'm going to use the previous quarter time intelligence function to filter the sum results by the previous quarter. Okay. So after opening the parentheses, let's type, I'm going to put in calendar and date key. Now the previous quarter function has one argument, a column containing a range of dates basically. In our case, that's the date key column, and then I'm going to close both the arguments. Your formula should now look like this. So I'm going to go ahead and commit, and I'll take some time, and here you can see your measure has been created. Okay. So congratulations, you did it and created a complex measure by using DAX. And that also, this is not one of the easy ones because it has nesting, it has so many advanced functions. But what will this formula do? What it's going to do is calculate the total sales for the previous quarter depending on filters applied in your current report. So for example, if we put sales amount and then previous quarter, so you were just introduced to several important aspects of DAX formulas. This formula included two functions. One is your previous quarter, which is a time intelligence function, which in a nested argument passed to calculate, which is a filter function. DAX formulas can contain up to 64 nested functions, even if it is highly unlikely for a formula to ever contain so many nested functions. Such a formula would obviously be very difficult to create and debug, and probably wouldn't be very fast either. But in this formula, you also used filters that narrowed down what will be calculated. In this case, you selected one filter as an argument, which is actually a result of another filter. You use the calculate function, which is one of the most commonly used functions in DAX. As you go ahead and author models of your own and create more complex formulas, you'll likely use this function many more times. Although any further discussion about the calculate function is outside the scope of this particular session. As your knowledge of DAX grows, my advice would be to pay attention to this particular function. Now, the next thing that I need you to understand, which is a very fundamental aspect of DAX, is context. Now, in DAX, there are two kinds of contexts. You have row context and filter context. First, let's look at the simpler one, which is the row context. And this applies whenever a formula has a function that applies filters to identify a single row in a table. This is something which you apply even without knowing that you apply this. The function will inherently apply a row context for each row of the table over which it is filtering. And like I said, this is most often applied to measures, and you're probably doing it anyway without even knowing about it. Now, the filter context is a little more difficult to understand than a row context, and you can most easily think of the filter context as one or more filters applied in a calculation that determines a result or a value. It doesn't really exist in place of row context, rather it applies in addition to the row context. For example, to further narrow down the values to include a calculation, you can apply a filter context which not only specifies the row context but also specifies a particular filter. For example, when you add total cost to a visualization and then add year and region, you're defining a filter context that selects a subset of data based on a given year or region. But why is this particular kind of context so important to DAX? Now, one of the reasons is because it can basically define a function by relationships and by other measures and columns. Now, to better understand this formula, we can also break this down much like other formulas. This includes the measure name, which is store sales, the equal sign operator, which I had discussed before, the calculate function, which you just used, your parentheses, which surround your expression, a measure, which is your total sales, and then you have a fully qualified referenced column, which is your channel name in your channel table. Now, this is our row context. Each row in this column specifies a channel such as store or online. Now, the particular value store here is a filter. This is our filter context. This formula ensures that only sales values defined by the total sales measure are calculated for rows in the channel name column of the channel table, with the value store used as a filter. Now you can imagine being able to define your filter context with a formula has immense and very powerful capabilities. The ability to reference only a particular value in a related table is just one such example. Now don't worry if you completely don't understand context right away. As you go ahead, learn more, create your own formulas, you'll obviously get a better grasp of this concept and why it is so important. Now let's go ahead, look at a few functions, what they are and how you can use them in your reports. So functions are basically predefined formulas that perform calculations by using specific values. Now these values are called arguments, and you basically are going to use them in a particular order or structure or syntax to suffice your function. Now, arguments can be other functions, other formula, expression, column references, numbers, text, logical values such as true and false, or other constants. And if you're familiar with functions in Excel formulas, many of the functions in DAX will appear very similar to you. However, DAX functions are unique in some ways, such as the customizing calculations based on a row by row method, or the fact that many functions return a table rather than a value, and also the very important time intelligence functions. So let's go ahead and look at a few of these. So first we're going to start out by some simple functions. We're going to start out with some count functions and discover a few different variations of the same function. So again, I'm going to go ahead and click on new measure. And let's go ahead, name this our count measure. I'm probably going to try and reuse this for all the three cases that I'm trying to demonstrate. It's not very complicated. You just type count and wait for Power BI to auto-complete it. And then you pick, let's say, I'm doing product category. Then I'm going to go ahead and commit. As you can see on the right, this measure has appeared. If I drag and drop this on my screen and then maybe pick the card visualization, it is going to give me the exact count of the number of cells that contain numbers. Say the count function, it's basically going to give me the number of cells in that particular column that contain numbers. So we have 8 of those in this. Now remember, the count function is only going to return a whole number, and the only argument that is allowed to this function is a column. The count function counts rows that contain either numbers, dates, or strings. When it finds no rows to count, it basically will return a blank value to you. Your blank values in your columns are going to be skipped, and your true and false values unfortunately are not supported because you cannot count them. Now, if you want to evaluate a column of true or false values, you can go ahead and try a variation of count, which is the count A function. You can use that to count logical values or text. What this is going to do is it's going to count the number of non-empty cells in a particular column. So let's go ahead and try that. I'm going to go ahead and use the very same measure that I had created. Okay. Let's name this count A. And here let's go ahead and count A. Now, as you can see, the syntax has not changed and our value has also not changed, which possibly means that all of the cells in that particular column, which are not empty, actually contain numbers, and there are no empty columns. Now, like the count A function, you have something known as the count AX function, which counts the cell containing any kind of information, including other expressions. For example, if a column contains an expression that evaluates to an empty string, the count AX function treats that result as a non-blank. Usually, this function will not count your empty cells, but if it contains a formula, it is counted. Whenever a function finds no rows to aggregate, this one, like both its sister functions, returns you a blank. So my next example is going to show you how count AX works by counting the number of non-blank rows in the column using a filtered form of the stores table on status off. For that, you need to see what the table looks like. Here's the table. This is the close reason you measure. Let's just name it something, which is close reason. All right. Again, let me tell you, basically we are trying to get a count of how many of these stores are closed by filtering out the number of non-empty cells in the close reason column. Okay. So let's go here and if we turn it into a card, it's giving us the number 12. Let's go to our data and see if that is true. Let's go down, 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 down. I'll keep it here for some time. You can go ahead and count the number of rows, and it's actually 12 rows, which have the status off and a close reason. So that is the number of non-empty cells in this particular column, and we have used the count AX function to count them. So next, let's go ahead and look at some logical functions. Now, these are the functions which are going to act upon a certain expression that you pass on to them and return you the information about the values given by the expression that you put in. Yes? For example, you can use a function known as if to check the result of an expression and create conditional results, because the word if, even in English, is used in a conditional context, right? So in this category, I'm going to discuss the 3 most common logical functions, which are and, or, and not. Another very popular one used more commonly is the if error, which basically evaluates an expression and returns a very specific value if the expression returns an error. So let's go ahead and look at our first function, which is the AND function, which does nothing but check whether both arguments that you have passed through it are true or not. If both of them are true, then it returns true, otherwise false. Now the syntax is fairly simple. All you have to do is put in two logical arguments after the AND, and it's going to return a value depending on the combination of values that you test. Now, if you need to perform an AND operation or multiple expressions, you can create a series of calculations, or better, even use the AND operator that you use while coding, which is the double ampersand sign, and join all of them in a simpler expression. As for this particular function in DAX, it accepts only two logical arguments, hence that's what we are going to do. So I'm going to go ahead and create a very simple measure again. And let's call it the logical measure. Again, like the previous time, I'm going to try and reuse this as many times as I can. Now, basically what this measure is saying is that if 10 is greater than 9 and minus 10 is less than 1, then we are supposed to be returned all true, else one or more false, which is just a good way of saying true or false. We're going to go ahead and test it. And if I just click on this, if you see both of the conditions, they are true. 10 is greater than 9 and minus 10 is less than minus 1. So our conditions are both true. Now, if I go ahead and change this up a little bit, instead of minus 10, I make it plus 10 and then commit, you see the value changes, right? So for the AND function to return you a true value, both of the logical arguments passed through it should be true, else it will be false. Now let's go ahead and try out another very popular logical function, which is the OR function, which basically checks whether one of the arguments is true. Now, like the AND function, the OR function in DAX also accepts only two arguments. So if you need to perform an OR operation on multiple expressions, you can create a series of calculations by using the OR operator. Also, this function evaluates the arguments until the first true argument and then returns true. So keeping that in mind, let's go ahead and switch this up a little bit. Now we know from our previous example that one of the arguments here is true and one of them is false. So instead of keeping this quote as all true, let's switch this to at least one true. And let's switch this to both false. All right. We're going to switch the AND to an OR function. And we're going to go ahead and commit our changes. Now we remember from the previous example that one of them is true, 10 is greater than 9. The second argument is false. So our card shows at least one is true. Now let's change the 9 to 11 and see what happens. As you see, the card shows both of them are false. So now that we've seen and OR, let's look at NOT. What it does is that it changes false to true or true to false once you pass a logical argument through the NOT function. Your return value will be true or false, and you're basically going to pass just one argument through this particular function. So what I'm going to do is I'm going to make these changes here. I'm just going to keep one side as true and one side as false. Here we're going to switch this. Let's remove our second argument and replace the OR by NOT. So 10 is not greater than 11. It's a false statement. So since we are passing it through the NOT function, we should get a true, which is why we're getting true. And let's flip this and see if we get false. And here you go. With that, we've looked at a certain logical functions. Let's go ahead and see what the next type of function is. Next, we have our information functions, which basically look at a cell or a row that is provided as an argument and tell you whether the value matches the expected type. For example, the isError function returns true if the value that you've referenced contains an error and false if it does not contain an error. All of these functions are pretty true to their name and are fairly simple to follow. Now the next one we're going to look at is a function called contains, which returns true if values for all the referred columns exist or are contained in those columns. Otherwise, the function will return you false. So basically, true if all those values exist and false if they don't in the column that is specified. Now make sure that your column is not an expression and your value is basically a sort of a single scalar value. The arguments, column name and value must always come in pairs, otherwise you will be thrown an error, and the column name must belong to the specified table. Now next you have a function called username, which is an expression with no parameters. It returns the domain name and the username from the credentials that are given to the system at the connection time. The code you see here basically verifies if user login is a part of a certain table or not. It's as simple as that. Your return value is going to be the username from the credentials given to your system. The same logic applies to two other information functions, namely user object ID, which returns the current user's object ID or SID, and the user principal name, which basically returns the user principal name as the name suggests. Next, let's go ahead and discuss some text functions. Now, DAX includes a set of text functions which are basically based on the library of string functions if you have worked on Excel before. Now, these functions have been modified to work with tables and columns in tabular models of Power BI, but if you've worked with them using Excel, it might come naturally to you. Now, the first one we're going to look at is concatenate, which, as the name suggests, it concatenates two text strings into one text string. You're basically going to use the function and then pass two different texts, and then your function is going to concatenate or join those texts. Now, the joined items can be text, numbers, or Boolean values represented as text or a combination of those items. You can also use a column reference if the column contains appropriate values. So again, if I go ahead and create a new measure, let's try and concatenate the commonest text that you can, which is hello world. See, it's as simple as that. Now you can go ahead, do the same thing with numbers or Boolean and work with it as you like. The next function we're going to look at is exact. Now what it does is that it compares two text strings and returns true if they are exactly the same and false otherwise. It's pretty self-explanatory, and one thing you have to remember is exact is case sensitive but ignores formatting differences. So you can use exact to test your different strings being entered into a document. So let me switch the second word to hello, but maybe with H capital. And as you can see, because it is case sensitive, it's going to return false. Now this is great if you want to compare two different columns and their values from two different tables that you have updated from, let's say, two different individuals. So you can sort out the differences and see where the irregularity lies. So the next text function we're going to discuss is upper. I'm going to go over this pretty quickly. It converts a text string into all uppercase letters. So if I used upper and maybe, let's say, Now, the next and the most common functions that are used in DAX are, in fact, the date and time functions. As the name suggests, these functions help you create calculations based on dates and time. Now, again, if you have used these in Excel before, they are very similar to the date and time functions there. However, like we saw in many other functions prior to this, the DAX functions in Power BI take values from a column as an argument. So I'm going to go through a couple common ones very quickly, and then we're going to discuss a few common time intelligence functions, which are a section of their own. So first of all, let's discuss today. Now, this function is very useful when you need to have the current date displayed on a worksheet, regardless when you open the workbook. Although it is most commonly used for calculating intervals. So I'll quickly go on to DAX and use this function. Okay, so we're going to go click on New Measure. Let's call it the date measure. And then commit. Now, if I had to display this on a card, it would give today's date. But a DAX function simply can't serve this purpose. It has to have more of a purpose than just showing the date, right? So, suppose if you know someone was born in 1955 maybe, you can use this formula to find that person's age as of this year's birthday. So here we are going to use another function, which is the year function, and subtracting 1955 from it. Let's commit. And you know that person as of this year would be 65 years old. This particular formula uses the today function as an argument for the year function to obtain the current year, and then subtracts 1955, which will return the person's age. Now that you've already seen how you use the year function, let's go ahead and look at it from a definitive standpoint. Now, as the name suggests, your year function will return the year of a date as a 4-digit integer, and that goes for all of Microsoft's spreadsheet-based applications and softwares. If you try to use date and time functions before the March of 1900, you'll probably get an error. Now, you need to understand that in contrast to Microsoft Excel, which is basically storing your dates as serial numbers, what DAX does is it uses a date-time data type to work with dates and times. Dates should be entered by using the date function or as results of other formulae or functions. You can either enter dates in accepted text representations of dates, such as 22nd June 2020 or June 22nd, 2020, depending on where you're from. Now, you need to keep in mind that errors may arise if the format of strings is incompatible with the current local settings, and you'll have to take care of it as you go along using this. Another one like the today function is actually the now function, which not just returns the date, but also the time in date-time format. Now, the now function might seem only useful when you need to display the current date and time on a worksheet, but it is also used to calculate a value based on the current date and time, and when that value is updated each time you open the worksheet. The result of the now function changes only when the column that contains the formula is refreshed, so please do not expect it to get updated continuously. Now, the last one I want to discuss is not just a date time function, but also a time intelligence function. Now, what a time intelligence function does is that it enables you to manipulate data using time. Now, this includes dates, months, quarters, and years, and you can then build and compare calculations over those periods of time. Now, one in particular which is used a lot is the dates in period function. Now, this basically returns a table that filters out your column only between a certain period of time or in between your start date and end of interval. It returns to you a table containing a single column of date values. So one very commonly used time intelligence function is your end of month function. It could be your end of quarter or end of year function as well. Now, what these kind of functions do is they return the last date of the month in the current context for specified column of dates. This table contains a single column and a single row with a date value. Now, this could be a reference to the date and time column, a table expression that returns a single column of date time values, or a Boolean expression that defines a single column table of date and time values. Now, one thing you need to remember is that you cannot use this in the direct query mode. So let's go ahead and look at a sample to create a measure that creates the end of the month for the current context. Let's call it end of month or EOM and use it directly. Now, like I said, you can use the end of quarter or end of year as well, depending on what your company uses, and put in the date key. Let's drag it out and put it in a card, and here you see your end of month. You can go ahead, drag it into a visualization and see how it affects your visualization. And you can also use the other variations of this, such as you can change end of month into end of quarter, which will basically give you the date for the end of quarter. This is the end of my quarter, so that's that. With that, I think we have covered all the common functions that there is to know about. You can obviously go ahead, look at the official documentation for DAX and see for yourself the entire plethora of functions that are available at your disposal.
Have you ever wished you could make instant decisions in Power BI without endless nested if statements? That's where switch function comes in. It's your shortcut to cleaner and more efficient conditional logic. It's like a smart menu in a restaurant. Give it an order as an input and it serves exactly what you need as an output, whether it's dynamic labels, classifications, or custom calculations. So let's uncover how switch can streamline your reports and supercharge your data analysis. Let us understand what is switch function in Power BI. Well, this switch function in DAX makes it easier to write conditional statements. It evaluates an expression and then it compares it to a series of values returning the first matching result. Switch function can replace multiple nested if statements by condensing multiple conditions into a single function. This leads to a cleaner, simpler DAX expressions that are easier to read and maintain. So it also improves the readability of your formulas, making it easier for you and others to understand and modify your calculations. Now, let us have a look at the basic syntax for the switch function. So, as you can see, there is an expression, the expression that is evaluated, and then the values that are compared against the expression, and then the results that are returned if the expression matches the corresponding value. And then we have else, an optional result that is returned if none of the values matches the expression. Now, let us have a look at why is the switch function used in Power BI. The switch function in Power BI is a powerful alternative to complex nested if statements, making your DAX formulas easier to read and maintain. So here's why you should use it. First, it simplifies conditional logic. Switch handles multiple conditions efficiently by evaluating an expression and returning the first matching result. This makes your DAX code cleaner and easier to understand. Next, it improves performance. Compared to deeply nested if statements, switch can enhance performance, especially in complex calculations with multiple conditions. And then the dynamic reporting. It enables dynamic categorizations, conditional formatting, and custom calculations, allowing you to create adaptable and interactive reports. Now let us see how to use the switch function in Power BI. So now we are at the Power BI desktop. So to import the data, we are going to get data, and then from here, select text or CSV, and then select your data. So once you open it, here you can click on load. And as you can see, the data set is getting loaded. Alright, so here we have it. So let's open it. Okay, now let us click the table view and here is the data set. So as you can see, we have a column called revenue generated. So to effectively categorize income levels based on this revenue, we are using the switch function in PowerBI. And we are simplifying complex conditional logic to make our DAX code easier to read and maintain. So now let us create a new column called income category. And this can efficiently classify revenue into low, mid or high categories based on specific thresholds, enabling more insightful analysis and dynamic reporting. So now let us type the formula. So the formula goes like this: income category equal to switch, and inside the switch function we are using the true function, which ensures the function checks each condition sequentially, and followed by the first condition that evaluates to true returns its corresponding value. So the condition is sales revenue generated is less than 90,000, then it should consider it as low. And if it is false, it checks the next condition. And the second condition is if revenue generated is between 90,000 and 5 lakhs, it returns as mid. And if it is false, it moves to the next condition. And the next condition is if revenue generated is greater than 5 lakhs, then it returns it as high. And if none of the condition matches, the function continues to the final case. And there is another condition which is a default case, which is known as unknown. So if no condition matches, then it returns unknown to handle unexpected or missing values. Alright, so once the formula is done, let us click on the commit. Okay, as you can see here, there is a new column called income category, and also it has categorized into low, mid and high. Alright. Now let us go to report view, and from the visualization let us pick the column chart. And now in the x-axis let us drag and drop the income category column, and under the y-axis let us drag and drop the ID column. And here it is. So here the chart shows the distribution of IDs based on their income category. So as you can see, a total of 50 IDs fall into the high category, meaning their revenue is more than 5 lakhs. And then we have the 40 IDs are in the mid category, indicating their revenue ranging between 90,000 to 5 lakhs. And then we have a low revenue. Here we have 10 IDs in low category, indicating their revenue is less than 90,000. Okay. Now let us categorize individuals based on their age. So we will use switch function in PowerBI, and this will create a new column called age category to classify people as adult, mid-aged or senior based on their age range. So making it easier to analyze demographics. So for that, let us click on new column, and here let us type the formula. So here is the formula. So formula goes something like this as age category equal to switch function, and inside the switch function we are using a true function. And we are using true function to ensure that conditions are evaluated sequentially, and followed by the first condition that evaluates to true returns its corresponding value. And the first condition is if age is 20 to 29, then the result is adult, and if it is false, it moves to the next condition. And the next condition is if age is 30 to 44, then the result is mid-aged, and if it is false, it proceeds to the next condition. And we also have third condition which says if age is 45 or older, the result is senior, and if this is also false, it checks the final case. And we have another condition which is a default, which is known as an unknown. If age does not meet any of these conditions, for example, let's consider less than 20 or invalid, then it returns unknown. Alright, so once you're done with the formula, let's click on the commit. So as you can see here, we have a new column which is created, which is age category, and we have also categorized according to adult, mid-aged and senior. Alright, now let us go to report view. So in the same chart, we are going to drag and drop the age category we just created into the legend field. So as you can see here, the data is categorized into adult, mid-aged and senior. Okay, so here the switch function in Power BI is a powerful tool for simplifying conditional logic and creating meaningful categories. And by using it to create columns like age category and income category, we can easily classify data, enhance analysis and make reports more insightful and user-friendly. So here are some of the best practices for using switch function effectively. So first is the use for multiple conditions. So switch function is ideal when you have more than 2 conditional checks. And it makes your formula easier to read and maintain than the nested if statements. And the next best practices is that clearly define all cases. So your switch function should cover all the possible scenarios, including a default case to handle unexpected values. This ensures your calculations are robust and less prone to errors. Next, optimize for performance. Keep the expressions within switch function as simple as possible to avoid performance hits when working with large data sets. And using variables to store intermediate results can help minimize the computational burden. Finally, test thoroughly. Especially when using switch function for complex logic, ensure you thoroughly test your results across different scenarios. And this will help catch any logic errors or cases you have missed. So as I discussed previously, this switch function in Power BI is a powerful tool for handling multiple conditions effectively. It simplifies complex logic, enhances performance, and enables dynamic reporting. And mastering switch can help you create cleaner, more adaptable and user-friendly reports, making it an essential skill for Power BI users.
So Power BI provides us the functionalities of multiple charts that we can use. So you will find bar charts, column charts, line charts, area chart, combination charts. You have pie charts, donut charts, tree maps, funnel charts, gauges and cards, tables and matrices. So there are lots and lots of visualizations that are available that we are going to explore now. So Sunit has a question over here. Same thing we can do using Excel. So what makes the advantage of using Power BI? So Sunit, so basically what happened is like in Excel, definitely you can create the charts. The first thing is that those charts are limited. And second thing is, suppose if you have a raw data, right? And with that raw data, what you want to do is you want to create a quick summary report. So in Excel, first of all, what you will have to do is you will have to summarize the data by applying some formulas or by creating some pivot tables. That will be your first step. Then once your data gets summarized, then on top of that, you will add a chart in it, correct? So there are two steps in this. Once you summarize the data and then you add a chart on top of this. Now that summary of the data will not be very quick. You will have to spend some time. You might have to do some calculations and formulas, which can take the process a little tedious. Now, if suppose in that report, you have to showcase 5 different charts. So that means you will have to create 5 summaries of the data, right? You will either create 5 pivot tables or you will create the formulas 5 times to first prepare the data and then create a chart on top of that. But all those hassles are not required in Power BI. You just have to select the chart. Aggregation and summary of the data is taken care of by Power BI automatically. You just have to select your calculation. Secondly, Excel cannot handle huge size of data, right? So you like in Excel itself, you have a limitation of 10 lakh or I will say 1 million rows of data. But Power BI can handle millions of rows without any challenge. Thirdly, if you will see, Power BI also gives you a lot of features of interactiveness. So you click anywhere on your report, the data will get filtered across all the different charts. So Power BI offers you the option of interactiveness, which is not possible in the Excel. And also sometimes if you have to make some more advanced functionalities in the Excel, you might have to write some VBA codes as well, which can again take a lot of time. Now, if you compare both Tableau versus Power BI, right? So when we talk of Tableau and Power BI, so both are visualization tools. That is something that they have a common feature. So Power BI has an edge in the context. If I tell you, the first advantage that Power BI offers is it has data transformation capabilities, which Tableau doesn't have, right? So basically for Tableau, if you have to do some advanced level of data transformations, you have to use another tool, that is Tableau Prep. But with Power BI, you don't need any additional tool. You can do all the transformations in your Power BI tool itself. Secondly, it is similar to Excel. So people who already have some experience and they have used pivot tables and all, so for them, learning curve of Power BI will be very less. They will be easily be able to learn it. The third benefit that Power BI has over Tableau is that is low upfront cost, right? So a license of Tableau costs you $70 per month, whereas Power BI costs you $9.99 per month. So if you see, the cost is also a very big role, something that impacts the use of the tool. So these are some of the features which make Power BI very much superior to Tableau, I will say, and make it that they have a higher edge over the Tableau, right? So visualizations definitely you will find to be similar in both the tools, and there could be certain visualization that you might be able to create in Tableau and not in Power BI, and likewise some in Power BI, not in Tableau. So those things are almost same on both the tools. Okay. So what we're going to do is we're going to explore this data plus visualizations, which makes it a complete Power BI tool. So let us see how you can create all these different type of charts very easily using the Power BI now. So I'll launch my Power BI tool. And also, if you will go by the latest trends also, like what something that I have observed is that now, the demand of Power BI has actually increased if you compare it with Tableau, and it has very fast, widely increased. So, as such, you don't need any language to learn, right? But yeah, if you know SQL, so that can be an added advantage. But even if you don't learn it, so it won't be a showstopper to learn Power BI now. And people, who might not have this the Power BI with them. So this is the link from where Power BI can be downloaded. So if you scroll down, so you will find the option of download. So dataset that we are going to use over here, this is a Superstore dataset, in which what we have is we have the data like, when you go and do some shopping from any of the e-commerce platforms, right? So you do some shopping from Amazon or you do some shopping from Flipkart. So over there, when you purchase something, there is an order ID that gets generated. So on what date that order was purchased, what was the shipping date, what was the shipping mode, right? Who was the customer who purchased that order? So customer name, segment, country, city, and state from where that order was purchased, the postal code, region, and what all products did he purchase, and what was the sales value, quantity he purchased, and the profit. Now, this is the data that we have in this file. So we will be using this data to create some interesting visualizations in Power BI now. So if I come over here to the Power BI, when you launch it for the first time, so you might get this window coming up onto your screen, which may ask for sign in. So you don't have to worry to sign in something. You just click on this cross sign and the box will be closed. The next thing that we do over here is we have to load that data into the Power BI interface. And how do we do that? You just have to click on Excel, because the file that we are using over here, it's an Excel file. So I click on Excel so as to load the data from there, and we go into that folder where that file is saved and click on open. So Power BI is going to create a connection with that file. This will just take a while to do that. So if you see now, the connection with that file has been created. So we will be able to see all the sheet names that we have in the Excel. Just a second, I think the file just got stuck. I'm just loading it again. Yep, so here we are. So orders. So once you select that file, you just have to click on load, and the file will be loaded in your Power BI interface. And actually, I've now closed the unnecessary documents that were opened up, so it speeds up the process. So now what we do is, once the data is loaded now, right? So when you come in this Power BI interface, so you will be able to see all the fields on the right hand side, and this is where you will be able to see all the visualizations that are available in Power BI, which we can use. And if you come on the left hand side over here, you will find there's a section. This is a report view, right? So currently we are in the report view where the visualizations will be created. And the second is, this is your data view. Right? So data view is something where you can have a complete preview of the data that you have loaded in the Power BI. Right? So order ID, order date, shipping date. So you can see complete information and complete data over here. You can't edit the data, you can't modify the data. You can just look at the data, and if you want to filter it out, you can do that. The third tab that you see over here is the relationship view. So relationship view means where if suppose you have a data, right, where you are loading the data from multiple files. So you can use this option to create the relationships between them. But right now we don't have multiple data sets. So we are going to jump back to the report view where we will be creating our visualizations. So in order to build the visualizations, you just have to pick up the chart from here and you will be able to create it. Suppose if I pick this chart over here, this is the clustered bar chart. So just click on this and you will notice that clustered bar chart, structure of a clustered bar chart will come up over here. So please everyone pick this up. So now what we do is we are going to make this chart. So when you select this chart from here, you will observe the options get activated below this chart now, right? So what I do is I am going to pick category and I'm going to put it on the axis. So when you put that category on the axis, you will notice you can see the category name over here. Then you pick up the sales and put it in the values. Okay, and you can see over here that these are the three categories that I have: technology, furniture, and office supplies, and we can see the sales across them, right? So this is a normal bar chart that has been created where I can easily compare the sales across the three categories. Okay, now what you can do is over here, let's pick up the field of region and I'm going to put that up into the legend, and the chart is going to split into 4 of the regions that we have in the data. So I can see that what was the sales in technology in central region, east region, south region, and west region. So I can see that split across the regions now for the three categories that we have. So it becomes easier to compare now, right? In which region, which category had the highest sales. So this is basically called as a clustered bar chart, right? If you want to modify this chart, you can click on the other chart. So this will become a clustered column chart. So difference between a bar chart and a column chart is this: bar chart is where you have the horizontal bars, and column means these are vertical. So that is what you have as the difference between the bar chart and a column chart. Now likewise, if you come over here, so we have seen bar and column charts over here, right? So these are two charts. Then you can create line charts and area charts. So why do we use line charts? Line charts are used to see the trend over a period of time, right? That is where we use the line charts. So for example, if you come over here now, this is where you will find the option of line chart. If you click on this line chart, the empty structure of this line chart will come up, right? Now on the axis, we are going to pull the field of order date, and then we are going to pull the field of sales now. If I put the sales into the values, you will notice a line chart will be created right away where I can see what was the sale generated in 2014, 15, 16 and 17. So I can easily analyze that the sales have increased over a period of time. Okay. And with these charts, Power BI also provides you a lot of options to do any of the customizations if you may want to do on these charts now. So when I say customization, customization means if you want to change the color of the line, you want to change the color of the bars, you want to add some background color, titles and all. So all those things are very easily possible with the help of Power BI. So if you click on this option of format, so with this, I will be able to do all those changes. So for example, if you want to change the data color, so you can change the color from here and you can choose any color of your choice. Likewise, if you come down, you want to turn on the data labels, you can do that. You can show the data labels on the chart. If you want to change the shapes and all, so you can do that as well, right? So if you scroll down, so Power BI will give you lots and lots of options to customize the chart. You want to add some background color, so you can just select any of the color of your choice, and you can play with the transparency and make it light and dark. So you can see the background colors can be applied on these charts very easily. You can apply the borders around the chart. You just need to turn on the border and the border will be applied. You can give some shadow effects to the chart. So here you can see a shadow effect has been given in this chart over here. And if you want to replicate the same thing, the colors of this chart to this chart, so just select the chart and click on Format Painter and click over here, and you will observe those changes will be replicated over here. So this is how you create a line chart now. Now, similar to line chart, we have one more type of chart that is called as an area chart. So if you click on this area chart, not this one, so just make sure this line chart is selected. If you select the line chart and you click on this area chart over here, right? So you will find this chart over here, area chart. So if you click on this, the chart will get converted into an area chart now. So the difference between a line chart and an area chart is that line chart gives you a single line over here, whereas area chart fills the bottom of the chart with the color, so it looks a little more occupied on that chart area as compared to a normal line chart. So this is what an area chart looks like. If you want to add some more data in this, you can do that as well. Suppose you want to convert it back into a line chart and you want to split this data based on, say, suppose the segments, right? So you can pick up the segment and you can put it in the legend. So you have an option of legend as well in the line chart. And now you see there are 3 segments in the data. So we have consumer, corporate, and home office. So you can see for all the 3 segments, 3 different lines have been created over here, right? So we can see the 3 different lines, one line for each of the segments, and from where we can see, like, on a basis of trend, both the 3 categories had an upward trend, but in terms of sales, the consumer is the segment which has generated the highest sales over a period of time, right? So see, there are 2 things that you all have to focus upon. So when we are building the charts, it is not just about the technicality that what chart we are creating. We also have to keep in mind and we have to understand that any chart that we create, it should have, it should suffice the purpose. It should be able to tell you what analysis or what inference you are getting from there, right? So that is very, very important. So if you see from here, I can see the trend that how the sales have changed over a period of time for the 3 different segments. Now what you can do is you can add pages in the PowerBI. So if you feel you want to add more charts, you can click on page 2. This plus sign, a page 2 will be added. Now what we're going to do is we are going to explore some of the other charts, which are like combination charts and ribbon charts. So let's try to see what are they and how do we use them. So this is where you are going to find a combination chart, right? This and this. So combination charts are something, which have both line and a bar chart in them, and we use them to analyze more than one value, right? So like in the previous charts that we created, we were only analyzing the sales, right? Sales over a time or the sales in comparison to the categories. But suppose you want to compare 2 things. So let us see that out. So we will click on line and stack column chart. Okay, so this is where this chart comes up. Now on the shared axis, suppose I put the category. I put category on the shared axis. Okay, now I want to show the sales. So sales will come in the column values, and you can see a bar has been created and we can easily compare the sales of the 3 categories. And if you pick up the profit from here and let's put it on the line values, so you will observe there is a line that has come up now. So I can easily compare that what is the how the sales that were given by the 3 different categories, and with the help of the line I can I can analyze what was the profit that was generated by the 3 categories. So I can see the lowest profit was given by furniture, And if I talk about the profit over here, so it was very high for office supplies and it was the highest for technology. So I can compare two things in one chart, that is sales and profit. And again, if you come into this formatting option, you will be able to do a lot of formatting options over here. So I'm just trying to show you one. There is an option of secondary access. So in the formatting, if you come up, right, so in the search you can type secondary. So you will see there's an option will come up, show secondary. So when you say so what happens is the secondary axis also comes over here. So you can see both the axes on this chart. On left side you have sales, on the right side you have the profit. So you can see both the axes now. So Rashmi, the complete training is of 27 hours, right? So which is spread across weekends and weekdays. So weekdays it takes 13 days and weekends it takes 4.5 weeks. So to have the complete tool knowledge where you learn about visualizations, you learn about data formatting, data cleansing, data modeling, and DAX and all. Okay. So the next type of chart that we are going to explore over here is a ribbon chart now. Okay. Now ribbon chart is something which could be very much new for some of the people, which is something you will not find in any other tools. So if I show you this, you just have to click on the ribbon chart over here. This is a ribbon chart that we have. Okay. Now in the ribbon chart, what I do over here is I am going to put category on the axis, sales in the values, and I'm going to put region, right? So we have a field of region on the legend. So you see a chart has been created now. So first of all, please don't do anything. First, just understand the chart, then you all try it. On every chart, you will find there is an option at the top which is called as focus mode. So if I click on this focus mode, the chart will come on the entire screen, right? And when you see this thing over here, what you will observe is that how we analyze this chart is, now that is something very important to understand in this chart, because this chart is more about technicality. So if you see the bars, right, the bars are telling you what was the total sale for each category, right? So if you come over here, sales for technology, sales for furniture, and sales for office supplies, correct? This is the first information that you get from this chart. Now if you take a look at this orange wave, this orange is for south region. So now in this chart what you will observe over here is these colors are, this breakup is sorted in the ascending order, right? So in technology category, the sales is lowest for the south region. That is why it is coming at the bottom. Then it is higher for central, higher for the west, and the highest for east region. That is what this chart is telling me, right? And when we go from the technology category to furniture category, so there is a change that has happened. The sale of the west region has gone down and it is coming at as the second highest sales for furniture in the west region, right? So you can see there is a downward trend that has come up, and then the sale has got further decreased a little bit from furniture to office supplies for this particular region, that is east. Getting it? I'm just showing you the trend for the blue color right now. Don't see any other thing over here on this chart. So if you hover on this blue area, it in fact tells you that the sales has dropped by 21%. And if you come over here, the sale has further dropped by 1.33%. You see sales change, that is minus 1.33%. So sale has decreased. And if the sale would have increased, it also shows that it will be a plus sign. So you see for this particular region, west region, when we go from technology to furniture, the sale has increased by a margin of 0.25%. And the rank has also changed. Previously the rank was 3, now the rank became this top over here, rank 1. So if this previously was rank 2, sorry, not 3, we will say rank 2. It was 1, 2, 3, 4. So 2 rank became 1. So now what we will do is we will come up and we are going to explore some more charts in it. So we are going to see the pie chart, donut charts, and the tree maps. So why do we use pie charts, donut charts, and tree map is when you have to showcase some market share, right? You want to see, which item is having higher share or which item is having a lower share. So let's try to create that. So you will observe we have a pie chart over here. You click on this pie chart, and in this pie chart, suppose I want to compare the sales of the different, I will say shipping modes. So I pick up the ship mode, I put it in the legend, I pick up the sales, and I put it in the values, and your pie chart will be ready. So I can see 59% of the sales had happened in the standard class, right? So we can see that percentage share. Out of that, then I can see this is the sale for second class, which was 19%, 19.99. This is the sale of first class, and this is the sale of same day delivery, right? So this is a shipping mode. So that how do you want your item to be delivered? So for all these 4 categories, we can see them. Okay. So this is a pie chart, and just a little bit different chart that you have over the pie chart is that is a donut chart. So if I just make a copy of this, Control C and Control V, I can copy this chart and I will convert this chart in the form of a donut. So you can see this donut shape over here. If I click on this, this chart gets converted into a donut chart now. So both the charts are same, just that a donut chart has a circle in the middle, a transparent circle. Otherwise, from the information perspective, both the charts are same. In the middle, you can never have any percentage, right? Like over here, percentage is for each section. So that is why they are coming over here. In the center, you can only show one number, right? If you click on this chart, but if you want that these legends that these data labels that you have, right? Detail labels, if you come over here, so you have this option of position. You want to keep it outside or inside. This is something you can do, right? So they can come over here. You can place those labels, right? Like this on these places only, not inside exactly. Sure. Now, similar to this, you have another chart, which is a tree map. Okay. So I'm just adding a new page. This is where you will find the option of tree map now. So if you click on the tree map, now this is also something on the similar lines of pie chart only, but different in the visualization. So I pick up the field of ship mode, put it over here in the group, and I pick up the sales and put it in the values. So you will observe a chart which is a tree map has been created. Now this chart is bigger the box, higher the sales, smaller the box, lower the sale, right? The size of the box is telling you the quantum of sales over here. Bigger size means bigger sales, smaller size means smaller sales. Okay, so this is how we can use this tree map in order to have some interesting visualization over here. You can create maps as well in the Power BI, right? So map is one of the interesting features. So if you want to show the data on the map, right? So for creating a map, you need to have a geographical data with you. So you can pick up the map from here, right? So once you pick up the map from here now, over here in the map, suppose I drag my state. So I want to show the states on the map. I'll pick up the state, put it in the location. I'll pick up the sales, put it on the size, and your map is ready, right? So you see bigger bubble means higher sales. So if you see California has a big bubble, that means in the California there was a high sale that was generated. If you take a look over here, that is New York, it is telling you that in the New York, again there was high sales but less than California. But in the places like Idaho, Montana, there was very less sale that was generated. And if you talk about Washington, there was a medium type of a sale that was generated now. Now, similarly, you will find there are bundle of other visualizations as well that are available in Power BI, which you can easily create to analyze your data, right? So you can create the maps, you can create the funnel charts. So if you want to create a funnel chart over here, so you will see there's a funnel chart over here. You select the funnel chart. Suppose you want to show the sales of subcategories. So you pick up the subcategory from here, put it in the group, pick up the sales, put it in the values, and it creates a funnel like structure for you. The subcategory that has the highest sales comes at the top, and as you go down you can see the sales are decreasing, right? So a beautiful visualization to see a pattern that how the sales have changed for the different subcategories now. And it also offers you an option where you can see how the percentage has changed, right? This is a very interesting feature that you will find. Like if you come on the chairs, now it is telling you that chairs had 99% of the sales of what tables had. So tables and chairs, you will see 99% of the sales what you had in this table phone, sorry, not tables, phones. And whatever you had the sale for phones, 99% of that was achieved in chairs. Similarly, if you go down, it is telling you that for storage had 67% sales of firsts. First means phones. So whatever was the sales of phones, 67% of that was generated for the storage. So likewise, you will see the percentages till the last. So this is an interesting visualization to see that sales in that decreasing order for the different subcategories with the interesting visualization over here. Likewise, you can create some bar charts, you can have the tables and matrices, and you can create the visuals using the R script visuals as well, right? So for that, you have to be a little bit comfortable with your R scripting and R codes, and you can create your visuals in the Power BI itself, right? So for example, this is where you are. So you just have to pick up the R visual from here. You click on enable. So in order to create the visualization using R, you should have R and R Studio to be installed on your system. Without that, you cannot create R and R visual, and same goes for Python. If you have Python installed on your system, then only you will be able to create the Python visuals as well, right? So this is basically how the R and Python visuals are created. You just have to pull that, and then what you have to do is you just have to drag and drop your fields over here. So if I drag the sales, I drag the profit, right? So you see this, some code has been generated over here. You just have to write the code what you really want to create. So if I say plot, right? So we have dragged two variables over here, that is dataset dollar sales and region. So I'm just going to say dataset dollar sales, comma. Now this is the R code, the code that I would have written in the R. I'm writing the same thing over here. Dataset dollar. So it's not region basically, it should be profit. Second. So we drag the sales, we drag the profit. So plot dataset dollar sales, comma dataset dollar profit, right? And I simply say don't summarize. And select to enable. And you can see the chart has now been created. So this chart that you see has been created by writing a R code. So this code that I have written over here, based on this, the chart has been created, right? So that is how you just have to write your code of the R or the Python, and the visual will be created. Okay. So this is what I think we will be having for the session, right? So I hope you all enjoyed the session and you got some insights on how you can create some interesting visualizations using Power BI at the speed of light.
Power BI's KPI Visuals serve as a dashboard for your success. They instantly show if you're meeting your goals by tracking key metrics with dynamic updates and trend indicators. So, it's the best way to transform raw data into real-time insights quickly, clear, and actionable. So, in this video, we considered Blinkit's example where we will show how Blinkit made use of KPI in Power BI. The Blinkit grocery store chain faces challenges in tracking and optimizing its key performance indicators such as sales trends, inventory levels, and customer satisfaction. Decision makers are struggling with the following challenges. First, identifying underperforming products. Next, forecasting inventory needs to avoid overstocking or stockouts. Then, understanding customer buying patterns to improve marketing campaigns. Then, monitoring operational efficiency across different stores. So now that we have explored the use case, so let's move on to the challenges faced by Blinkit during this journey. So the challenges faced are, first, data silos. Here, different systems for sales, inventory, and customer feedback make it hard to unify data. Next, manual reporting. So here, generating reports manually is time-consuming and prone to errors. Next, lack of real-time insights. Decisions are based on outdated or static data. Next comes the scalability issues. As the chain grows, analyzing data manually becomes impractical. Next, let's take a look at the tools Blinkit relied on before transitioning to Power BI. So the first tool is the spreadsheet. For example, Excel, used for manual reporting but lacked interactivity. Next, basic reporting tools, limited to static charts and predefined views. Next, ad hoc scripts. This allowed custom scripts in Python or R for advanced analysis but not accessible to non-technical users. With that in mind, let's see how the tools evolved after implementing Power BI and the improvements it brought. So here are the tools. First, Power BI dashboards, which allows real-time interactive dashboards with drill-down capabilities. Next, data integration. It provides connections to multiple data sources, example, sales databases, inventory systems, and customer feedback. Then comes DAX and Power Query. It helps with advanced calculation and data transformation within Power BI. Now, let's explore the solutions that address these challenges. So, using Power BI, Blinkit addressed its challenges with the following approach. First, unified data platform. It integrates sales, inventory, and customer feedback data into a single Power BI workspace. Next, dynamic dashboards. Helps to create dashboards for real-time tracking of KPIs like sales trends, stock levels, and customer satisfaction scores. Next, forecasting and insights. Implemented predictive analytics using Power BI's AI capabilities to forecast demand and identify sales opportunity. Next, enhanced collaboration. It enabled teams to share reports across departments with updated cloud-based dashboards. Next, let's understand why KPIs are so important in Power BI. Well, using KPIs in Power BI is critical for tracking performance, making data-driven decisions, and aligning with business objectives. So here's why they matter. KPIs simplify complex data by distilling large datasets into simple visuals, allowing stakeholders to assess whether goals are met quickly. Next, monitor progress. They provide real-time data on key metrics such as revenue, customer satisfaction, and project timelines, allowing you to identify trends and areas for improvements. Then, improve decision-making. By visually comparing actual performance to targets, KPIs help prioritize actions and focus on what is most important. So, in a nutshell, KPIs convert raw data into actionable insights, making your Power BI dashboards more effective and strategic. Now, let's dive into what KPIs in Power BI are all about. Here, let's define KPIs and show you how to visualize them in Power BI. So, KPI, which stands for Key Performance Indicators, allows you to assess how effectively your company meets key business objectives. Power BI KPIs track key metrics like sales, profit, or satisfaction against targets. They show actual values, goals, and trends using visual indicators, enabling quick insights and informed decisions. Now, let's look at the advantages and disadvantages of using KPIs in Power BI. So the KPI advantages include monitoring the target. This KPI helps the organization monitor their performance in a visual manner. The next advantage is timely reports. With this KPI, the organization be able to check whether they can execute their plan or not. Then comes simplifying process. Modern businesses can use KPIs for their advancements of profit. Now, moving on to KPI disadvantages. Disadvantages includes like time taking. It does not offer information on which action can be taken immediately. Next, implementation. Do not try to overload with more than one data. Always start with simple implementation. So now we will demonstrate on how to use KPIs in Power BI. Now we will move on to the hands-on. So let's perform how to use KPIs in Power BI. First, we need to source the data. So go to Excel workbook and from here select the file. Click on that and here you can see the file I'll be using named Blinkit Grocery Data. So click on that and open the file. Now click on load to load my file and it might take some time to load. Now if you want to check if your dataset is loaded, look at the right side. Here you will see that your dataset is loaded. Okay, now on your right hand side you can see visualization. So from here we are going to select a graph. So from here we will be using KPI graph. So just click on it. So as you can see the screen, the graph is here. Now we need to add the values. So again on the right hand side you can see the value and these are the data set. Now we want to find the total sales value. So for that we will be using formula. So click on new measure. So as you can see the screen, the formula bar will open. Here we will type the formula. So I will rename the measure as total sales to find the total sales of the dataset using the formula. So basically we are using this formula to find total sales value based on sales target. So the formula here is we have total sales equal to sum. So under sum we are going to select the dataset name which is the Blinkit Grocery Data and we are selecting the column which is the sales. Now if you see on the right hand side the total sales column is created. Now moving on to next step, let us find the sales target where our sales target is set to 50,000. So let us follow the same steps. Click on new measure and as you can see the formula bar will open. Here we will type the formula. So this is our formula which is sales target equal to the target that we have set which is 50,000. So as you can see on the right hand side you can see the sales target column which is created. So under value we are going to add the total sales column. So just drag and drop it. Okay. Next, under the trend axis we are going to add outlet establishment year. So again we will drag that column as well and then under target we are going to add sales target column. So that's it. So as you can see the graph is ready. So this graph is showing the total sales and the sales target by outlet establishment year. You can choose charts based on your preferences. So if you want to display values more clearly according to yearly revenue, we recommend using an area chart. So on the right hand side under the visualizations, you can select this area chart. So again under x-axis I am going to select the outlet establishment year and under secondary y-axis I am going to select the total sales. Alright. So the only difference between the two charts is that the KPI chart does not display values based on the year, whereas the area chart displays value by year, making it easier to analyze the values. So one more thing to see here is both graphs are displaying the same values. Additionally, the dataset we are using includes data up to the year 2022, which is why the values are shown only up to 2022. Now, if you remember, the sales target was set at 50,000. So considering this, the sales have increased by 162.96%, which is why we see the tick mark on the graph. Now, to display values by year on the graph, we can use a slicer chart. And this allows us to filter and analyze data for specific years. So for that, under visualizations, I am going to select the slicer chart. So click on it and align it. Now again on the right hand side, you can see the field. So under field, I am going to drag and drop the outlet establishment year. So this way it will display all the years. And now go to format your visuals, and from here click on the slicer setting. Here you can see many options under style. So here by default we have between, so I am going to keep it as vertical list. So select the option, and again you can see the selection here, click on it. Here you need to disable the multiple selection. So just disable and it's ready. So why have we done this is because we can select multiple years to get values. So this is how you can select multiple years. Now as you can see, I have selected the year 2012 and 2014. So according to that, the data has been displayed. Now let us add effects to the charts. For that, go to format your visuals, and here under the general, select effects. So under effects, let us select the visual border. So under visual border, let us select the color of your border. So I'm going to keep it black, and then you can also increase the rounded corners and also the width, and that's it. Now you can also enable the shadow. So that's it. If you want to add more effects, you can do it. So for now, I'm just going to keep it basic. So once you've added an effect to the chart, there's no need to make changes to each one individually. So you can simply use the Format Painter to automatically apply the same effects to other charts. So click on Format Painter and click on the chart to apply the effects. Well, that's it. So KPI Visuals combine numbers, trends, and goals to tell a dynamic story. They convert raw data into actionable insights, guiding you to success with each click. Consider them as a compass, keeping you on track with your goals and adapting in real time to your decisions.
Let's move ahead and talk about what are slicers in Power BI. Slicers in Power BI are the simple forms of filters that play a key role in designing customized charts and reports on the Power BI desktop. Now, these slicers play the most crucial role in really creating comparative charts or customized reports. Also, Power BI slicers act as an alternative solution in filtering the narrow portions of data sets that are represented in the form of other visualizations in a particular report. For example, the image on the screen has a dashboard on it, right? It has many visualizations that are grouped together in one page. Now, what slices can really do is it filters the narrow portions of the data sets that are presented in the form of visualizations in this particular report. Now, slices in Power BI can also be thought of as on-canvas visual filters. The slices really enable a user to sort and filter a packed report and view only the information that they want. Now, unlike filters, the slices are present as a visual on the report and let a user select values as they are analyzing the report. Now, let me explain again with another example. If you have a sales analysis report, you can make a slicer for years. Now, from that slicer, you can select the year for which you want to see the sales metrics. The report visuals will automatically change, showing the information for that particular year. We will understand slicers much more when we understand when to really use them. So, when do we use slicers? Now, slicers are a great choice when you really want to display commonly used or important filters on the report canvas for easier access. It also makes it easier to see the current filtered state without really having to open a drop-down list. You can also filter by columns that are unneeded and hidden in the data tables. And finally, you can create more focused reports by putting slicers next to really important visuals. Power BI slicers do not support the following options, that is input fields and drill down options. You can really use a slicer in your Power BI when you aim at doing one or more of the things that are mentioned below. That is when you want to easily access important and frequently used filters by putting them on the report canvas. You can also use slicers when you want to view a focused report by placing the slicer right next to essential graphs and charts. This I've already mentioned before. Slicers also easily allow you to view all the currently applied filters on the report instead of going to the filters drop-down list.
It also helps you to show unneeded or hidden or less used columns, but keep them on for the users in case they need to use them for further analysis. Now that we know when to really use slicers, let's move ahead and install PowerBI Desktop. So on my browser, I'm just going to search for PowerBI Desktop. The second link that appears on your search engine that says download Microsoft PowerBI Desktop from official Microsoft is what we need to click. This will immediately redirect us to a page where we can select our language and click on download, and this will allow you to choose the download you want. Now I want to download the PBI Desktop Setup x64 version, so I'm just going to click next, and this will automatically download the executable file for me. Now once the executable file is downloaded, I'm just going to open this. You can just select the language that you'd like to use Power BI on. I'm just going to look for English really quickly, and I'm going to click next. Now you can see that it says welcome to the Microsoft Power BI Desktop Setup Wizard. I'm just going to click next. I'm going to accept the terms, and I'm going to click next. This will allow you to install Power BI Desktop onto this particular location. If you'd like to change the location, you can do that, but I'm just going to let it be, and I'm going to click next. To begin the installation, you can just click install. Since I've already installed Power BI Desktop onto my local machine, I'm not going to click install. So once you click install, it will download automatically for you, and you can finish the setup, and it will also create a desktop shortcut from where you can access your Microsoft Power BI Desktop. Okay. So once you download your Power BI Desktop, this is what appears initially. From the welcome screen, you can see that you have an option that says get data, and you can also see the recent sources that you have worked on. That is, you can open your recent reports. Also, you can open other reports or select other links. Okay. You can select the close icon to close the welcome screen. Now, alongside the left side of the Power BI desktops are icons for the 3 Power BI desktop views. The first one is a report, the second one is data, and the third one is model from top to bottom. Now, the current view is indicated by the yellow bar along the left, and you can change views by really selecting any of the icons. Okay, see, you can see that the views really change. We are going to switch back to the report section. If you're using a keyboard navigation, you can simply press Ctrl plus F6 to move focus to that section of buttons in the window. Now, to see the many types of data sources that are available, simply click Get Data, and you can click More in the Power BI Desktop Home tab. And in the Get Data window, you can scroll to the list of all data sources that are available. Okay, you can see that there are a lot of data sources available. So here you can see that you can connect to a couple of different web-based data sources. You can get data based on file, database, okay, and Power Platform like Power BI data sets, Power BI data flows, Azure, and also online services, and finally others. Okay. But if you want to view all of the data sources that you can connect to, you can just click the all option and check out everything. Once you select your data source from where you'd like to import it, you can just click connect. But since we have no data sources of now, I'm just going to click cancel. So in Power BI Desktop, the report view, that is what we are currently on, you can build visualizations and reports. Okay. The report view has mainly 6 areas that I would like to discuss. The first is the ribbon at the top, which displays common tasks that are associated with reports and visualizations. Like you can import your data set, you can directly import data from a Microsoft Excel workbook. You can also create a live connection to data sets in Power BI service, that is cloud service. And you can also import data from an SQL server database. You can enter data by yourself. Okay, I'm just going to show that to you guys. You can add how many ever rows you'd like to. You can add various columns, and you can create your own data set. Okay. You can also check out the recent sources that you've been working with. You can transform data. You can create new visualizations. You can add text box. You can add more visualizations. You can really use these common tasks to associate and work on your reports and visualizations. The second main part is the canvas area in the middle, where visualizations are created and arranged accordingly to the user. The third area is the Pages tab, at the bottom, which lets you select or add report pages. So if you click the plus icon, it will create a new page for you. If you want to delete pages, you can click the cross button and delete the page. Okay. The fourth area is the filters pane. You can see that here on the right hand side. And in this part of the session, you can filter data visualizations. That's the advantage. The visualizations pane is where you can add, change, or customize visualizations and really apply drill through, right? There's several visualizations that are available, like stacked bar chart, you have stacked column chart, you have pie chart, you have donut chart, you have gauges, and you have world maps, and you have many visualizations that are really available from where you can select. Okay. And the last part, or the last section of the report view, is the fields pane, which really shows you the available fields in your queries. You can drag these fields onto the canvas, the filters pane, or the visualizations pane to create or modify visualizations. So this part of the pane allows you to load data. So once you click get data and you import your data into Microsoft Power BI, the data set will be available here. You can see the different tables that are available in your data set, and all of that information can be available in the field section. Okay. Once you get that, you can drop these fields onto the canvas part, that is the filters pane or visualization pane, and really play along with it. Now, what you can really do is you can expand and collapse the filters, visualizations, and fields pane by selecting the arrows at the tops of the pane. Okay, collapsing the panes provides more space onto the canvas to build really cool visualizations. You can also check out the insert option, which allows you to insert a new page. You can also add new visualizations. You can add text box, buttons, shapes, images, all of that. In the modeling section, you can just add a new table. You can add new parameters. You can select languages. You can change your languages. And in the view option, you can select a theme that you'd like to work on, right? There's several themes, like, for example, in PowerPoint, you have different themes that you can choose from. The same way, Microsoft Power BI Desktop also allows you to choose various color themes, and you can also, customize your own theme according to how you'd like to. The page view allows you to fit your page the way you'd like to. If you want to fit it to width or you want to put in a size, you can do that. And the mobile layout is another interesting option, which allows you to create your dashboard or reports according to your mobile layout, okay? According to how a user or how people can view it on a phone. You can also add grid lines, you can snap to grid, and you can automatically lock all objects in place to put them as where they are. And there are many more options like filters, bookmarks, selections. All of that is not really necessary to learn right now. The help option, on the other hand, allows you to check out training videos. It allows you to check out documentations. You can also check out examples from sample data sets from, the official website. And also you can interact with the community. You can read blogs. You can submit an idea. All of that can be done in the help option. Now, the interesting part is that once you create your report, you can definitely share it with others. There are many ways to share your work. You can distribute the report.pbix file like any other file. You can upload the .pbix file from the Power BI service, or you can publish directly from Power BI Desktop to the Power BI service. But you must have a Power BI account to be able to publish or upload reports to Power BI service. Now, to publish to the Power BI service, what you have to do is from the Home tab, you can select the Publish option, and you may be prompted to sign in to Power BI or to select a destination. And once it is completed, you can see that it will directly publish to where you want it to. So this is all for the interface of Power BI Desktop. I hope it's clear. I hope I have covered most of the parts that I need to for this introductory part. Now let's move ahead and create our slicer in Power BI Desktop. So now let's learn how to create our own slicer. I have downloaded the retail analysis sample PBIX file on the internet. So this slicer really filters data by district manager. So what we're going to do here is I'm going to click on file. I'm going to just say browse reports. And since I've downloaded the file already, I'm just going to open it. Make sure on the left pane you have selected the report icon to open the file in report view. And down you can see that there are 4 pages. One is the information, overview, district, monthly sales, and new stores. I'm just going to click on the overview page with nothing selected on the report canvas. Select the slicer icon in the visualizations pane to create a new slicer. As you can see here, we have the slicer option. I'm just going to click on that. Now that we've selected a new slicer, we can just go to the fields pane, select district and DM to populate the slicer. Now the new slicer is populated with a list of the district manager names and their selection boxes. So what we can do is we can just resize and drag the elements from the canvas to really make room for the slicer since it's overlapping with the pie chart. Okay, and now that I've made some room for the slicer so that you can see the district manager names, it's easier to figure out things now, okay? Now what we're going to do is we're going to select names on the slicer. Okay, you have Alan, you have Andrew, you have Brad, you have Carlos, Chris, and all of that. So you can just select the names and you can notice the effects on the other visualizations on the same page. Okay, so you can just select Andrew for now. So you can notice the effects on the other visualizations of the page automatically, okay? And if you want to select more than one name, you can just click on the control button and you can see the changes immediately. Now, if I go to the visualization pane and select the format section here, there are many options to really describe them all here. You can experiment and create a slicer that works best for you. So this is exactly where your next topic comes into picture, that is to format your slicers. Different formatting options are available depending on the slicer type. Now, if I click on general option, you can see there's option that says orientation, right? So here by clicking on the horizontal orientation and responsive layout, you can produce buttons or tiles rather than, standard list items and make slicer items resized to fit different sizes and layouts. So that's what the option really allows us to do. You can now see that the names are given in terms of tiles. Now with the district manager slicer selected on any page in the visualization pane, you can select the format icon and to display the formatting controls. You can also select the drop-down arrows next to each other to display and edit the options. You can see this page information, this page background, wallpaper, filter pan, etc. There are many options that you can really, play around with. So this helps you really format the slicers. Now you can sync a slicer and use it on any or all pages in the report. Now in the current report, the overview page has a district manager slicer. But what if you also wanted that slicer on the new stores page? The new stores page has no slicer. Now with the sync slicers panel, you can sync the district manager slicer to these pages so that the slicer selections on any page affect visualization on all three pages. You can do this by clicking on view and there is a sync slicer option. Now I'm just going to go back to my overview page and select the DM slicer. So once you select this, you can see that the sync slicers, it will show you what all pages have the DM slicer. Okay, because you've already created a district manager slicer on the overview page, the sync slicers pane appear as follows. Okay, now in the sync column of the sync slicers pane, select the overview district monthly sales and new stores page. Okay, this selection, what it really does is it causes the district monthly sales slicer to sync across all of the three pages. So what I'm going to do is I'm going to select all of these. Once that is done, we can observe the effects of syncing the slicer and making it visible on other pages. Now, if you move to the district monthly sales page, you can notice that the district manager slicer now shows the same selection as on the overview page. That's how easy it is to really sync slicers on other pages of your report. Now that we know how to format and create our own slicers, let's move ahead and check out some of the limitations of Power BI Slicer. So there are several disadvantages of slicers in Power BI. We're going to be discussing each of this. First one, there is no support for input fields in Power BI Slicers. Second one is there is no support for visual level filters in Power BI Slicers. This is really important. for certain people when they're working on different kinds of data set. You can also not be able to pin a slicer to a dashboard. This is very, very bad. You can pin your visualizations to the report, but you cannot pin a slicer to the dashboard. The next disadvantage is that the slicers do not support and work with measures, or nor do they support drill down in Power BI report. And also, the data models imported in Power BI and used in slicers do not have the time zone information, although you can convert a local time zone into UTC using the query editor in Power BI desktop. So these are some of the limitations of Power BI slicer.
Are you ready to transform raw data into powerful insights? Create stunning dashboards, uncover hidden trends, and make confident data-driven decisions. Whether you're a beginner or an aspiring data analyst, learning Power BI can lead to exciting career opportunities in business intelligence. So in this video, we will discuss the importance of Power BI and how to retrieve data from SQL Server and how to create an interactive dashboard from scratch. So let's get started. Let us understand what is Microsoft Power BI. Well, Microsoft Power BI is a business intelligence tool that enables users to visualize, analyze, and share data using interactive dashboards and reports. It connects multiple data sources, converts raw data into useful insights, and allows for the real-time decision making. So now, we will see how to import data into Power BI using a PostgreSQL database. PostgreSQL is very similar to SQL and much easier to work with. First, make sure that you download PostgreSQL. So go to Chrome and search for PostgreSQL and then click on download. And here you will see many options. You can also download it for Mac, but I'm going to select for the Windows option. Click on it and click on the download installer and then click on Windows. So the download will start. So once it's get downloaded, click on it. And here you will get this option. Just click on next and it will show you the path where it will be downloaded. So click on next and then it will ask you for a password. So you can type any password, but make sure to remember this password as it will be asked while working with SQL. And again retype the password and click on next. And then it will show you the port number. Please do not change it. Just click on next for further steps. And here click on next and installation will begin. And it will redirect to this page. Click on finish and over here choose PostgreSQL and then click on next. You don't have to make any changes to this, just click on close it. Now let's search for pgadmin and this page will appear. On the left hand side you can see an option as servers, so click on it and below that you can see PostgreSQL. Click on it. So once you open it, it will ask you for the password. So make sure you enter the same password that you used while installing it and then click on OK. Now you can see an option called database and below that you can see PostgreSQL. Select that and click on query tool. So first we have to create a database. So type create database and I will name this database as credit card DB and click on run. Now refresh the database. You can see that the database has been created. Expand it and you can see the option as table. So click on it and you must create columns within the table. So type create table and I will call this table customers. Now I will copy the column names from the CSV file that I'll be using to create the dashboard and make sure you enter the column name and data type. So if you know how to use SQL, you will be aware of the data type, but do not worry. I'll make sure to provide you with the file and the drive link that contains the CSV and SQL files. After entering all the column names and data types, click run to see that the table has been successfully created. Now, click on the table and refresh it. You should see the customers table below. Click on it and type select star from customers to extract the data from the columns and then type copy customers from .csv within the colon. Now here copy paste the location where you have saved the CSV file and then type /customers and then type delimiter and CSV header. Now select the first line and run it and you will see the output below. Now open Power BI, click on the options to get data there and you will get the options to search for PostgreSQL. So click on continue and it will ask for the server and database. Give the server name as localhost and the database as credit card DB and click on OK. Then it will ask for a name and password. So to do so, go to the PostgreSQL and click on it. Then go to properties, search for connections. And over here you will see username. So copy it and paste it in the PowerBI username column and give the password same as you have given in PostgreSQL. And next click on connect and the navigator will open. Select the file and over here click on load. Now you can see that the file has been loaded into the Power BI. So this is how you can import data into Power BI. So I hope so far it's clear now. In the same way you can import the other datasets as well. But in case you're facing any error while importing dataset using PostgreSQL, then just go to get data and from here you can select text or CSV if your file is in text or CSV format. So just click on it and select your dataset and then click on open. And once it's connected, you can just simply click on load and it will get imported. And I have already imported using the PostgreSQL. So as you can see on the right hand side, these are the datasets that I have imported. If you want to view, simply click on it, go to table view and this is how it will be presented. So these are my credit card transaction datasets. So if you want these datasets to practice, then I will provide this dataset in the description box below. So now let's start creating an interactive dashboard. So first let us name the dashboard. So for that I'm using text box and over here let me type bank details dashboard. So I'm going to increase the font size and here I'm going to select the font style as well. Alright, now that we have named our dashboard as a bank details dashboard, so now let's calculate the total revenue for each quarter based on the transaction activity. So to create a column, select the dataset and to this dataset we are going to create a column. So click on table view and over here select the new column. Alright, so to create a new column we will be using a DAX function and here is the function. So the function is total revenue equal to credit card annual fees plus credit card total transaction amount plus credit card interest earned. Over here the credit card annual fees, this represents the fees charged to credit card holders for using the card. So many banks charge an annual fee which contributes directly to revenue. Next is the credit card total transactional amount and this refers to the total transaction amount spent by the card holders. So while this amount itself is not direct revenue, financial institutions earn from transaction fees charged to merchants. Next is the credit card interest earned. So this is the interest charged to the customers on outstanding balances if they don't pay their full dues on time. So it is one of the largest revenue sources for credit card companies. So now let me explain you how it works. So the credit card companies earn revenue from multiple sources, including the fees, transaction charges, and the interest. So this formula adds up these three key revenue components to calculate the total revenue generated by the credit card business. So now once you have typed the formula, just click on the commit and there you go. You have created a new column called total revenue. And as you can see, this data type is in decimal numbers. So let us change it to whole number. Click on S and there you have it. Okay. So now let us go to report view and over here click on the visualizations and from here I am going to select the line and stacked column chart. So click on it and here you have it. And on the right hand side here you can see the x-axis and y-axis. So here you need to add the columns. So in the x-axis I am going to drag and drop the quarter and in the column y-axis I am going to drag and drop the total revenue and then in the line y-axis, we will drag and drop the total transaction amount. So now let us add the border to this graph, okay? So for that, let's go to the format your visuals and here let's go to the general and I'm going to add some effects. So for that, choose the effects. Under the visual border, turn on and from here you can select the color. So I'm going to keep black and then the rounded corner you can increase from here, maybe 3. And then also you can increase the width. So I'm going to keep 2 and you can do it according to your needs. And now this is ready. And now let's go back to the visual. So under the visual, here you can scroll down and here you can see the data labels. So this you can turn on. So this will give the accurate value. Okay. So as you can see, it's giving the accurate value. So if it is on, this is how it looks. So if it's on, it gives the accurate value. And this you can only turn on if you want to show the accurate value on your graph. And now if you don't want these titles to be visible on your graph, then simply go to x-axis, and under x-axis you can turn off this title, and then similarly go to y-axis and then here off the title. And this is how it looks. Now to hide these values, go to secondary y-axis because it's present in y-axis, and you can simply go to value and off it. Okay. And you can also off this legend because this will hide the values that were present here. So as you can see, I just want to hide this, so I'm going to off it. Okay. Now you can also rename the title of this graph. So go to general and click on the title. Over here you can rename it. So let me keep it as, let's name it as total revenue transactional amount. Alright. So let's align this to center, and then let's make these grid lines visible. So for that, go to visuals, and here you will see these grid lines. You can on it. So once you off and on it, you can see the difference. You can also select the color. So let me choose black so that it will be much visible. Okay. So next I'm going to take card. So I'm going to use card to present the total revenue. Okay. So to present the total revenue, inside this field, you need to drag and drop the total revenue column. So that's it. And this is done. And the card will present the sum of the total revenue. But here you can see that the total revenue is in decimal format. But if you want this number to be presented in whole number, then simply click on this, go to visuals, and then click on general. And inside this, you can see the data format. So once you scroll, you can see the format option here. So over here, select the whole number and it will be presented in whole number. And if you want to keep just as a total revenue, then simply go to field and over here you can edit it. Once you delete, enter it and it will be edited. Now if you want to add visuals to this card, then simply go to Format Painter and then click on it. Now I'm going to present the annual fees as well. So similarly, copy it and we'll paste it. So over here, under the fields, for the previous card, we have added total revenue, but now we want the total fee. So remove this and over here, drag and drop the annual fee. So I want the annual fee to present. So I'm going to add annual fee and you can similarly edit it. Okay. Now, if you want to show the income, then we'll try the same way, copy paste it. So we have another card here and let's go to the another data set, that is customer data set. And in this, remove the field and drag and drop the income. And that's it. Alright. Now let's create another column such as income by person. So for that, I'm going to select the customer data set, go to table view, and over here, I'm going to add a formula. Now let us create another column which is income by person. So to create this, I'm going to select the customer data set and over here, click on the new column because we're creating a new column. And again, we are using a DAX function. So here is the formula. If you closely look at the formula, here we have the switch true function. So this structure allows switch to act like an if-else statement. So it evaluates condition sequentially and returns the first matching result. Then we have the income groups, which is low, mid, and high. So first we have the low, that means if the customer income is less than 35,000, it is classified as low. Next we have the mid, that means if the customer income is between 35,000 to 74,999, it is classified as mid. And then we have the high, that means if the customer income is 75,000 or above, it is classified as high. And by default, we also have unknown, which means that if none of the condition matches, like for example, the customer income is blank or contains an error, it will return as unknown. I hope the formula is clear. Now let us click on commit and there you have it. So now let us go to report view and here let us add the chart, that is stacked bar chart. I'm going to click on it, and now let us add the columns, that is x-axis, y-axis. So once you click on this chart, over here you can see y-axis. So I'm going to add the columns. So let's add the column that we have just created, which is the income by person. Drag and drop. And next, in the y-axis, go to the credit card data set, and from here let us drag and drop the use tip, and in the legend you can drag and drop the expenses type. So there you have it. So if you want to add the visuals, again same way. So now if you want to add the formats to this, just click on the previously created chart, go to format painters, and then click on this, and it's created. So now if you want to change the title of this chart, so let's go to the format visuals, and under general click on the title. So let's name it as use tip by income and expense type. Next, let us create another chart which will represent the total revenue by card category. So for that I'm going to select the stacked area chart. In the x-axis we will drag and drop the card category, and in the y-axis let's drag and drop the total revenue. Now this chart is representing the total revenue by card category, and here the card category are blue, silver, gold and platinum. Okay, so if you want to present the total revenue by something, then this is how you can do it. So this particular chart I'm going to present the total revenue by card category. Next, let us add another chart which is the donut chart. So over here in the legend we are going to drag and drop the education level, and then in the values income. So this particular chart we are using to present the income by education level. So here are the education levels such as graduate, high school, unknown, uneducated or postgraduate, doctorate, etc. Okay. So for this, let me add the visuals. Similarly, I will click on this and then select the format paint and add it to this. And let me also change the title. So for that, let's go to format visuals. Under general, let's select the title, and over here, let's keep it as total revenue by card category. Alright. To add the same visuals, we can also click on this. First click on this, select the format painter, add to this, and there you have it. Now if you want to present these numbers in just the percentage, then simply click on this, go to visuals, and under the detail labels, under the label contents, you can select the percent of total. So here you can only present the percentage. Now let us move forward and create another chart. So now I am going to select the tree map where I am going to present the total revenue by gender. So under the category, drag and drop the gender. So here is the gender column, and there under the values, you can select the total revenue. So simply drag and drop it, and there you have it. Now to present the values, you can go to the format your visuals, and under the data labels, you can turn on this. So over here, you can present the total revenue for male and females. So let's change the title. Let's go to the format your visuals, and under general, click on the title, and here I'm going to keep it as total revenue by gender, and let's align to center, and that's it. So similarly, let's edit this title. Go to generals, title, under title, let's remove this sum of, and let's only keep income by education level. Alright, so this is done. Now let's create another chart which will represent the total transaction by use tip. So for that, I am going to select the ribbon chart. So under the x-axis, let us drag and drop the use tip, and under the y-axis, let us drag and drop the total transaction amount. So now let us add another chart which is the table chart. So here we have the table chart. So let's select the table chart. So in this table, we are going to present the card category. So we are going to present the card category details and then the total revenue. Along with this, we are also adding the total transaction amount. Okay. So the table is ready. So let us add some visuals to it. So for that, again, let's select this, go to format painters and then add it. Similarly, we will add it for this as well, which we have missed to add before. Click on format painters and then click on it. And there you have it. Now to align things properly inside this table, let's go to the format visuals. So here you can see the style presets. So under the style you will have different styles. Currently it's in default, so I'm going to select the minimal. Okay, so you can see the changes, right? Now let us change the titles for this. So for that, go to card category. Let's keep it as card category. And then sum of total, let's keep it as total revenue, and then the total transaction amount. Okay. So to make this table more appealing, what you can do is go to the format your visuals, and under the visuals you have the grid here. So let's select the color as black, and then you can also keep the vertical grid lines. So first on this and then select the black color. So now you can see the grids are added to the table. Now you can select the column headers, and over here you can make these headers to be as bold, and then you can align it to center and select the text to be black. Let us also select the specific columns over here. On this, apply to header and also apply to total, and then align them to middle. So here you need to select the category. So we have done it for card category. Next, let us select the total revenue and then turn on and align it to center. Then next, again let us select the total revenue column and then turn on this, apply to header and apply to total, and then align it to center. So now let us add the visuals to the border as well. So click on this, go to format painter, and then click on this title as well. Okay, so the border is created. Now let us name this page. I'm going to name it as bank detail dashboard itself. Now to represent the values in total, under the format page, here you will see the canvas setting, right? So under the type, let's click on the tooltip. So here we have it. So now we are going to add the pie chart. So here we are adding the pie chart to present the values in total. So now under the legend, let's add the card category, and under the value, you can select the total revenue. So now let us edit the title. So for that, go to the visual format, go to generals. Under the title, you can make it as total revenue by card category. Okay. Now let's add a background to it. So for that, click on this and go to your visuals, and over here you can see the canvas background. So here you can select any color that you want. So let me select this, and then transparency you can decrease. Now let us go back to the bank details dashboard. So let me add the format painter to this, and now if you want to present the tooltip, just click on that chart, go to the format your visuals, and under general you will see this tooltips. So click on that and select the page here, and that's it. Now let us add background to it. So for that, let's go to the visualization, and here under the format your report page, let's go to the canvas background, and here you can browse it. So I'm going to select the background and then decrease the transparency. Okay, and there you have it. Again, let us go to the canvas background, and here under the image fit, it's in normal, so let us make it as fit, and this is done. So the dashboard is ready. So over here, if you want to check the total revenue of a male, then according to that you will get all the details here. If you want it according to female, then again here you have it. So this way you can select and you can get the values. This is how it is. And if you want to see the sum of total revenue according to the card details, and this is how you can do it. So over here, if you want to see this total revenue, total fee or the income according to the card category, then simply click on it, and as you can see, the data will change. So in every card you will see there will be a change. Okay, so this will give the values according to what you're selecting. So if you want to see the total revenue by gender, then simply click, and then here you can see the difference, right? So here you will get the total revenue according to the gender that you have selected. So previously we created a tooltip, and this is how it works. If you want to see the income by educational level, and if you want to see the total value for it, then click on it. So it will present the value in total. Our dashboard is ready and you can create according to the datasets that you have. So I just took a sample dataset. So from here I have created a dashboard and you can create according to the datasets that you have. Have you ever wondered how to bring your data to life with interactive maps? Imagine highlighting sales hotspots across continents, tracking customer location in real time, or visualizing business performance at a glance. In today's data-driven world, location intelligence is a game changer. And Power BI makes it easier than ever to turn raw geographical data into compelling visual insights. So first, let us understand what are maps in Power BI. Well, maps in Power BI are interactive visualizations that help display geographical data, making it easier to analyze location-based trends and patterns. They allow users to plot data points using locations such as cities, states, or coordinates, providing deeper insights into regional performance, sales distribution, customer demographics, and more. So, by leveraging Power BI's mapping capabilities, businesses can transform raw data into actionable insights, uncovering trends that might be overlooked in traditional reports. Whether tracking sales across different regions or optimizing logistics, maps offer a compelling way to visualize and interpret spatial data effectively. But why use maps in Power BI? Maps in Power BI help visualize geographical data, making it easier to identify location-based trends, track sales, and analyze customer distribution. They enhance data storytelling, improve decision-making, and provide deeper insights into regional performance. But how to use maps in Power BI? Now, let us see how the maps will visualize the data in Power BI. Now, let's get started. But before we begin creating a map in Power BI, we need to ensure that the map settings are enabled. So for that, let us go to File. From here, select Options and Settings. Then click on Options. And in the Security section, scroll down to find Map and Filled Map Visual. So here, ensure the setting is turned on, and if it's not enabled, the map option won't work. So once enabled, click OK and close the window. Next, we need to import our dataset into Power BI. So for that, go to Get Dataset and from here select text or CSV file as our dataset is in this format. Now select the dataset and then click on Open. Now let us click on Load to add the dataset into Power BI. And there you have it. So once the dataset is loaded, go to the table view to review the dataset. So to do that, click on the dataset and go to table view, and this is how you can view your dataset. So here you will see columns such as order ID, country, state, city, region, latitude, longitude, and sales. So to create a map visual, ensure your dataset includes columns like city, state, country, latitude, and longitude. Now go to report view, and in the visualization panel here you can select the map visual. So from here click on the maps. You can resize the map visual for better visibility. Alright, now let us drag the country column into the location field. So as you can see, here are the columns of our dataset. So these are the columns, and here we are going to add the country under the location. So just drag and drop the location. So basically what we are trying to do is we are going to find out the total sales across different countries. Okay, so now here you will see this blue color bubbles, right, which are appear on the map, and these are representing each country in your dataset. So for example, here as you can see, this is India, and here Germany, France, UK, and this way it's representing the countries. Next, let us drag and drop the order ID column into the bubble size field. So here we have the bubble size. So let us drag and drop the order ID. And now, as you can see, you will get the country and the count of order ID, such as 83. Similarly, you can see for other country as well. Here you will see India, count of order ID is 105. So as you can see, the bubble sizes will now vary based on the number of orders in each country. Okay. Now, to add more details, let us drag the region column into the legend field. Well, the bubbles will now be color coded based on the region categories such as North and South. Now as you can see, if you just click on this, you will see north and south. So this is north and this is south. Here it is representing light blue and dark blue, which is north and south. Similarly, you can see for India, this is South India and here you have the North India. And it's also giving the count of order ID such as 56 in South and 49 in North. Now let us drag the sales column into the tooltips field. Okay. So here you will have the tooltips field. In this we will drag and drop the sales column. So now it should show the sum of the sales, right? So here you can see for Australia, you have the sum of sales displayed. Again, similarly, you can see for other countries as well. Here you will see for India and Europe. Similarly for Canada as well. Okay. Now, when you hover over a bubble, you will see details like the country, region, order ID count, and also the total sales. Now to improve the map's visual appeal, go to the Format Your Visuals. And here click on Map Settings. And from here, under the controls, you will see these zoom buttons. So you need to enable it. So in this way, you can zoom in and zoom out. So this will become easy for you to find out the sales. Now to change the map style, go to the Style and select your preferred option, such as you have Arial and it looks like this. And if you want to select dark, just click on it. Or if you want light, then just go for it. And this way you can change the style of your map for better visibility. Now let me select the light. Okay. And that's all about the maps. You can also add title for your map. So go to General and here click on Titles. From here, let me keep it as Sales by Country and Region. And let me make it bold, and also you can align this to center. You can also increase the font size of your title. Okay. For a professional look, you can also add borders. So for that, let us go to Effects. Now you can also go to Visual Border and you can enable it. And you can also set the border width to be 2. And that's how it looks. And you can also enable the shadow effect to enhance the map's appearance. So this is how it looks. And that's it. Now you have a well-structured map visual displaying total sales across different countries and regions. If you would like the dataset used in this demo, let me know in the comments and I'll be happy to share it with you.
Do you need help with the usual Power BI dashboards and looking for a change? It's time to break free from the routine and explore a fresh approach to creating them and unlocking new possibilities. Stick around until the end of the video to see how it's done. So here I have taken the screenshot to just brief you out about the demo that we're going to show. The screenshot here is about the motorbike sales dashboard. So sales done here is 15 million. Then we have the growth percentage that is 17%. Then pre-sales showing it 12 million. And lastly, the total budget having it 17 million. We have also inserted the images of the motorbikes as well. The importance of the dashboard is, dashboards in Power BI are crucial for visualizing key metrics and insights in real time, helping businesses monitor performance, identify trends, and make data-driven decisions quickly and efficiently. Now let's move on to the hands-on session to show you how motorbike sales dashboard is created. For that, first let's go to Excel workbook, click on it. You can see a folder that I've created, that is Power BI dashboard. So inside that folder, I have a lot of files that has been created. So I have icons and images to just make my dashboard more interactive, and also I have used this motorbike data set, which gives me the data set of the motorbikes as well. So in case if you want this file or this data set, please comment below so I can provide you this. Now let's click on this data set. Click on Open. So here you can see a navigator on the screen. So just click on the motorbike data set that's given here and load it. Now to check whether our data set is loaded or no, Here, towards the right hand side, you can see the data. Under that, you can see that our file motorbike data set is loaded. Now, let's go to the table view on the left hand side of the screen. So once you click on the table view, it gives you the columns and its values of the motorbike data set. Now let's go to the report view. So let's move on to the first step. Now let's name the dashboard first. For that, let's click on text box. So here you can see that the text box is appeared. Let's write the name for it, or the title. So here I will be giving it as Motorbike Sales Dashboard. You can give your preferable titles as well. Now let's increase the font size. As you can see, it's not visible. I'll give it to 24, no, to 20. I think that will be enough. And let's make it as bold as well. And let's align it. Yeah, so there you go. So here is how you can easily create the title for the dashboard. Now let's create the graph for the sales amount. For that, let me choose a chart that is card. And let's align it, and let's even give the values for it. So for the fields, I'll be giving the values as sales amount. So here you can see that my graph is created now. So here you can see that our value of the chart is in decimal. So let's change it into whole number. For that, let's go to model view. So once you click on model view, here you have motorbike data set given on the screen. When you just scroll down, you can find the sales amount. Click on it. So after clicking on it, you can see properties appearing. So under properties, you just scroll down. You can find formatting. Under formatting, you have format. So let's change that to whole number. You can give your preferable format as well. And let's check in our report view whether it's changed. Yeah, so there you go. You can see that it is changed to the whole number. Let's align it. So now I don't want the title to be sum of sales amount. So let's also change the title by just double clicking on the fields. So let me just delete sum of and just make it short, keeping it as sales amount. Click on enter. So here you can see that our chart is perfectly created. Now I will teach you how to insert the icon. So for that, let's go to insert. So under insert, we have image. Click on image. In images, we have a file that we have already downloaded is icons and images. So in this file, I have downloaded the necessary icons and images. So let me pick the necessary one here. I will be clicking on the sales and click on open. Now let's align it and keep it near to our chart. So now you know how to insert an image in a dashboard. Now let's find the growth value. For that, we should know the previous year sale and the current year sales. So we can calculate the growth value for it. Now let's go to new measure. Click on it. I will be naming the new measure as the current year sales. So here I've applied the formula to get the growth percentage. So we have a sum function. This part computes the total sum of the column, that is the sales amount from the motorbike dataset. Then we have is a calculate. So the calculate function modifies the context in which a calculation is performed. In this case, it applies a filter to restrict the calculation to rows where the year of order date matches the current year. The next we have is the year function. It extracts the year from each value in the order date column. We also have given a year function. That means it extracts the current year from the system's current date. This filter checks if the year of each order date matches the current year. So now let's click on commit. So here you can see under data towards the right hand side, the current year column is created here. So now let's drag and drop it onto a panel. I'll change the graph into the card. So here again you can see it's given in decimal. So my formula actually consists of the current year sales and the previous year sales. So here I've already given you the current year sales. So now let's even add up the previous year sales as well here. So as you know, to find the growth percentage, I have to add the current year sales and the previous year sales. So now by using the formula for the current year sales, I have shown you that we have got 1.46M. So now let me again give you the previous year sales formula and also let us see how it works. Now again, let's go to new measure. Let's change the title to previous year sales. So here I have written the formula for the previous year sales. So some function here which notifies this part sums up all the values in the sales amount column from the data set. It calculates the total sales without any filters. Next we have the calculate function. The calculate function modifies the context in which the data is evaluated. It applies filters or changes the context of the expressions inside it. In this case, we have the sum motorbike data set with the sales amount. The next we also have the year function with the motorbike data set in the order date. So this filter ensures that only rows where the year of the order date is equal to the previous year are included in the calculation. Another one we have is the year to date function, which gives the current year based on today's date. The last one we have is a year to date -1, which calculates the previous year. Now let's click on commit. Here you can see that the previous year sales column is also created. Now let's calculate the growth percentage. Let's again go to the new measure and change the title to sales growth percentage. So here you can see that I have written the formula for the sales growth percentage. So here we have written a divide function. This function divides the numerator by the denominator. If the denominator is 0, it returns the alternate result. In this case, it is 0 instead of throwing an error. So then we have here is a current year sales minus the previous year sales. It represents the total sales of the current year. This is likely a measure or a column in your data set that sums up the sales value for the current year. Then that we have minused with the previous year sales, which represents the total sales for the previous year. This is another measure or a column in your data set that sums up the sales value for the prior year. This full expression calculates the percentage change in sales compared to the previous year sales. If previous year sales is 0, to prevent division by 0, the result will be default to 0 itself. Let's click on commit. And here you can see under the data, we have the column that is created is the sales growth percentage. Let's drag and drop it. Now you can see that under data, our column sales growth percentage is created. Let's drag and drop the column to a panel. So here you can see that a graph is created, but it is in decimal, which I really don't want it. So now let's go to model view. Similarly, in the motorbike data set, when you scroll down, you can see the sales growth percentage given. Click on it. So under formatting, we have format and change that format into percentage. Now let's go to the report view and check whether it's changed. Yes. So here you can see that it's given it as 17%. Now, as you can see that in our graph, our title is a little more bigger. So let's shorten it down. Let's delete the sales and the percentage and let me just keep it as growth. So now let's give a small icon for this. Let's go to Insert, Images, click on Grow. Let's align and keep it next to it. So this will just show you a visually appealing graph. Now let's find the pre-sales value from the dataset. For that, let's go to Home, click on New Measure, so we can write down the formula. Let's change the title again. Let me just give it as pre-sales. So here I have written the formula. In this formula, we have a calculate function which modifies the context in which the data is evaluated. In this case, it applies to the filter year motorbike data set to order data less than year today to the calculation of the total sales amount. Let's click on commit. So here you can see that a column is created as a pre-sales. Let's drag and drop it onto a panel. Let's not keep it in bar chart. So I will just change the chart to card. Similarly, I don't want it to be in decimal as well. I'll go to model view, click on pre-sales under the dataset and change the format. Let's change the format to whole number. Let's go to the report view and check whether it is applied. Yeah, so here you can see the decimal is removed and the whole number is implemented. Now let's again insert the image. For that, go to Insert, Image, and click on the preferable image that you need to. So here I have given it as coupon. Click on Open. Let me align it accordingly. Now let's find out the total budget. Even that contains a formula. So let's go to Home. Click on New Measure. Let's change the title as Total Budget. So here you can see that I have written the formula for the total budget. The sum function here determines that the function adds up all the numeric values in the specified column. In this case, it sums up the value in the column that is motor bike data set with the actual amount. Let's click on Commit. So here you can see by clicking on Commit, our total budget column is created. So now let's drag and drop it onto the panel and change the graph to card. Similarly, go to Model View for making it as a whole number. Let's go to Format and again change it to whole number. There you go. So here you can see that the total budget is 17 million. Now let's add the icon similarly. Let's go to Insert, click on Image and apply any preferable icon you want to. So I will be giving here as a calculator. Click on Open. So let me align the icon. Now let me group the value and the icon. So let me select the value and the icon together and just hit on Ctrl G so that it's grouped here. So it's easy for us to align as well. Similarly, let's do for others as well. Now let's align all of the values properly. Now let's find out the current year sales by segment. For that, let me choose a chart that is clustered column chart. Now let's add the values for the graph. So for the y-axis, I'll be giving it as current year sales. And for the x-axis, let's drag and drop the segment. Now let's align the graph. Now let's modify the graph a little. For that, I'll be going to Format Your Visual. Under Visual, we have x-axis. Let's click on it and let's change the font size. So I've increased it to 12. And let me off the title because I do not want the title. Now similarly for the y-axis as well. Under y-axis we have values. Let me again increase the size of the values and off the title. Similarly, let's change the color of the text for the x-axis and the y-axis. So let me go to y-axis and let's change the color. You can choose any preferable color you want to. So I'll be choosing black. Similarly for the x-axis, let me again choose black. Now to change the heading or the title, let's go to General, Title. In title we have font size. Let's increase the font size a bit and let's make it bold. And let's even align the title to center. Yeah. So that's how we create this graph. Next we'll find out the current year sales by subcategory. Let's select a chart that is the donut chart. So now let's give the values. So for legend, I'll be giving the subcategory. So let me drag and drop the subcategory for the legend. And for values, I'll be giving the current year sales. Yeah. So here you can see that a graph is created. Now let me go to Format Your Visual. So let me off the legend because I don't want any subcategories to be named. So here you can see that the modifications have been applied. Now let me go to the detail label as well. So under detail label, you have the label contents. So you have various label contents such as data value, percent of total, category data value and so on. So let me select the percent of total. So as you can see, the title is not bold. So instead of just again going and modifying it, let's use a format painter. So just select the previous graph and go to Home, click on Format Painter and just click on the latest chart that we have created. So now you can see that again we'll get back all the subcategories and everything. So let's again omit all of that. So let's off the legend. Now let's add the border to the graph. For that, let's go to General, FX. So in FX, we have visual border. So let's keep it in black itself. So if you want, you can use your preferable color as well. So let's increase the rounded corners and then also increase the width. So now you can see that a border of a graph is created. So in the same way, let us create the border for the current year sales by segment also. Let's go to General, FX, Visual Border. Let's on the visual border first and then increase the rounded corners, increase the width. There you go. Now let's create another chart that is current year sales by month. I'll be choosing the stacked column chart and let me put the values for it. So for the x-axis, I'll be dragging and dropping the order date. So here I only need the value for the month and not for quarter, day or year. So let's cancel the remaining ones. And for the y-axis, let me drag and drop the current year sales. So here you can see that my chart is created. Now I need the border for the chart. Let me do the Format Painter by clicking on the previous chart, clicking on Format Painter, and then just click on the latest chart. So here you can see that the border is applied. Let me just align it correctly. Now let's add an image. For that, go to Insert, Image. Click on the image that you have downloaded. So now let's align the image accordingly. Now align everything according to your preference. Now let's add the buttons. I will tell you why buttons are used for in this video further. So now under buttons, we have a lot like left arrow, right arrow and so on. So let me select the left arrow and the right arrow. So let's align them. So as you click on the month in the current year sales by month, you can see the changes happening in the sales amount, growth percentage, pre-sales and even the total budget as well. Now you know how this dashboard is created. So this is the home page of the motorbike sales dashboard. I will be also adding the additional dashboards according to the individual bikes, and even you can see the values varying accordingly. Now, down at the home page, you can see a page 1 written. So just right click on it. So let's click on duplicate to duplicate this page. So now let's change the image. So for that, let's remove it first. Remember, this is the duplicated page. So now let's go again to image and select the preferable image that we need to put in an additional page. So I have selected here, click on open. So I have chosen the Ducati bike here. So let's align it. Now let's even change the title for the dashboard. So I will be giving it as Ducati dashboard. Now let's add the border for the title. So let me just do the Format Painter from the previous graph. So here you can see that my title is containing a border. Now let's change the name of the duplicated page. Let me just write Ducati itself. Similarly, let's duplicate another page. And let's change the image of the bike. Let's remove it. And add another image. Let's add the Harley Davidson that I have already downloaded. Let's align it accordingly. Now let's change the title again. Similarly, let's even rename the page name. Now let's duplicate for another page as well. So you will follow the same procedure for the rest of the bikes as well. So let me select Honda. You can add a preferable bike as well. Let's align it. And let's give the name. And change the page name similarly. Let's duplicate again. You can put n number of bikes you want to. So let me select another image. That is Ninja. So let me change the title of the dashboard as Ninja. Similarly, the page name as well. So I will add the last page by duplicating it again and change the image. So this time I will be choosing Yamaha Now let's change the page name as well to Yamaha. So I will be adding a slicer here. So let's select the slicer from the visualizations. And let's take the subcategory as the value for fields. So now let's go to format your visual. Under that, slicer setting, style. I'll be making it to tile. Let's align it. Now let's do the format painter to get the border. So I will tell you why I have added the slicer here. So the slicer is a subcategory of each page that I've added. For example, let it be Ducati or Harley Davidson, Honda, etc. So when you click on each of the name, you will get the values changed accordingly to the page. Make sure you copy the slicer on each of the page that you have given. So let's close this dialog. So after adding the slicer for each page, when you click on the name of the bike, you can see that the values will change. That is the sales amount value or the growth percentage, pre-sales, and even the total budget might change. So now for example, here when you click on Harley Davidson, you can see that the sales amount is also changed, then the growth percentage, pre-sales, and even the total budget. Similarly, it will change for each of the bikes as well. This is the reason that we have used slicer here. So now let me show you the use of buttons and why have I added these buttons in the dashboard. When I select the button, under format button, you can see actions. Let's on the actions first. In actions, we have type. So let's make it into page navigation. That means it will navigate to each of the page. And let's also choose the destination for it. So I'll be choosing the destination as Ducati because once the page is in Ducati, if I click forward, it will move to the next page as well. So I have chosen the destination as Ducati because when I'm in the home page, it will navigate to my page Ducati. Now let's see how this button works. Press Ctrl, click on the follow link, and here you can see from my home page, it is navigated to the page Ducati. Similarly, you can do for the remaining pages as well. Similarly, I have added the navigation to all my pages as well. So now, to direct to my home page, let's click on the left arrow on the action. Let's keep the type as a page navigation and keep the destination as home. So once you click on it, you can see it will navigate to your home page. I hope you all have understood how to create an advanced Power BI dashboard project from the scratch.
Now let's start with paginator reports. And what are they? I assume some of you might have already used SQL Server reporting services. For them, paginator reports are not a new thing. For people for which this concept is new, these reports are called paginator reports because they are formatted to fit well on a page. They display all the data in a table, even if the table spans multiple pages, and hence given the name Pixel Perfect Reports. Because you can control the report page layout exactly and precisely as you need it to be. Paginated reports are based on the RDL report technology in the SQL Server reporting services and can have many pages to begin with. Now, paginated reports have their own design tool, which is in fact known as the PowerBI Report Builder, the tool we'll be working on today. It's a new tool that shares the same foundation as the tools you'd previously used to create the paginated reports if you have done so. In fact, for those of you who have used SSRS before, paginated reports that you created there in 2016 or 17 or in the Power BI report server on-premises services are all compatible with the Power BI service. Power BI service thankfully maintains backwards compatibility, so you can move your reports forward and then you can upgrade any previous version paginated reports. So Report Builder is your standalone tool for authoring paginated reports. Now, a single paginated report can have a number of data sources It doesn't have an underlying data model unlike your Power BI reports. So for the initial release of paginated reports in Power BI service, you create embedded data sources and data sets inside the report itself. You create reports in Report Builder on your local system, and if a report connects to on-premises data after you upload the report to the service, you need to create a gateway and then redirect the data connection. All right. Now, there are a couple of different sources you can connect to as of May 2020, which are the Azure services, Azure SQL database and data warehouse via authentication, Azure analysis services via SSO, SQL Server via a gateway, SQL Server analysis services again via a gateway, Power BI datasets, Oracle, and Teradata. Now, through this exercise, you can design your report, which basically means create paginated reports with matrix, chart, and freeform layouts. Add more to it by filtering, grouping, and sorting your data or adding formulae and expressions. You can create a report definition when you design a paginated report. You can view it via the Power BI service in a browser or the Power BI mobile apps. And finally, you can create a subscription to the same. Now, a couple of limitations and considerations that you have to understand. There are some features that aren't supported in this initial release. Firstly, pinning report pages or visuals to Power BI dashboards. I mean, you can still pin visualizations to the Power BI dashboard from an on-premises paginated report on a Power BI report server or reporting services, but you just can't do it on the service. Second, you cannot use document maps. Third, sub-reports and drill-through reports are also something you cannot do. You may consider using URL parameters with paginated reports to achieve the drill-through scenarios though. And one that I have mentioned before is that you can't use shared data sources and shared data sets. Hence, you have to create your own via embedding them in your report. So now that all of this is out of the way, let's go ahead and look at the different aspects in the report design view of paginated reports. Now, the report design view in the Power BI Report Builder is the design space for creating paginated reports, as the name suggests. You can publish it to the Power BI service, as I had mentioned before, and the design surface is at the center of the report builder with ribbons and panes around it. Now, the design surface is where you add and organize your report items. Now, basically, we're going to discuss in brief the panes you use to add, select, and organize your report sources and change report item properties. So first, you have your report data pane. Now, from the report data pane, you define the report data and the report resources that you need for a report before you design your report layout. For example, you can add data sources, data sets, calculated fields, report parameters, and images to your report data pane. After you add items to the report data pane, you can drag fields to the report items on the design surface to control where the data appears in the report. However, if you drag a field from the report data pane directly to the report design surface instead of placing it in a data region such as table or chart, when you run this particular report, you will only see the first value from that field. Okay, so this is one thing to keep in mind. Now, you can also drag built-in features from the report data pane to the report design surface. When rendered, these fields provide information about the report, such as report name, the total number of pages in the report, and the current page number. Some things are automatically added to the report data pane when you add something to the report design surface. For example, when you embed an image in your report, it will be added to the images folder in the report data pane. You can use the new button to add a new item to the report data pane, and not just one, you can add multiple data sets from the same data source or from different data sources to the report. Next, you have your report design surface. Now, this is basically your main work area for designing your reports. To place report items such as data regions, sub-reports, text boxes, images, rectangles, and lines in your report, you add them from the ribbon or the data part gallery to your design surface. There, you can add groups, expressions, parameters, filters, actions, visibility, and formatting to your report items. Now, the design surface size might be different from page size print area that you specify to print the report. Changing the size of the design surface will not change the print area of your report, no matter what size you set for the print area. The full design area size does not change, however, but you can definitely choose to display the ruler if you are in doubt. Next, you have the parameters pane. As the name suggests, with the report parameters, you can control the report data, connect related reports together, and vary report presentation. The parameter pane provides a flexible layout for the report parameters. Then you have the properties pane. Now, every item in your report, including data regions, images, text boxes, and the report body itself, has properties associated with it. For example, the border color property for a text box shows the color value of the text box's border, as the name suggests. And the page size property for the report shows the page size of a report. Again, pretty understandable. These properties are displayed in the properties pane. The properties in the pane change depending on the report item that you select. Now, in a report builder, you can change properties for the report items in several ways. You can do it by selecting buttons and lists on the ribbon. You can do it by changing settings within dialog boxes, as well as property values within the properties pane. The most commonly used properties, however, are available in the dialog boxes and on the ribbon. By default, the properties displayed in the properties pane are organized into broad categories such as action, border, fill, font, and general, each category with a separate set of properties associated with it. Next, you have the grouping pane. Now, groups are used to organize your report data into a visual hierarchy and to calculate totals. You can view the row and column groups within a data region on the design surface and also in the grouping pane. Now, the grouping pane has two panes, one representing row groups and the other representing column groups. When you select a data region, the grouping pane displays all the groups within that data region as a hierarchical list. Child groups appear intended under their parent groups. Now you can go ahead and create your groups by dragging fields from the report data pane and dropping them on the design surface. In this pane, you can add parent, adjacent, and child groups, change group properties, as well as delete groups. Even if the grouping pane is displayed by default, you can definitely clear it by unchecking the box on the View tab. I hope with this section, you're clear with all the different ribbons and panes in the design space. With that, let's move on to the real deal. Let's go on to our tool and create our paginated report. Now, upon selecting to open your Power BI report builder, you shall be faced with something like so. You will have a dialog box called Getting Started, which shows at startup. I'm going to close this and I'm going to full screen the report builder. This is what your report builder looks like. Here's your design space with all the different panes and ribbons around it. Yes. Now in this tutorial, what we're going to do is we're going to connect to a sample Azure SQL database, and then we're going to use a wizard in the report builder to create paginated reports with a table that wraps to multiple pages. So again, your steps to this demo is to use an Azure sample database, create a matrix in the Power BI report builder with the help of a wizard, format the report with title, page numbers, and column headings on each page, format currency. If you don't have an Azure subscription, you can definitely go ahead and create a free account before you begin. Now, as I had given you guys a heads up before, you definitely need a Power BI report builder from the Microsoft Download Center. You need to also have created an Azure SQL database sample in the Azure portal. You will be needing the name and password you created. You will also need a Power BI Pro license. You need a workspace on the service in a premium capacity. Now, if you have a premium capacity, it would have like a diamond-like icon in the workspace next to it. So let's go ahead and create a matrix with a wizard. If we go to File and then click on New, again, this dialog box appears that we had closed out before. If you're using the dialog box that appears automatically once you turn it on, make sure that your new report option is selected on that dialog box. For me, I've opened it through File and the new report option. So this is the only one option that I'm getting. But apart from this, if you use the startup dialog box, you will also be getting options such as new dataset, open, and recent. So be careful of this. So on the right, you have options such as table or matrix wizard, chart wizard, map wizard, and blank report. So I'm going to go ahead and click on Table or Matrix Wizard. Here I will be prompted with this dialog box, and here I'm going to go ahead and choose a data set. Okay. In the Choose a Dataset page, this wizard that appears, select Create a Dataset. For most of you, this will be automatically selected. Then go ahead and click on Next. You'll be prompted to choose a connection to a data source, a page like this. Here we are going to click on New because we are going to use a new data source. And on clicking that, a dialog box which says Data Source Properties is going to open up right in front of you. You can name a data source anything you want. Use characters and underscores. For the purposes of this tutorial, I am going to call it My Azure Data Source because I am going to be using an Azure data source. In the connection type, I'm going to go down the list and select the Microsoft Azure SQL database. And next to the connection string box, I'm going to go ahead and click on Build. Now this is going to lead to another dialog box called Connection Properties. Now for the server name, I'll be going back to my Azure portal where I have created an SQL Server database beforehand. So on the SQL databases page, this is the name of my sample database. I'm going to click on it. And here it's going to show me all the details that I need. If I go a little to the right, you have your server name, which let's just copy and paste here. You can copy to clipboard and then paste. Make sure it ends with a .database.windows.net. In the logon to the server section, instead of use the Windows authentication, we are going to be using our SQL Server authentication. So my login is Azure user. I'm going to go ahead and type a password. And in the next section, to connect to a database. Now under connect to database, select the drop down arrow and select the database name you have created in Azure. In my case, it's the My Sample Database. Then we're going to go ahead and test connection. The test results would come fairly quickly. And as you can see, the test connection is succeeded. For you, you will also see the test results message every time. Then we're going to select OK. And again, we're going to go ahead, even in the connection properties, we're going to select OK. Now, in the connection string box, the report builder displays a second line, which you might have noticed did not exist before. This is basically the connection string you just created. We're going to go ahead and click on OK. Now, we're back to the choose a connection to the data source page. And now you have a data source connection in your data source connections box, which is your My Azure data source. And in this report button under the data source connection you just created, we're going to select the data source, which is already selected in my case, and then click on Next. Here we are going to be met with a design a query page. If this does not come directly to you, you'll probably be met with a prompt where you'll have to type in the same Azure username and password. But since I'm already connected and logged in my Azure portal, as you guys just saw, now you'll be met with a design a query page. What we're going to do is we're going to expand this sales LT section and then the table section. And you'll have a bunch of different tables called address, customer address, product, category, description, model, so on and so forth. I'm going to go ahead and select a couple tables. We're going to select address, customer, product, and the last two. Now pay attention here in this line. Because auto detect is selected in case of our relationships, the report builder detects the relationships between these tables automatically. We're going to go ahead and select run query, and then our report builder displays to us the query results. Yeah, all the columns, and this is all the rows. Once we're done with this, we're going to go ahead and click next. Now this will directly lead you to the arrange fields page. For those of you who have older versions, you might be led to a choose a dataset page where you can go ahead and choose the dataset that you're working with and click on next. For those of you with the latest version as of May 2020, you will directly be met with this arrange fields page. What we're going to do is drag certain fields from the available fields box to the row groups box and the value box. So I'm going to drag company name. Also going to get the sales order number as well as product name. Let's get this also. Now again, from the availables field, we are going to pick 3 more things to put in our values box. So order quantity. As you drag order quantity into the values box, you know what this logo means, right? It's a calculated field. So it's going to sum your order quantity automatically. You're going to put unit price as well as line total. All right. On clicking next, you'll get a choose the layout page. Here, what you're going to do is keep all the default settings, but clear the expand and collapse groups. In general, the expand or collapse groups feature is great, but just for the sole purpose of this exercise, you want the table to wrap to multiple pages. So we're going to go ahead and uncheck this. We're going to then go ahead and click next. It shows us a preview of what we've created, and then again we are going to finish so our table is displayed on the design surface. Alright, so now let's pause for a moment and look at the results of the wizard. This is a little insight into what you have created as of now. Let's first go step by step and look at all the features that we had looked at previously. First, the report data pane. If I expand the dataset here, you see the embedded Azure data source and the embedded dataset based on it, right? Both of which you have created. The design surface is about 6 inches wide, and on the design surface, you see the matrix displaying the column headings and the placeholder values. Yes, the matrix has 6 columns and appears to be only 5 rows tall. Again, here you see the order quantity, unit price, and line total are all in sums by default, and each row has a subtotal again by default. You still don't see actual data values. You need to run the report to see them. Now we go to view and check our properties pane. We get our properties pane on the right. In the properties pane, the selected matrix of yours is called Tablix 1 or Tabli 1. Now, a Tabli or a Tablix in the report builder is a data region that displays data in rows and columns. It can either be your tables or matrices, whatever. All right. Now, the grouping pane is in the bottom, as I had mentioned before. It has your row groups and column groups. And here you will see 3 row groups that you created in the wizard. You have your company name, sales order name, and product name, which we just did. The matrix doesn't have any column groups because we didn't create any. Next, what we're going to do is run the report. To see the actual values, you need to run the report. So we're going to go to the home ribbon or the home toolbar and then select run. Now, as you see, the page has changed and it'll take a few moments to load. Kindly be patient, and voila, you see the values. The matrix has many more rows than you saw in the design view, right? Note that here on top, report builder says it's page 1 of 2. Now the report builder loads the report as quickly as possible, so it retrieves enough data for a few pages at a time. The question mark at the end of this 2 indicates that the report builder hasn't loaded all the data yet. We can go ahead and click on print layout, and then your report will be in this format when you print it. The report builder now knows that the report has 29 pages and has automatically added a date and timestamp as well. So now you have a report with a matrix that wraps to 29 pages. Let's add some features and improve how it looks. So you can run the report after every step if you want to see how it's coming along. Yes? Now for that, on the Run tab, you see this design option. We're going to click on that so we can continue modifying it. First, we're going to go ahead and set page width. Typically, a paginated report is formatted for printing, and a typical page is 8.5 by 11 inches. So I'm going to drag it out. So you can go ahead and drag your ruler to make your design surface a desirable size. The default margins are 1 inch on each side, so the side margins need to be narrower. So we're going to go to report properties. I'm going to expand margins. I'm going to change the left and right margin to like 1.9 just for the sake of this. I'm actually pretty satisfied with the 2 centimeter gap. All right, then we're going to go ahead and add a report title. So here it already gives us the option called click to add title at the top of the page. Let's name it sales by company. Also going to centerline it. On the right, you can see the alignment, font, general lists, so on and so forth. Once you've selected your title text, under font in the color, let's change this to blue. All right. Actually, I quite like the black, so let's just keep it black. Much better. Then we can go ahead and add a page number. Now you notice that the report has a date and time stamp in the footer. You can also add a page number to the footer. So at the bottom of the design surface, you will see something known as execution time. Yes, this is on the right at the bottom. Now in the reports data pane, let's go up and expand the built-in fields folder. We're going to take page number. We're going to drag this to the left side of the footer. Yeah, so I put it at the same height of this execution time bracket thing. I'm going to drag it out to make a square. Then I'm going to go to the insert tab and select a text box. I don't know why I couldn't see it. It's right in front of me. And as it appears, click to the right and type I'm going to bring this also type off. And then I'm going to go back to the report data pane and drag the overall total pages. And also make it square. So it'll basically show the page numbers in a current page number of total page numbers format. Okay. Next, we're going to go ahead and make our table wider. So now you can make your matrix wide enough to fill in the width of the page and make the text columns wider so the names don't scroll as much. So I'm going to select the matrix, select the company name column, and open it wide. And I'd do the same for the product name. I'm just going to expand it enough so the name shows completely. Now your matrix is almost as wide as the print area. Now all that we are left with is to change the currency and add column headers on each page. So to format the currency, we're going to select the upper left, the cell, hold down the shift key and select till here. Okay. We're going to go to the home tab and select the $sign. Then we're going to click on this little arrow next to the placeholder styles and select sample values. So now you can see that the values are formatted as a currency. Yes. Now finally, we are going to go ahead and add columns on each page. So one more formatting improvement before publishing the report to the service is to make column headers show up on each page in the report. So in the far right top bar of the grouping pane, select advanced mode, select the top static bar in the row groups, and you will see that the company name cell matrix is selected. Now we go to our properties pane. So here we're going to select our keep with group and set it to after and repeat on new page to true. It's time, guys, now to run the report and see how it looks. Go back to the home ribbon and select run. This is going to take some time. All right. Then we're going to go select print layout. Okay, so this is our print layout. Here you can see your currency is formatted. Your columns have headings on every single page. Just let's go to the next page. So my line total has actually come to the next page. What I'm going to do is I'm going to go back to design, select this and bring it in. Make a few changes. All right, let's run this. Voila, our line total comes on the same page. And here on our last page, you have your totals. So now you see your currency is formatted for every page, and the report has a footer where there is your page numbers written. I should have aligned it better, but we work with what we've got. You have a date and timestamp on your page for every page. Here in the bottom, you see you have your footer, you have the date and timestamp. Now you can go ahead and save this to your computer. So now that you created your paginated report, you're all set to upload it to the Power BI service. All you have to do is go to your Power BI app to your workspaces. You select the arrow next to the advanced and turn on dedicated capacity. Now, if you cannot turn it on, you need to ask your Power BI admin to give you the permission to add the workspace to the dedicated premium capacity. Choose an available dedicated capacity for this workspace if necessary, and then save. If your workspace isn't a premium capacity, alas, then you cannot upload your report. You will get the message unable to upload paginated report. Then you can go ahead and contact your Power BI admin to move the workspace. If you do successfully upload these paginated reports in your new workspace, you can simply go to Get Data and navigate to where you've saved the file and open the file. Power BI will import your particular file and you see it under your reports on the app list page. You can then go ahead and select your report to view it, and that is how you can view your paginated report in the Power BI service. So what is Python, or the Python programming language? Now, Python is an interpreted high-level general-purpose programming language which emphasizes on code readability within its notable use of significant white space. It's a fairly simple language to pick up, and any experienced programmer with the knowledge of coding can pick up Python pretty easily. It is also a great decision for beginners to start their coding journey with Python. Now, there are a couple things to keep in mind before we can start this tutorial. Now, to run the Python scripts in Power BI Desktop, you need to install Python on your local machine. I downloaded mine from the Python official website, and the current Python scripting release supports the Unicode characters and spaces in the installation path. The Python Power BI integration requires the installation of two Python packages. First of all, you need Pandas, which is a software library for data manipulation and analysis. It offers data structures and operations for manipulating numerical tables and time series. Your imported data must be in the Pandas data frame, which is basically a two-dimensional data structures, meaning that your data is aligned in a tabular fashion, like having rows and columns. The second Python package you require is matplotlib, which is basically a plotting library for Python and its numerical mathematics extension NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits such as Kinter, WXPython, Qt, etc. Now, you can install these packages in a console or shell. You can use the pip command line tool to install these two packages. And that is all I have to say in terms of prerequisites. Now, let's move on to actually using Python scripts in Power BI. For that, we need to move on to our demo machine. Okay, now first things first, in the Power BI desktop, first we are going to go to File and then Options and Settings and select the option Options. Now this is going to take some time. Okay, here we are going to select Python scripting and the Python script options page appears. Now here what you can see up top in the detected Python home directories, you're going to find your local Python installation path. If it is not already given, you can just click on the arrow and select the path that leads to your Python home directory. In here, you can see the Python's installation local path here is in users, app data, local programs. Make sure the path is for the local Python installation that you want Power BI Desktop to use. Here at the bottom, you have your detected Python IDEs. Since the Power BI could not select the Python IDE that I preferred, I clicked on other and then I browsed to the Python IDE which I wanted, which is the Visual Studio Code. Once you specify your Python installation, you are ready to begin running Python scripts in the Power BI desktop. So we're going to go ahead and select OK. Now, in just a few steps, you can run Python scripts and create a data model. From this model, you can create reports and share them on Power BI service. So first of all, we need to prepare a Python script. So first, I'm going to create a script in my local Python development environment and make sure it runs successfully. For example, here's a simple Python script that imports pandas and uses a data frame. Okay? When the script runs, here is what I get in return. Kindly look at this output right here. Now, when preparing and running a Python script in the Power BI desktop, there are actually a few limitations. Firstly, only pandas data frames are imported, so make sure that the data you want to import to Power BI is represented in a data frame like I have done in line number 3. Any Python script that runs longer than 30-minute times out. Interactive calls in Python scripts such as waiting for user input halts the script's execution. And when setting the working directory within the Python script, you must define a full path to the working directory rather than a relative path, which we have already done before. Also, another important thing is that nested tables are currently not supported in the newest version of Power BI. Let's hope that is fixed in the months to come. So now that we've run it here, I'm going to take this code and I'm going to try and run this Python script in the Power BI desktop. So right now I'm on my Power BI desktop. In the home ribbon, I'm going to select get data. Now this is going to take some time. Okay, I'm going to select other. Here I'm going to go down and select Python script. I'm going to click on connect. Now your local latest installed Python version is selected as your Python engine. So you'll see a dialog box like so on your screens, and here I'm going to copy my Python script that I had earlier run in the IDE. I'm going to select OK, and if the script runs successfully, then the navigator is supposed to appear and you can load the data and use it. Kindly be patient, it's going to take some time to connect. And here for this example, I'm going to select DF or my data frame, which is this small little table, and then click on load. Now, if Python isn't installed or identified, you might find a warning that displays. You can also see a warning if you have multiple local machine installations. Now, that's pretty easy to troubleshoot. All you have to do is revisit and review the previous install Python and enable Python scripting sections and uninstall the previous versions of Python. You can then refresh a Python script in the Power BI desktop. You can then refresh a Python script in the Power BI desktop by going to the home ribbon and selecting a refresh, which is this button right here. And when you refresh a Python script, Power BI runs the script again. It's as easy as that. Now that you know how to import data using your Python script, let's actually import some data of use, which we can layer visualizations on top of. All right. So for this, I am going to use a different script. That one was just a dummy, the one that we used before. I only wanted to show you how you can import a simple data set using a Python script. Like I had given the disclaimer earlier, the scripts are going to be pretty rudimentary because this is not about Python programming, but about how to use Python in the Power BI desktop. So I'm going to do the same thing again, and this time I'm actually going to have some data with more dimension. So here I'm creating a data frame again, but this time I have more dimensions. I have names, age, weight, gender, state, the number of children, and pets as well. So I am going to click on OK and wait till it connects. Again, I'm going to select the data frame. As I had told you earlier, we have multiple columns this time. You can go on to transform data, which is going to open the Power Query editor. And you can see your table, make changes by adding to the query right here. We have a tutorial about this. You can go ahead and check that. I'll link that in the description box as well. And I see everything is fine. I'm just going to close and apply. And on the right on my fields, you can see my data frame. Here we have all of the columns as well as calculated columns. We have ages, children, pets, weight, so on and so forth. Now we're going to see how we can use beautiful visualizations in the Power BI desktop by using Python. So now to begin with, let's select the Python visual, which is right here on the visualization pane in the PY icon. This will lead to a prompt named Enable Script Visuals. This is a dialog box that is going to appear the first time you use it in every Power BI session. So here we're going to click Enable. Now, when you add a Python visual to a report, Power BI Desktop is going to take the following two actions. First one is going to be your placeholder Python visual image, which appears on your report canvas. This one is right here. It's a blank visualization with the Python icon on it. And all of it is grayed out because we have no values. And then you have the Python script editor, which appears along the bottom of the center pane, which you can see right here. Now, the thing is, your Python script can only use fields added to the values section, which is right here on the right. So what we're going to do is we are going to drag the age, name, children, gender, pets, a bunch of different fields to the values section, which already says add data fields here. So basically, I dragged all my fields in there. And now we can add or remove fields from the values section while working on our Python script. Power BI Desktop will automatically detect these field changes. Now, the default aggregation type for Python visuals is do not summarize. All right, remember that for later use. So now you can use the data you have selected for creating a plot. So as you select or remove these fields on the right, supporting code in the Python script editor, which is here, is automatically going to be generated or removed. Based on your selections, the Python script editor generates this binding code, which is given right here. Basically, the editor has created a dataset data frame right here with all the fields that you have added: age, children, F name, gender, pet, state, and weight. Now, similar to table visuals, fields are grouped and duplicate rows appear only once. In certain cases, you might not want automatic grouping to occur, or you'll want all the rows to appear, including duplicates. If so, you can add an index field to your dataset that causes all the rows to be considered unique, which prevents grouping. Now, you can access columns in the dataset using their respective names. For example, you can use the variable age to call age in your Python script to access the age field. Now, with the data frame automatically generated by the fields that you selected, you're ready to go ahead and write a Python script which results in plotting to the Python default device. Now, when the script is complete, you can go ahead, select Run, which is right here, which is on the Python script editor title bar. Power BI Desktop replots visuals if one of two events occur. First of all, when you select Run from the Python script editor title bar, and second, whenever a data change occurs due to data refresh, filtering, or highlighting. So when you run a Python script that results in an error, the Python visual isn't plotted and the canvas error message appears. Then you can go ahead and select See Details from the message, and to get a larger view of the presentations, you can minimize or maximize the script editor and the blank visualization as you please. So that's enough chit chat for now. Let's create some visuals. So first of all, we're going to try and create a scatter plot to see if there's a correlation between age and height. So I'm going to go to the line which says paste or type your script here. And on the next line, I'm going to paste the script which I have already created. And your Python script editor pane should now look something like this. The matplotlib library is imported to port and create our visuals. So now let's go ahead and select run script. So as you can see, a visualization has appeared. So I'm going to make it slightly larger for it to be visible. Now when you run the script button, this scatter plot generates in the placeholder Python visual image. You can look at the correlation between the ages and weights of the children. Now, what else can we do? I'm thinking let's create a line plot with multiple columns. Let's go to a fresh new page and do the same thing as we did before, except for this time we are going to create a line plot for each person showing their number of children and pets. Again, we have the same sort of basic frame of code. Again, paste or type your script here. And here, basically, I have created a line plot showing the number of children and pets. Here on the x-axis is going to be the names of people, and on the y-axis is going to be represented their number of children and pets. And the line of pets is going to be represented in the color red. Then I'm going to run the script. And as you can see, children appear in blue while pets appear in red. Now you basically have a line plot with multiple columns showing the children and pets of every person on the dataset. Another interesting chart you can do with this is the basic bar plot. For that, again, I'm going to do the same thing. I'm going to create a bar plot in a fresh canvas. Now, when you run the script, you basically have a bar chart or a bar plot representing all the ages of all the people that are there in your data frame. And that's just the tip of the iceberg of what you can do if you explore the potential of Python in Power BI. Now, this tutorial was basically designed to help you get started with creating visuals with Python in Power BI Desktop. This barely scratches the surface about the many options and capabilities for creating visual reports using Python, Pandas, and Matplotlib library. There's a lot more information that you can tap into if you go on to Power BI's community or maybe Python's community. But this is basically all you need to know to get started with Python in Power BI. Now let's go ahead and look at a few known limitations of this service. Now, Python visuals in Power BI Desktop have a couple limitations, starting with the data size limitations. Basically, the data used by the Python visual for plotting is limited to 150,000 rows. If it is more than that, then only the top 150,000 rows are used and a message is displayed on the image stating the same. Additionally, the input data has a limit of 250 MB. The second is resolution, which basically refers to visuals are displayed at 72 dpi. Third, you have calculation time limitation. If a Python visual calculation exceeds 5 minutes, the execution times out, which results in an error. Then you have relationships. As with other Power BI desktop visuals, if data fields from different tables with no defined relationship between them are selected, you basically get thrown an error at. Then you have Python visuals, which are refreshed upon data updates, filtering, and highlighting. Then you have something which is kind of a given. Python visuals can be refreshed upon data updates, filtering, and highlighting. However, this image itself isn't interactive and cannot be the source of cross-filtering. Followed by next, which obviously gives rise to the next problem, which is that Python visuals respond to highlighting other visuals, but you can't click on elements in the Python visual to cross-filter other elements. Pretty self-explanatory. And finally, only plots that are plotted to the Python default display device are displayed correctly on the canvas. So a good practice is to explicitly avoid using a different Python display device. Now, R is a programming language and free software environment for statistical computing and graphics, supported by the R Foundation for Statistical Computing. It is a widely used programming language used among statisticians, data miners, data scientists even, for developing statistical software and data analysis. So in this session, I'm going to explain to you how to work with R in Power BI Desktop, focusing on how to perform R specific tasks as opposed to taking a deep dive into the R language. Now for this reason, the R scripts in the examples are extremely rudimentary and meant to only demonstrate how you can utilize R in the Power BI Desktop. So once you understand these concepts, you can take advantage of R's extensive and robust capabilities to analyze, transform, and visualize data. If you're not familiar with R, a good place to start will be the R project site, where you can look at projects based on R and learn a little bit about the programming language. Now, when working with R in the Power BI Desktop, R must be installed on the same Windows computer as Power BI Desktop. Now, you can download and install an R distribution for free from a variety of locations, including the CRAN distribution available from the R project site. You can also do so using the Microsoft R Open distribution available from the Revolution Analytics site. And for examples in this particular session, I have used the CRAN distribution version 3.6.2. You'll also find it handy to have a separate R integrated development environment or IDE installed on your system. This allows you to verify your R scripts before running them within the Power BI Desktop. Now, an IDE also makes it pretty easy to install R packages that you might need while running R in Power BI Desktop. On my system, I have installed the free version of RStudio, which is again available from the RStudio site. So now that you know where to get started, let's actually get started. So when you open your Power BI Desktop, it tries to locate an R installation on your system. You can verify whether the correct installation has been detected by opening the Options dialog box available by going to File and then Options and Settings, and then going and selecting the first option, which is called Options. Kindly be patient, this might take some time. Now, if I select the R scripting section, it appears like this on my system. In my case, as you can see right here, the Power BI Desktop has detected both the correct R installation, which I had mentioned before, the R version 3.6.2, and the IDE, which is the RStudio, indeed the one that I'm using. If you find the information to be incorrect or missing, you can provide a specific R installation, R IDE, or both. Now, associating an IDE with Power BI Desktop applies only when you're creating R visualizations in your report view. Okay, so by associating an IDE, you can launch the IDE from within Power BI Desktop and work on your visualization script right there. I hope that's clear. So let's move ahead. Using an R script to import data. Now, when using an R script to import your data, your script must return at least one data frame that serves as the basis for your imported table. Now, if your script returns multiple data frames, you can choose which ones to include as a part of your import process. Now, Power BI will create a table for each imported data frame. One word of warning, however, if a data frame contains a column configured with the complex or vector type, Power BI Desktop will replace the column's values with errors. So now, moving on, to use R script to import data into your Power BI Desktop, it's very simple. You can click on Get Data, the button right there, click on More. And when this Get Data dialog box appears in front of you, you can navigate to Other and then R script. And then when you click on the Connect button, Power BI Desktop is going to launch the R script dialog box. As you can see, R script is written right here. Now here you can type or paste your R script. For example, we are using an R script to retrieve data from the IRIS dataset. Now this is included in the CRAN distribution. And then what we are going to do is we are going to assign it to the IRIS raw variable. So here I have a handy notepad. Here I've kept all of my code because it's not about R, it's about learning how to use R in Power BI, as I had mentioned before. Basically, what we are doing is we are going to retrieve the IRIS dataset and assign it to the IRIS raw variable. Now in Power BI Desktop, you must assign the dataset to a variable even if you don't modify the data frame in any way. If you were to enter only the name of the dataset, as you can do in an IDE, no data frames would be available to import into the Power BI Desktop. So before entering your script into the R script dialog box, you should probably test it in your IDE to ensure that it runs properly and returns the results that you expect. Now, if your script generates an error within Power BI Desktop, it can be very difficult to make sense of it. Plus, you have to start over with the import process all over again. Once you're sure your script is ready to go, you can enter it into the script text box as you see in front of you, and then click on OK. So when you click on OK, Power BI Desktop processes the script and then launches the navigator dialog box, which will appear in a few moments. Here it is. If I select the iris raw table, this is the data frame that we have imported, and now we can review our sample data for each data frame. In this case, we only have one data frame, which is the iris raw data frame. So it is the only one available, as you can see in front of you. Now this navigator dialog box lists the data frames in the display options section under the R1 folder, as you can see here. As I have selected the checkbox right here, you must also select the checkbox which is associated with each of your data frames that you want to import. Once you've made your selections, you can click on load. And after Power BI Desktop loads that data, you can view the data set in the data view. It's going to take some time. Kindly be patient. Here, you can see it on the right, or you can go straight to the data view. This is the data view. And again, you can see your table, your data frame right here, and all your columns right here on the right hand side of your view. Now, in some cases, you might want to import the data from a file rather than using one of the built-in data sets. For example, suppose you have copied this iris dataset into a CSV file, which you have saved into a certain location on your system, on your local drive. You can easily pull the data into the R data frame using a statement. For example, suppose you've copied the iris dataset to a CSV file, which you've copied in your C drive in a folder named data files and saved it on your local drive. You can easily pull that data into the R data frame using this statement in front of you. The statement uses the read CSV function to read the context of the iris.csv file. The header argument is set to true to indicate that the first row values should be created as headers if that's what you want to do, and the sep argument indicates that a comma is used to separate the data values within the file. You can use the same process described in the previous example to import the data from the iris_csv data frame as well. Now let me close this. Don't need to save it. Now the R language is extremely flexible due to the ability to install packages with additional functionality, and there are several that aid reporting and analytics. The dplyr and data.table functions provide extremely useful functions or verbs for working with data frames, and the ggplot2 is useful for visualization. To use these in Power BI Desktop, they must be installed into your system. So you can install these through your IDE. In my case, it's going to be RStudio. So let's go ahead, launch our RStudio and run these commands. So here are a couple of commands. First is I am installing the dplyr package, followed by the data.table package, and finally the ggplot2. So let's run these commands. Now, these packages are going to take a few moments to load. Now, after these packages are installed, you can then use the library function within your R script to call that package when you're importing the data. These will basically allow you to use these functions included in the package and make use of them in Power BI. So one of the biggest benefits of being able to use R when importing data into the Power BI Desktop is that you can manipulate data as a part of your import process. For example, here is a script. Now this script uses the summarize and group by functions available in the dplyr R package to group and aggregate the data before importing it. So I am going to click on enter. The group by function here prepares the data for the use by another function, which in this case is summarize, that has been just used before the group by. In this example, the summarize function is used in conjunction with the mean function right before that again. The mean function to find the mean for each of the 4 measures grouped according to the values of the species column. You can see it in the global environment right here. If we click on the global environment, here on the left hand side top corner, we can see this table. Basically, returning now to the R statement that we have just given, the aggregated data is saved to the iris mean table. Now, this is the name that has been assigned, as you can see here. This is the name that has been assigned to the data set when it has been imported into this R Studio. Now that we've run it here, let's go ahead to Power BI and run it right there. So again, we're going to get data. Now, of course, you can write far more complex R scripts than the one I am writing, but this should give you an idea of how easy it is to use R to import data into Power BI Desktop. And the more adept you are with R, the more powerful this tool becomes for you. Again, on the right, you can see our table of iris mean is right here. It appears. Even if we go to the data view, we see the table that has been imported from R. Moving on. Now, there might be times when you want to use R to manipulate a data set already imported into your Power BI desktop. Now, the query editor includes the capacity to apply an R script to a data set in order to transform the data. But before modifying the data, let's take a look at how the iris raw dataset appears in the query editor before applying any transformations. Notice that the applied step section includes only 2 steps. There is source and there is navigation. From what you see in front of you, the source step is selected and a small table is displayed in the query editor's main pane. Now, the table represents an initial import operation with 1 row included for each returned data frame. Now, in this case, as you see in front of you, because there is only the iris raw data frame, the table includes only 1 row. The table value in the value column, right here on the right, represents the data associated with that data frame. Now, the table value in the value column represents the data associated with that data frame. Now, selecting the value results in the second step. So, if we click on navigation, now this shows the actual imported data as shown previously. Whenever you use an R script to import data, the Power BI desktop adds both the source and navigation steps. Now let's take a look at how to run an R script against this iris raw dataset. Now, to keep things simple, we are going to use the same aggregation logic which we used while importing the iris mean dataset. The primary difference is that you must use the dataset variable when referencing the dataset instead of specifying iris. Now, to run this R script in the query editor, we are going to click on the Run R script button here in the Transform ribbon. So it's right here on the right. So instead of this iris right here, I'm just going to change it to dataset. Now, after you enter the script and click on OK, the query editor adds 2 steps more to the applied steps right here. As you can see, we have one Run R script and the iris mean. These 2 steps work just like the first 2 steps, source and navigation. The first one reflects the data frames returned by the script, and the second one reflects the selected data frame, as you can see on the screen before you. As with using R to import data, being able to run an R script against a dataset provides you with a very powerful tool for working with the imported data, whether the data was imported from a database, an online service, or a text file. After you've imported the data into Power BI Desktop, any dataset is a fair game. Another great feature in Power BI Desktop is the ability to use R to create visualizations within the report view. I'm going to close the query editor. Now, for the most part, this process is also as straightforward as using R in other ways, except for one important thing. Now, R automatically groups and summarizes the data whether or not you want it done. And you cannot override this behavior of Power BI. Why Microsoft decided to take this approach is a bit of mystery to me, honestly, especially since it can sometimes give you the results you don't want. Fortunately, there is a workaround. You can add a column to your data set that uniquely identifies each row similar to an identity column in the SQL Server table if anybody of you have used it before. Now, if you're using an R script to import the data, you can add the column as a part of your import process. For example, let's open this. For example, this R script adds an identifier column to the iris dataset based on the dataset's index or row names. The script starts by calling the data table package, which provides functions for the working with data frame objects. Now, be sure to install this package if you already haven't. Then you have the setDT function along with the keep.rownames argument. Now, this creates the new column based on the index values. And notice that you must first assign the iris dataset to the iris ID, which is a variable, before you use the setDT function. Now, this is because the function makes changes directly to the dataset, which you cannot do with a built-in dataset such as iris. After creating the column, you can then use the setNames function to change the name of the first column from the default RN to the new name ID. The final step is to change the column data type to an integer. Now, with the iris ID dataset in place, you can use it to create a visualization based on an R script. And to add an R-based visualization, you have to be on the report view, which we already are. So let's click on this. Let's go again. As you can see, it has this row called ID with all the row numbers, and that's what we wanted. Let's go back to our visualizations pane. Now, the first time we are going to create a visualization out of our script, we are going to click on this R sign in the visualizations pane, and you will be prompted this enable script visuals prompt. You have to simply click on this enable button. And when you click on that button, Power BI Desktop adds a graphic placeholder to the report and opens an R script editor pane here at the bottom. Before you can do any scripting, however, you need to identify the dataset columns that you'll be using in the visualization. Now, the easiest way to do this is to drag the columns from the fields pane, which is right here, to the values section right here. Be sure to include the identifier column you created on the dataset. So for this example, I'm going to add, let's start with ID and species, petal width, and petal length. Now, if you look at your R script editor, when you added the columns, Power BI inserted several comments in the R script editor pane. Now, the first two comments indicate that a data frame named dataset has been created, and based on the columns you added to the values section of the visualization pane, you must use dataset to reference the source data in your R script. The second two comments indicate that duplicate rows have been removed from the dataset, which is why you needed to add the identifier column. Now, beneath the comment, my code starts here. Now, this is a fairly simple script. The script uses the ggplot function in the ggplot2 package. Again, make sure to install the package if you haven't already to create a visualization with the specified colors and labels, right? Notice that your petal width column is used as an x-axis right here, and the species column serves as the basis for plot colors, as you can see right here. After you define your R script, it's very simple. Go ahead and click on the Run button, which is right here. It's at the top right of your R script editor pane. And here we are. Let me just make it slightly bigger. The Power BI Desktop basically processes the script and displays the visualization in the placeholder that was added earlier when you first click the R button. This figure shows how the visualization appears on my system. It might appear slightly differently on your system, but the basics will remain the same. The petal width and length are going to act as axes, and the colors are going to differ by species. You can update an R-based visualization at any given time by modifying the R script. After you modify the script, just click on the Run Script button to update your visualization. And if you want to edit the code in your IDE, you can edit the script in your internal RStudio or RIDE by clicking this button right here. As you can see, it gives you an option of editing the script in an external IDE. Now you may need to do that to connect to code necessary to connect to your data source that you're using for your visualization. The script will also include any code you already added to the visualization script in the Power BI desktop. You still have to copy and paste a bulk of your script back into the desktop if you make any changes at all. But this at least saves you the trouble of trying to set up the data source in an IDE in order to test your script. Something to keep in mind when adding R-based visualizations to your report is that the Power BI service comes with licensing restrictions. You cannot use R-based visualizations in the Power BI service unless you have a Power BI Pro license. Moving on, another fun feature in the Power BI desktop is the ability to import predefined R-based visualizations into your workspace. The visualizations are available through Microsoft's App Source Gallery, which you can directly access through the Power BI desktop. You do not need to understand R syntax, nor do you need to build or run R scripts for this. So let's open a fresh page. And to import a visualization, we are going to click on this ellipses or the three dots on your visualization pane in the report view, and then click on Import from App Source or the marketplace. Now this launches the Power BI Visuals window. As I had mentioned, it's also known as the marketplace. So here are a couple of suggestions for you. When you locate the visual that you want to import, you can just go ahead and click on this yellow add button. If the visualization requires additional R packages to be installed, the R packages required dialog box is going to appear, and it is going to list down the packages that need to be added. You can either click, cancel, or install the packages manually, or you can click on the install button and let Power BI Desktop install the packages automatically for you. For this specific example, I'm going to select something known as a spleen chart. Okay. Now when it's added to the Power BI Desktop, you can see it right here in the bottom. So when you import a custom visualization, the Power BI Desktop adds a button to the visualization pane specific to that particular visualization. Now you can then add this viz to your report and configure just like you would any other pre-built visualization. As you can see right here, in the bottom, you can see your spleen chart visualization that we just downloaded. Now, Microsoft provides a number of free and interesting custom visualizations like this one, and it's certainly worth familiarizing yourself with what's out there. So you can create reports that are even more engaging than you can achieve with the built-in visualizations. Best of all, Microsoft has made it exceptionally easy to pull the custom visualizations into Power BI Desktop, so you have little to lose by trying them out. Now, the integration of the R language into the Power BI Desktop provides a powerful tool for transforming and presenting business intelligence data. R is a comprehensive statistical computing and graphics language that is extensively implemented and has a very large and active user community. In Power BI Desktop, you can use R to import and modify data as well as create a wide range of visualizations that provide in-depth insights into the data. Those already well versed in R should find that using R in Power BI is simple and a pretty straightforward process. Even those less experienced with R could find it well worth the effort to try out the Power BI Desktop R features.
So if you talk about Azure, then Azure is the second leading platform in the entire globe after AWS, because AWS has been on #1 position since its inception back in 2006. And Azure has multiple services under its portfolio. So it has services for computation, networking, database, migration, IoT, artificial intelligence, machine learning, on databases, on unstructured databases. So there are multiple services offered under Microsoft Azure, almost more than 100 services in different categories that we can choose to get started with. To see the list of all the services offered under Azure, we can refer to the link here, azure.microsoft.com. So here we can refer to this link here, azure.microsoft.com, where we can see the list of all the services offered under this platform, where we can see the services offered under AI/ML, under computation, containers, hybrid solutions, Internet of Things, and there are more than 200 plus services offered under different categories that we can get started with. So AWS currently offers almost 175 services, whereas Azure offers more than 200 services offered under different categories. All right, so Azure, as you know, is one of the leading platforms for cloud computing through which we can choose multiple services and different categories, and then we can get started. So why people prefer Microsoft Azure? Because here we have everything offered on on-demand basis. That means there are no upfront cost here. We have to pay only for the services that we have consumed. That's it. For example, if we have deployed 100 VMs and we have consumed them, let's suppose for 2000 hours, then we had to pay only for those 2000 hours, nothing less, nothing more. If we have a small testing requirement and we have used a server only for 2 hours, we had to pay only for 2 hours, that's it. And we had to pay also based on the configuration of the resources as well. That means if we have used a high-end server having more cores of CPU, more amounts of RAM, and a specific set of processor, then we had to pay for that. And if we are deploying a low scale server, I mean small scale server, then we have to pay accordingly. So it is all based on the requirement, and then we have to pay only based on the amount of services that we have consumed and for the time period we have consumed it. And then it offers abstract resources. That means we can focus only on requirement, not on the hardware specification, as it is already managed by Azure services. We can have the scalability done. That means we can easily scale up and down the resources as per the requirement. And then we can also have the efficiency of experts. That means we can utilize the skills, knowledge, and resources of the experts as per the requirement. Because again, here we only have to worry about making a solution available to everyone. And then we can let the Azure platform to take care of the entire maintenance, deployment of servers, and every other component that needs to be taken care of. And then we have to pay as you consume. That means we have to pay only for the resources and for the time period that we have used it, nothing less, nothing more. All right, so let's move forward. So we had discussed on the Azure platform. So Azure is currently having multiple services offered under its umbrella. As we discussed, we have more than 200 services offered under blockchain, computation, containers, databases, developer tools, DevOps, hybrid, identity, integration, Internet of Things, management and governance, media, mixed reality, mobile applications, networking, security, storage. So there are multiple solutions being offered under Azure that we can choose accordingly. All right, so first of all, before we jump into Azure ML, so first of all, let's see how we can work with Power BI individually so that we have a complete understanding on Power BI first. Now, Power BI is offered as a free tool for the individual users. So we can download the community version of Power BI that we can use for free. So we can refer to this link here for called powerbi.microsoft.com, and here we can click on start for free, where we have to enter our own details. And once we enter the details, we will be getting the direct download link that we can use for getting started. So here we can click on Power BI desktop and we can click on download, and then we will be taken to the download section altogether. All right. And once we have the Power BI desktop version downloaded, we can open this up. So here we can refer to Power BI. Now, Power BI is one of the easiest platform to get started with. So once we have this one downloaded and then we have opened it up, we can see this dashboard being open in front of us. And first of all, to get started, now this is the entire canvas that we had to work on. So here we can work on the entire data set, and here we have different worksheets, as in we can create multiple worksheets. We can get started here, And then we, on the right side, we have multiple visualization tool that we can choose based on the data that we have currently selected. So let's open up a sample data with us that we can work on so that we can have a quick insight of what kind of visualization that we can create here. So let's use a sample data set. To get data here, we can click on get data, and here we can choose a source of data. So if we click on more, we have data integration available from multiple platforms. So either we can import a simple CSV Excel file directly, or if we have data stored in a database, we can have the data fetched from multiple data sources, including MySQL, Postgre, Teradata, IBM, Oracle database, Impala, Vertica. So we have multiple integrations available. We can make use of the Power Platform in since these both solutions are offered by Microsoft. We have a direct integration available for the data solutions offered by Microsoft Azure that we can integrate this with. We have multiple offline services available where we can integrate this to Salesforce, to Google Analytics, to Adobe Analytics, to Facebook, to Marketo, MailChimp, LinkedIn, Facebook, Zendesk. We have multiple other solutions integrations available here that we can make use of. Let's say we want to work with the Excel sheet, a simple Excel file that we may have the access to. We can click on Excel. We can click on Connect, and here we have to choose the source of the Excel file. So let's say we want to work with a simple financial sample workbook. So here we can open this financial sample workbook, or we can open up the Superstore orders as well. We can use both the data sets. For example, let's say we want to work on Superstore orders. We can click on open. And first of all, this is going to read the data, and this is going to allow us to fetch a portion of the data that we are currently importing, or we can perform multiple ETL activities as well as per the requirement. So let's say here we have two tables. Here we have orders, and whichever table we choose, whichever sheet we choose, we can see a preview of the data available in this sheet. And then we have a people. We can see the data available for people as well. So now let's say if we want to import both or just one, we can choose one. Let's say we want to choose work with this order table, that we can click on load. And now the entire sheet is going to be loaded. All right, so now once the table has been loaded here, we can see all the columns available in the right side. And to visualize the entire data set, we can click on this option which says data. And here we can see that means we can see the entire data set in terms of the entire rows and column that we have currently imported. As you can see, currently there are 51,290 rows available in the current data set that we have imported as a part of our Power BI desktop. Now, once we have imported the entire data set here, we can come back to our visualization screen where we can start creating multiple reports out of it. So first of all, let's say here we want to work on importing city, or we suppose here we want to work on importing the quantity, or let's say we want to see the profit ratio here, right? So here we can see the profit, and now we want to see the order date, as in we want to see the, now we don't want to use this map here, we can remove this. We want to work on the profit and the order date. That means we want to segregate and see how it has been the profit in terms of different year-wise performance. And once we choose any two data set, we can see multiple the best suitable format for this given data set is going to be chosen in terms of visualization. So first of all, we can see the entire bar graph has been chosen, and we can easily increase and decrease the size of the visualization as per the requirement. So we can, suppose here we want to create we want to focus only on this one for the entire page, and here we can choose entire page, or we want to focus on different components as per requirement. Here we can choose the size accordingly. Means how exactly we want to increase or decrease the size for different parts of visualization. We can choose accordingly. All right. So now let's say here we have, in terms of access, here we have year, quarter, and date available. In terms of legend, for example, suppose here we have year, right? Here we have day, here we have, so suppose here we want to visualize this based on, suppose month. Then here we can define, here we can simply cross check. Let's say here we want to see the report based on different months, right? based on the year and based on, suppose not just based on year, but based on the quarter, as in quarter one, quarter two, quarter three. And then we want to see the entire report based on the month itself instead of quarter. We want to simply segregate them based on month. So we can see which month has performed really well and which month has not been able to set as per the current, or we can say current expectations. We can see the entire report here. And now we want to, now let's say here we want to work on the date hierarchy itself. For example, suppose here we want to work on year, quarter, month. Let's say here we want to display the quarter, right? So here we have this quarter data set here. And now here we want to display another table for quarter. We can choose that. Or suppose here we want to work on this table only. But here we want to make sure, let's say, just to avoid confusion, we can remove this. Now here we can choose this table. And now we want to display the variation in terms of year. But again, here we also want to display in the legends here, we want to display the multiple quarter data set as well. For example, we want to display the year-wise data set, but again, here we want to make sure that we are segregating them based on the year-wise performance. For example, now here we have seen that we were earlier projecting the entire data set just in year. That means year-wise performance. And now we want to see the detailed performance in terms of quarter, and again and that too for a different year. So what we can do, let's say here we can keep the under the axis here for the main, we can keep it to here. And now we can expand order data. So in order date we have segregation based on year, quarter, month, and day. Now we want to see a detailed report in terms of quarter. So here we can pick quarter, and here we can drop it under legend. So now we can see here we have detailed report on the performance, not just in one quarter, but again in terms of different quarters as well. That means how has been the performance for in 2012 in terms of different quarters, so that we have a better insight how we have performed in which quarter accordingly. And we can see here the entire legend has also been added here for quarter one, quarter two, quarter three, quarter four, correct? So we can segregate the entire data set. Plus, let's say here we want to segregate them further. So let's say we want to also showcase the segment as well. Segment also in terms of the legend. For example, segment as in which segment we have spent the most. For example, in which year consumer goods have been sold the most, or the corporate segment has been sold the most, or the home and office has been sold the most. We can define it as a part of segment. So it depends upon us how exactly we are going to map it out, what kind of problem statement we are going to solve. Suppose if a company asks us, okay, what has been the profit distribution for different segments in different quarters of the year? So we can simply use a segment to help them visualize, okay, now for the consumer products, the worst year was 2012 and the best year was 2015, where the consumer goods were sold the most, correct? And the worst year for the corporate customers, or for the corporate profit, was 2013, or was 2012 itself, where we saw a profit of almost 84,000, whereas in 2013 we saw a profit of 90,000, and the best year was 2015 itself, and so on, correct? So here we can quickly visualize the entire report of how has been the entire profit distribution in terms of different segments as well, by quickly showcasing the category report as a part of the requirement. And depending upon data set, here we have multiple integrations available with that we can make use of. For example, say here we want to visualize if we have some kind of geospatial data set. For example, here we can click on add, and here we can visualize the entire geospatial data set as well. For example, let's say here we want to see the profit distribution, and that too based on different cities. So now if we have this kind of data set, and now we can choose how exactly we want to visualize it. So instead of using the bar graph, we have the option for map. Now in map, we have this direct support from ArcGIS map for Power BI, or we can make use of simple maps section available that we can use it for visualization. If you want to use ArcGIS map, then we can simply choose the ArcGIS map, or we can make use of simple map tool offered itself by the Power BI itself. So here we can see, here we have plotted the entire report in terms of different cities for the global level. We can see the entire data set has been plotted. And now in terms of profit, right? So let's say if you want to see the segment as well. So here we can add segment as a part of the color. So suppose here we can add different colors, different tooltips also added here as a part of our segment that we can use it for visualization part. So now we can see here we had different colors defined, right? And we can see the entire in terms of now why we because we have added different segments and different colors. So you can see different reports here, right? So here red has been given to consumer, then we have the green given to the home office, and the blue has been given to the corporate as a part of the color segment. So we can simply visualize how exactly that distribution has been in different cities all around the globe as a part of the color segment. Or if you want to add this as a part of tooltip, then you can add tooltip as well. Tooltip as in if we hover over the over different items here, then only we are going to see the detail as a part of tooltip. So we can define it either as a tooltip, or we can define it as a part of the color scheme that we want to visualize. And once we are done, we can simply go to the file section, and here we can save the entire report. We can export this to the PDF as well, or we can generate a complete visualization dashboard where we can click on publish. And then when we simply publish, then we can create a complete dashboard through which the end users, they can interact with the entire data set that we have defined. So that they will be able to interact how the data has been defined, and then they can work accordingly. Now we can see how we can easily integrate the Azure ML Studio with Power BI. So let me showcase you how we can integrate the ML Studio as well. So Azure ML is what? Azure ML is basically useful in making sure that if we want to create a model for testing use case, then we can do that easily by using the ML Studio itself. ML Studio is a really good platform, one of the best services offered by Azure. And we can say that it is even better than any of the cloud computing platforms that we have present currently. So its ML Studio is really easy to use platform through which we can create the entire testing models. We can deploy it right away as per the requirement. We can easily do that. So first of all, to get started, we can start by signing up on Azure platform. Let me showcase you how we can sign up on these. All right, so to get started working on Azure, we can simply click on this link here, which says create free account on top. And once you click on free account, we will be taken to a complete sign up form where we can register. So for signing up on Azure platform, we can click on the link which says free account on the Azure website. And there we have to sign up just like we sign up for any other website, where we can specify the account details. And just like we need to have an active payment method for Netflix and Prime Video, we also need an active payment method for signing up on Azure. And once we sign up, we won't be getting charged once we sign up for an account on AWS. We would be getting $200 of free credit that we can use against our billing for a period of 1 month. And just like we get $300 of credit when we sign up on Google Cloud product, which we can install in 1 year, and in AWS, we get the access to some selective free tier services that we can use under limitation. So same way here, we can also get the access to the services that we can make use of. So you can sign up on the platform. Here you go. And once we log into AWS or to Azure platform, this is the dashboard that we look at. And here we can click on the menu icon where we can see all the resources, resource group, app services, function app, SQL databases, on storage accounts, on virtual networks, Azure Active Directory, monitoring, advisory, security center. We can see the entire report as per the requirement. We can see the entire report. So to get started working on the ML Studio, we can search for a link directly called ML Studio from Azure. So here we can type in as studio.azureml.net, where we can log in via our own Azure account that we have signed up for. Here we can click on sign in. And once we sign into this link, we would be taken to the Azure ML Studio that we can use for getting started with the machine learning models deployment. So in the Azure Machine Learning Model Studio, here we can work on creating multiple experiments. So for example, suppose here we want to work on experiments. We can see these are a list of all the experiments that we have already created. And now we want to work with new one. Then here we can click on create a new assignment. So here we can click on new. And here we can choose what kind of experiment we want to work on. For example, we want to work on the experiment tutorial. We want to work on a blank experiment on dataset processing. So there are multiple templates available that we can choose here. So let's say here we want to work on blank experiment. So here we can click on blank. And here we can simply map out the entire dataset. And here we can create the entire experiment as per the requirement. We can do that directly here. All right, so here we can define the entire output and create the entire testing scripts so that we can run those testing scripts automatically and that to as quickly as possible. All right. So first of all, we have to work on uploading the current data set as well. So if you do have the access to data set, so here we can refer to save data set where we have my data set. So now currently, let's say we have our data set available for COVID-19 and let's say we want to work on it. So here we can simply import the COVID-19 India.csv. For example, here we can pick this data set and then now we can use this current data set to use or to suppose, let's say, to create a complete model out of it. Now for this, we have to, again, in case we don't have a data set available, and here we can click on samples where we have sample data set already available that we can play around with, or if we want to work on our own data set, so here we can click on this option data set, and to start new, then here we can simply click on new. We can choose from a local file. Let's say we have used a local file for the sales data, right? And now we want to create a sales prediction out of it. Then here we can create a model for that sales prediction as well. For example, here we can choose a local file that we want to work with. Let's say here we had the access to that Excel file, correct? To that Excel file, XLS. So where we have the access to this global superstore, we can make use of this data or we can make use of any old data that we may have the access to. So for example, we want to work on this one. So here we can click on upload, open, and then we can click on add. So this is what, okay, we haven't saved that in the CSV file. So let's see if we do have the access CSV that we've already imported as a part of COVID India analysis. Where we have data set for the active COVID patients, for the recovered patients so far. So we can make use of this data for now. Now to work on creating a model out of this current data. So here we can go back to the experiments where we can create our own experiment. So here we can come back to experiments. We can click on new. Here we can click on experiment, not tutorial, on blank experiment. We can have the access to this one, and here we can simply drag and drop it here. Now to see it, now here we can simply click on data set, and here we have visualize. So we can simply get a complete visualization created so we can see how, like, what are different pointers available in this current data and then how exactly we have to work with these. So let's start again. So first of all, let's say we don't want to use the entire data set available here. We only want to make a selection. So for doing that, we can search for select data set here, and here we have select column. So let's say here we want to be selective in terms of the column that we want to choose. So here we can drag and drop the select part. And now we can define select. Here we can click on launch column selector. So here we can choose which all columns we want to work on. And then we can, now currently we have these different data pointers available. So we have to choose from these data pointers only, that which data pointer we want to work with. So here we can make a selection accordingly. Let's say here we are going to work on the prediction for the survival rate. So let's suppose here we want to work on, here we want to include confirm international. Here we want to confirm the cure, and that's as well as a part of the data pointers that we want to work on. So here we can define the data as well. Now these all columns you want to work on here, and here we can click on select. So again, these different columns have been selected as a part of our model building. Now here we can search for another data pointer here as split. So here we can make use of split. Now we want to split the current data set into equal components here. We want to have the train data and test data defined. So here we can split the entire data into training and test data because we don't use the entire data set. We split the entire data set and that's how we start working on it. So here we can split the entire data set into one training and the other component to be testing data. So here we can define the fraction with which we want to test here. Let's suppose here we want to make a selection of 75% of the current data set. So here we can define 0.75. That means again, suppose if there are 100 columns, there are 100 different rows here, then 75% of those rows are going to be split. That is what we have currently defined. If you want to make a selection in terms of 50% or 75%, generally we keep it to 75%. So we have a good amount of data that you can use for the training purpose. We can define it. And then if you want to randomize splits, then here we can simply click on randomize splits, or we can keep it to just one. So now we have defined in the splitting of data how data is going to be split in 75 and 25%. And here we have defined for 75% for the first component. For the first component here. So here we can define machine learning. So here we can search for machine learning algorithms. Now there are multiple machine learning algorithms available here. So let's say here we are going to make use of. Now here we can make use of, let's say, which model shall we select? So here we can make use of, let's suppose two class decision forest. So here we have two class decision jungle and this one is forest. So here we can simply drag and drop two class decision forest. We can place it here. And then here we can insert the training model as well. So here we have on the machine learning. Here we also have train model also available. So here we can also drag and drop the train model. All right. So here we can split the entire data set and again we can use it for training the model. And then we have decision tree. And here we have decision tree. So basically here we can use a training model here and then the decision tree we can integrate with this with the entire training model that we can create here. So once we define the entire training, once we have connected the two decision forests with the training model. So again for training model as well, we can simply launch the column selector in terms of which column we want to make use of. So here we have rules and here we have defined the column names. If we want to include the column names, or let's suppose here we want to search for the confirmed national. Here we want to search for not just for confirmed, the number of patients cured, deaths, and the time frame as well. So we can remove the confirmed national. So here we can choose these pointers, click on select. Or suppose here we want to make use of the confirm as a main parameter. We can choose confirm, we can select. And here we can simply define the score model. So here we can search for score model. We can define the score model. And here we are going to test the score model here along with the components that we want to integrate this with. And once we are done, we can simply run it to see. Now, if each and every step is correct, we will be able to see the entire model created one by one. That means currently each and every model statement is currently being executed one by one. And if there are no issues, it is going to be deployed automatically. And now if we want to visualize, and here we can right click on it. Here we can click on score data set, and here we can visualize to simply see the entire score based distribution that has been currently derived for each and every data pointers here to what we have defined. And here we can set up the predictive web services, which is currently recommended. So as you can see here, the entire model is going to be defined and deployed for creating the entire predictive experiment. So the entire experiment is currently being deployed automatically. And same way we can integrate this entire component by taking care of a simple R script back in Power BI through which now using that R script, we can easily create the deployment and have it done.
So by the end of this demo, you would be able to answer basic questions on what are the basic views on the Power BI desktop, how to import datasets into your model, how to transform and edit your dataset, how would you create a report on the Power BI desktop. I'll be also giving a few visualization tips and helping you out with a few custom visuals. Before ending, I would like to talk a little bit about the Power BI mobile app and the ideas at the Power BI website. So with that, let's move to our Power BI desktop. Now here I've had it open from some time, but if this is the first time you are using the Power BI desktop, you might have, say, a yellow pop-up which shows various different videos and tutorials. But you don't need those tutorials because you have this tutorial. So without wasting much time, let's get right to it. So since you're using this tool, I'm assuming you guys have already pulled in some data for your report already. Here is the Get Data button. It gives you a bunch of different sources. We have the Excel, we have the SQL Server. You can even scrape off data off the web. I'll be using Excel data. These are some of the data sets that I'm going to be using today. We have a bunch of data regarding the bikes that are going to be introduced in 2018, and we have our PUBG data, something because of which a lot of you might be present here today. So all you have to do is click on it. Yeah. So once your data is imported into the model, it should look something like this. You should be able to see a preview of your data. Since I have already loaded this data, I am going to cancel it. But for those of you who haven't, you can just load it here. So now when you have imported your data, your view should look something like this. This is your report view. This is where you make your report. It's a nice blank space. Yeah, it's also called a canvas. There is a visualization pane here at the right. It gives you access to a bunch of different charts to visualize your data and analyze your data. You get access to a gallery of custom visuals from here, the marketplace. And also from down here, you can pretty much control everything about the appearance of your visuals. Further right, you see the data sets that you've imported into your model. I've got a bunch of different bike sets and some PUBG players data. Okay, now this is another view. This is your data view. You basically get the preview of what your data looks like. So I want to point out a few things before you begin actually creating a report. Try renaming all your columns into how you would like to see them in your dashboard or your report. You must always remember that you are creating this from a user perspective. So your naming conventions and data types are going to appear at the surface to your user, and you want it to be as interactive and comprehensive as possible. So I've already renamed everything right here. Another thing, that anything that's not absolutely necessary in your model, just delete it. Because it's basically going to contribute to the size of your model and take up way more system resources while processing. Here I have nothing to delete, but I think I shall be hiding this column because nobody needs to see this. Just a right click and hide in report view. As you can see, this entire column has been grayed out, and once you go to the report view, you won't be able to see it. Okay, so this looks good. I don't want to spend much time on this. I only wanted to show you a gist of how you can make these changes to the model. So let's start building some charts. Building charts here is very simple. On the PowerBI desktop, I'll be using the bikes dataset as I had mentioned before. All you have to do is take a field and drop it on your canvas. I am going to take the type of bike, drop it on my canvas, and the count, and drop that on my canvas as well. Change it into, say, a column type chart. As you can see, a bunch of all the bikes that are going to be launched in 2018 are going to be the cruiser bikes. This dataset consists of the top 50 bikes that are going to be introduced in 2018 or already have been introduced. So at top we have cruiser bikes, then we have a few cafe racers and super bikes, and a few others. Now let's try a few other graphs. Okay. Remember to click outside of the box when you want to take a new graph, else it'll change your graph like it did to mine. Let's take this line chart for example. You can also use a KPI, but I prefer the line chart here. I'll take the month and drop it, and the number of units and drop it. Great. As we can see, there have been spikes in the March of every year. For some reason, people love buying bikes in March. Next, let's just try something new. Let's just add a multi-row card. I'll just keep adding fields. Let me just add, say, the name of the bike, the company, the type of the bike, and let's say the on-road cost of the bike. We have some Ducati here, some Bajaj, some Triumph, a lot of Triumph, some Royal Enfield, some Harley Davidson, and so on and so forth. So this is basically the easiest report that you could make. It took barely like 2 minutes and hardly 10-12 clicks. So the great thing about these visuals is that it is so interactive right from the bat. All I have to do is select one bar and it's going to show that on the table. With the line graph it works a little differently, but you get my point. Another thing is I can change and control how my report looks visually. So let's just add a text box. Let's see. Bikes of 2018. You can just choose a font that you like, a font size that you like. I'll choose a 60. Let's just put it up top here. Anything that you feel would make your report look more beautiful, just do it. Along with that, you can add a few images, a few shapes, like a few line, oval, triangle, arrow. I'll be taking an arrow and putting it right here because why not? There. The simplest dashboard ever. Now a lot of you might wonder, I said dashboard a few times and I said report a few times. Mostly these two terms are used synonymously, but what is the difference? And I assure you there is one, and a major difference. It's basically how these two are utilized. So a dashboard is something which summarizes the data. You can take a bunch of different data sets and then bring them into one sheet in a dashboard. And a report is something which will elaborate on your data. So basically, you take one data set and you want to show individually for each column what it wants to portray. That is your report. Yeah, so basically, the bottom line here is a dashboard summarizes data, whereas a report elaborates on data. That's my understanding of it. Okay. That's a simple graph, and this is a way more, say, colorful graph. We can see a bunch of BMW, some Harley Davidson, some Triumph. It's so interactive, and I don't even have to do anything. All I have to do is make a few graphs from the same data set. And everything else is taken care of by the Power BI. Go to the formatting tab, data colors, and choose all the colors that you want it to have. As we can see, if we select one, you can see the cruiser bikes in all different companies. Here in the pie chart as well, the donut chart, I'm sorry, here in the tree maps. But out of all these bikes, I have a certain favorite, and I'm sure a lot of you might have it as your favorite. That's the Harley Davidson. Come on, let's face it, it's a very, very cool bike or set of bikes. So here I have on the map of the Indian subcontinent all the different dealers that have their showroom for a Harley Davidson. The red ones are the cities which have one dealer, yellow 2, and Bangalore, being the only city with 3 dealers, is in green. And here we can see the number of units of Harley sold since Jan of 16 till December of 2017. Again, like I had mentioned before, for some reason, people seem to buy a lot of Harleys in March. There you go. If I select a certain city, it gets zoomed in the map. That's just how interactive this tool is. So of course, I can go and change the format and order of these visuals. Next, we have a lot of people must often create reports on a weekly basis. This is where sorting comes into picture. Look at this graph. I mean, when you look closely, you can see that the days are ordered alphabetically by default. Now, the Power BI does not know that your sales by days refers to the days of the week. So obviously alphabetical order, so Friday comes first and Wednesday comes in the end. Very logical according to Power BI, but we all know it's wrong. So we have to fix it. You have to tell Power BI that these are not just words, but days of the week. So we open the data set it's from. It has days and sales. We're going to select the days column and go to the modeling tab here, and there is something called the sort by column. Go there and select the order. And there you have it. It's fixed. Monday comes first, Sunday comes in the end. I wonder what office this is, which is even functional on Sundays, but it makes for great data, so who cares? Another thing is this funnel chart. As we can see, A funnel chart is supposed to look like a funnel, which it clearly does not. If we sort this out, then we can just select the stage and go to the sort by column and select the stage order. There we have it. Our funnel looks like a funnel. As you can see, it starts with the lead, then potential, and comes down all the way to the number of deals closed. This is a proper order, and with that, I am here at the last. This is the last from this particular data set. It's the last update. So another thing you can do with the Power BI is see how fresh your data is and when it was last updated, right? So you can do it a lot of ways, but I prefer the edit query editor function in the Power BI desktop, or a lot of you might know it as the Power Query. All you have to do is select this, go to your home and edit query here like so. Then you can create a query, like here I have the last updated query. You can just close and apply. And there you have it. You can simply create a query like so, and here I have given the formula for your live date and time. You can even append text to it, but I like it this way. It's simple. So just like that, it creates a dynamic text string, and you can use it in maybe like a card, like I have used this little icon 1 2 3 written on it. That's the card visualization. This is a live tile and it changes with the data set underlying it. So you can do things like turning off the label or making the text a little bigger, a little smaller. All you can do is you can go to the data label, and here you get the text size. You can increase the text size, you can decrease the text size. And every time you hit update, it gets updated. Pretty useful, yeah? Now let's move on to our next segment of the module, that is conditional formatting. For this, I have a separate data set, and that is probably the data set which this thing is getting sold on. So I think I should explain this data set and where this comes from. A lot of you might know it, a lot of you might not, but this looks pretty morbid with all the bombs and weapons and the death and all. Now, how many of you have heard the game PUBG? Heard of the game PUBG? Can I have a show of hands? Okay, great. So for those who have, for those who haven't, it's one of those player versus player games where you go around killing a bunch of your friends. It's great. Some good, clean fun, right? But what's better is that all the data that you've generated on the game is available through an API. So I've acquired these datasets using various gamer tags, and it has an entire history of how many minutes you've played, what weapons you've been using, what maps you've been playing on, how many you've killed, how often you've been shot, all this great data. And I thought it would make for a great demo. So here we go. I have two datasets here. One is a PUBG data set which has all the ways people have died, the killer names. It's a set of 100 different players. And another one I've got here is a player's data. It consists of 20 specific players and their kill to death ratio. The KD ratio here is the kill die ratio. Let's just call it that. All right, so let's go to our dashboard. Conditional formatting. This is already done. Let me bring it back to its basic state. So yeah, so one of the most common things people say is that I just need to be able to change the color, which is pretty basic formatting. So my answer to them is, here is this paint roller sort of icon. You can click on it and you get this option called data colors. And of course, you can always change the color of your data depending on your company color. Like I can change this into a green, or maybe say a lighter blue. It's great for anybody that's colorblind. Yeah, but what you could also do is that you can change this into a color dynamic pattern instead. You can obviously just add solid colors, but you can also change the color saturation according to, let's say, the number of absolute kills. Let's take this field and drop it at the color saturation right here. There. So green being good, red being bad. Player number 20 seems to have the best kill to die ratio, but as you can see, he isn't doing pretty well in the absolute number of kills section. Whereas this player right here, this player number 15, has a lower kill to die ratio, but has a better kill record, let's say, than the player number 20. A lot of killing talk going on here. I assure you, this is no real world data. It is just the game. So this is a PUBG dashboard that I've created. This graph obviously shows the previous graph, which I showed for conditional formatting. Here, this is a map which is based upon where the here is a map which is based upon where each player is from. There is something very important I have to show you about the map. So let's just open the player's data in the data view. Now, as you can see, it has a latitude column and a longitude column for each player. Now, your MSBI just will notice that these are numbers. We have to tell the MSBI that all these numbers here are latitudes and all these numbers in this column are longitudes. So what are we going to do? We're just going to go to the modeling tab, select your column, data category, and by default it is usually uncategorized, but you're going to set it to the longitude. And same goes for the latitude. I've already set the data category. That is how I've been able to make the map, else it wouldn't take on those numbers. Now, here's a pie chart which tells how most people have died. We have down and out, which is most people. Then we have the M416, and then we have the M16A4. Pretty popular ways to die. I'm just happy this isn't real data. Just putting it out there. Another thing you can do is make use of the cross highlighting to know specific data. So here I have made two different charts, a bar chart and a column chart. Here it shows how a bunch of people have died, and here it shows who has killed those bunch of people. Like this is player data, and once you select any player here, it just shows how they've been died, how many times they've died and how. So again, down and out from the grenade and the M24. If I choose another player, it shows the same. So MSBI is always this interactive. The MS Power BI is always this interactive. It's just how it was designed. It was designed for those people who didn't want to code in the background, or let's say who couldn't. So anybody who can visualize data can use this tool. Next, we have a few other graphs. Like, I really like the scatter chart, so I made it according to players right here. It shows how they've performed. The bigger the bubble, obviously, the better record they have. On top, we have the legend here, which shows the color assigned to each player. Next, we have our custom visuals. So I'm going to be using the KPI visuals here. This is the basic KPI, this ticker looking icon over here. It has a red and a green ticker. Basically what a KPI does is it will answer two questions. Firstly, how far or close to your goal are you? And secondly, what has been your performance over a period of time? So all the companies use this KPI, or the key performance indicators, to monitor their internal and external performances. Internal as in team-wise performance, maybe the performance of the marketing team or the sales team, and external performances as in the overall performance of the company in the market. So these are a bunch of custom visualizations. Remember, I had mentioned right in the beginning that you could go to home and there's something called from marketplace. I'm going to select that. Here you can choose from a bunch of different custom visualizations, but since we are using KPIs, let's just select KPIs. And right at the bottom, you will find something called the KPI indicator. All you have to do is add it to your model. I've already added it to my model, and it will appear right here in the visualization pane next to all your other visualizations, and you can use it just as easily. So the thing about these custom visuals that I really like is the solid background color that you get. It really makes your reports pop, and the graph here you can see is in solid lines, and you get variants of the same graph. So suppose I take this, I can go to the formatting tab and choose KPI colors and choose the background color. You can go to KPI general and choose your chart type. So we have three different charts here. We have a line, which this chart is. Then we have a line and no markers, and you can see all the bubbles here are gone. And then we have a bar chart. Pretty simple, right? Then we have something called the banding type. Increasing is better, decreasing is better, or closer is better. So there are three cases. First, say something like the money you've acquired over a period of time. The bigger the better, right? So in such a case, increasing banding type is better. But what if it's about the money that you've been penalized to give? For such a thing, I think a decreasing banding type is better. That's where you put the decreasing banding type, and see, your entire graph turns red. And then we have the closer is better. This is an option which is not available in your basic KPI. You'll have to use a custom KPI for it. So when you have experimental data, like say drugs or medicines, the closer it is to your ideal data, the better it is. In such a case, closer is better. Now the prerequisite for KPIs are you must always have a target value. So this is the bike sales chart. If we just open it in the data view, so this is what a KPI appropriate data should look like. It should have an actual value column and a target value column and a trend. This is how your key performance indicators are made. Now I think we've already made a pretty big report, so I think we're ready to publish this. So there's a publish button in the home ribbon right at the corner, extreme right here. All you have to do is press the publish button. And here at the Power BI website, it gets uploaded. You can see how it's as interactive as it was on the app. Nothing has changed. Yeah. So the best thing about this is you can even use it on your desktop, but you can even use this in your mobile apps. And this is a pretty open data set. Like, I can share it with a bunch of different people, which is the reason why this data is on YouTube right now. But a bunch of you might be using Power BI for, say, company purposes or really confidential data. In such a case, you would want it to be with a limited number of people. So for that, there is an ellipsis right here, these 3 dots on the extreme right. What you can do is select the option Generate QR Code. Now a QR code connects anything in the real world directly to the related BI information. You don't need any navigation or search. So the colleagues you've shared the dashboard with then can scan the QR code for access to your tile or your report right from their mobile device. They can use either, say, the QR code scanner located in the Power BI app or the mixed reality app, which is also from Microsoft, or any other QR scanner which is installed on the device. All you have to do from here is you have to download it, and then it will be saved as a JPEG image, and then you can mail it to people or print it out, whatever, it's your choice. I hope you found all the ideas and the tips that I've given really helpful. There is actually another place where you can go and search for ideas. It's ideas.powerbi.com. This is a forum basically which shares ideas about Power BI, and when people have queries also they come here. Let's see, the top search is copy paste from Power BI desktop. Seems to be pretty popular because people want the copy paste functionality from Power BI to their reports in Excel and so on. We have a few more ideas. Even if you have ideas of your own, this is a place where you can share them as well. Just had to put it out there. With that, I think I've concluded my session about the Power BI desktop and how to create impactful reports on it.
So if you're someone who's not from India, IPL is the Indian Premier League, which is a professional 2020 cricket league in India. And it is usually contested between March and May of every year by 8 teams representing 8 different cities or states of India. Now, the league was founded by the Board of Control for Cricket in India in 2007, and it's been going on since then. So today what we'll be doing is we'll download the IPL data set from Kaggle, and we'll visualize this data set on Power BI. You can see that I have Power BI desktop on my desktop, and once I click on that, it will just allow me to get started, and I have pop-ups that occur. So first thing what we're going to do is we're quickly going to talk about the interface. So the interface is very interesting. It's very easy to understand too. It's not very complicated. You can see you have a menu on top. You have, as usual, file where you can create a new file. You can save those files. You can get data. You can import, export. You can check out options and settings. You can also get started. You can sign in. You can read about Power BI too and things like that. Okay. Once that is done, you also have home, and this will just redirect you to the home page of Power BI Desktop. You can also insert new pages. You can add a blank page, you can add duplicate pages, you can add visuals. These are a little more complicated as of now. We don't really have to discuss this, but maybe elements are important. You can add text boxes, buttons, shapes, images. All of this may be useful later on. Also, in the modeling option, you can add tables, you can add new parameters, you can choose a language. That's great. And in the view option, you can pick themes, right? There's current default themes. You have city park, you have classic theme, you have classrooms, you also have page views, you have mobile layouts, and you also have filters. You can put grid lines if you want an idea of how to create your visualizations, all of that. And if you want any help with the community of Power BI, Microsoft has a great set of community. You have guided learning, you have training videos, you have documentation, you have various examples. This is great. Okay. So once that is done, I'll just quickly switch back to home. And you can see that this page that we currently on, that is home, is very, very important. Okay. This is where you'll be mostly working on. So this is pretty important. Here you have the get data option. And this is where you're going to import your common data sources. This is where you're going to be getting your data sources from. So you can get your data sources in form of Excel sheets. You can also get Power BI data sets, data flows. You can also get in terms of SQL Server, text or CSV files, even via web, and also blank queries and much more. You have a lot more options you can get your data from. Okay. And you can also import data from a Microsoft Excel workbook. You can create a live connection to data sets in the Power BI service, that is cloud service. You can also obviously import SQL Server database, which is really important. Most of the organizations work on SQL Server, so importing data from SQL Server might be a very, common option when you're working on Power BI. So they've just given a separate icon to import data from a SQL Server database. And you can also create a new table by really typing or pasting in new content. You can create your own database, right? If you have small content and you want to go ahead and create it yourself, you can just enter data by yourself by clicking this option. And the data verse option will allow you to connect through its SQL endpoint. This is not really that important for now. And you can also manage and connect to recent resources. Right now, we don't have any, so it just says more. You can also transform data. Okay. So this is a really interesting option that is present on Power BI. You can really, add queries and transform data as you'd like to. So this will really allow you to do that, right? Transform data. And moving on, you can create new visuals. You can add new text box. You can create more visuals and a lot of things. So I clicked the create new visual and it just created a new visual for me. I'm just going to remove this for now. Okay. And you can create new measures. There's an option for calculations. There is an option for sensitivity, and you can also publish it. You can share it with your friends. So these are few options that are available at home. Now, if you look at the bottom, you can see page 1. If you want a new page, you can click the plus icon and it will create a new page for you. And you can just shift around with your pages. Okay. And if you click another plus button, it's just going to shift you to page 3, page 4, etc. If you want to delete it, you can just click the delete option, the remove option, and it will delete the page. Okay. We don't need 3 pages as of now. So I'm just going to delete all of the pages except page 1. So that is done. Now the interesting part is you have filters, you have visualizations, and you have fields. You can just click on these arrows to hide all of these options. And since we're going to be learning about them, we'll just open them. So the filters will allow you to search any of the data fields that are present here. You can add data fields that are there. And the visualization is the most important part. So fields will just allow you to really import the data. If you import the data, all of the data and its tables and the entire content of the data that you've imported will turn up in the fields option. We'll see that when we download the IPL data. And when we import that, you'll be able to see the data here. Okay. So once that is done, you can visualize the data. So you can just drag and drop the data, and you can choose various visualizations. You can choose a bar chart, you can use a pie chart, you can use R script visualizations, you can use tables, you can use matrix tables, you can also use charts, and you can also use maps. You can really visualize these data in various forms, like forms that you could never imagine. And that's the real advantage of Power BI. It will allow you to play through your data and really get a hang of it, and really understand your data in detail. And you can also add the data fields here which you'd like, and then choose the visualization for that data. So you can really like have fun with your data using Power BI. Now with this, let's move on to the left side of Power BI. You can see the three icons. The first one says report, the second one says data, and the third one says model. Currently we're on the report option. If you click the data option, the screen changes, and if you click the model option, then the screen will change too. So this will just allow you to create reports and visualize your data in a certain way. This will just give you an overview of your data. So the model option will just make you really identify data sources and create relationships between your data. Currently in this session, we'll just be working on reports, so we don't really have to bother with data and model. And this is all for the user interface. It's pretty easy, right? It's not rocket science, it's very easy. Now let's go ahead and download our data set. Now I'm just going to go to Google and click Kaggle. If you aren't part of this community where you can download any data for free, then you've definitely been missing out on a lot. Definitely sign in and create an account on Kaggle, because you'll be able to download a lot of data sets and really, work on them. I'm just going to search for IPL data set, and I'm just going to scroll a bit down, and you can see here there's a data set by Prateek Bhardwaj, and there is a complete data set of IPL from 2008 to 2020. I'm just going to click on this. Now let's see what he has on his data set. So you can see that there are two data sets. One is ball by ball and the other one is matches. Okay, so I'm happy with this. They're just two files, and we'll just import both of these files. And I'm just going to click on the download button, and this will automatically download the zip file of this data set. Once that is done, I'm just going to check out the first data sets, that the ball by ball data sets. Here you have the ID, you have innings, you have the number of overs, the number of balls, the batsman, and non-striker, bowler, batsman, extra run, total runs. You have a lot of information. The bowling team, there are around 8 teams in the IPL. You can see that that's mentioned here. There's batting team, there's bowling team. And this just gives you a ball by ball information. That's a lot of data. Okay. I'm just going to close this, and then we're just going to check out the matches data set. Here you can see the ID, you can see the city, the date, you can see the man of the match here, the venue, and you can see the teams who won the toss and what was the decision after they won the toss, the winner, the result, and there are a lot of information, the umpires of the match. All of that is given in the matches data set. So this is great. I am happy with this data set. So I'm going to go ahead and import this in my Power BI desktop. So now I'm just going to click get data, and I'm just going to click text to CSV. Just going to go to downloads, archive, and I'm just going to import ball by ball first. And I'm just going to click load. Now you can see that automatically in the field section, all of the data in the ball by ball data set has been automatically loaded and placed in the field section. Now I'm just going to again click get data, and I'm just going to click text or CSV, and I'm just going to click IPL matches data set, and I'm going to open that. I'm going to click load. Once that is done, you can see that you have the IPL matches data set in the below, and I'm just going to click this. Okay, and you can see that you can just click these buttons to really select the data that you want to use. Okay, now what we're going to do is we're going to visualize some data. Okay, so let's visualize the batsmen that have been playing in IPL. Okay, so what I'm going to do is I want to view the batsmen that are currently playing in IPL, okay, from 2008 to 2020. So I'm just going to drag batsman and I'm going to drop it in the between. And you can see that there are a list of batsmen according to the alphabetical order. Now, if I want to visualize this on a column chart, I am just going to drag batsmen again, and I'm just going to add it in the values field. And this will just give me an overview of the count of batsmen by batsmen, okay? As you can see that Virat Kohli is currently the batsman who's made the most number of runs in IPL, followed by S. Dhawan. So now that we have represented the count of batsmen in the form of bar charts, what we're going to do now is we're going to give colors to each of these. So we're going to change the colors of this. So what I'm going to do is I'm going to click the paint bar icon and I'm going to click on data colors. Once that is done, if I scroll down, you have the option that says off. Okay, it says show all off. I'm just going to click this to on. And you can see that you can really select colors for each of these because Virat Kohli has been playing for RCB and RCB is represented mainly by red and black color, mostly red from the past how many ever years it's been there. I'm just going to click on a red color for RCB. Just going to click on more colors. I'm going to pick a more precise color. Okay, this looks great. And here you go. You have red color for RCB. And then you can change the colors for all of them, all of the legends. And you can really play around, It's great. So this is to represent in terms of, bar charts. And if you hover your mouse over each of these legends, you can see the names and you can see the number of runs they've scored over the entire course of IPL. It says 4,609, but I don't think it's very accurate. It says S. Dhawan scored 4,208, and then it says RG Sharma scored 4,088, and so on. So the number of runs scored by the batsmen throughout the IPL is mentioned over these legends. So if you want to filter out batsmen only from a particular team, you can just look for them and then just select them and then just make a bar of them, right? That makes more sense. That's one filter you could play around with. You can also add data fields here. Now, if you scroll down, you have an option that says count of batsmen is all. Show items when the value is less than 4,000 and is greater than 2,000. And I'm going to apply this filter. And you can see the list of batsmen. The first one is David Warner. The second one is R.V. Uthappa, Gautam Gambhir, and so on. So you can really, play around with queries also on the filter side. And you can visualize on the visualization side. And on the field side, you can pick your data. So this is amazing, right? Now let's create a pie chart for the bowlers. So as usual, I'm just going to grab my bowler and I'm just going to drop it on the page. And you can see there's a list of bowlers that are mentioned here. So what we're going to do is we are going to click the pie chart option. And what we're going to do is we're just going to again drag bowler here and then going to add it in the values field. That is, we're going to drag and drop it in the values field. So as you can see, there are a lot of bowlers. The first one on the list is Harbhajan Singh. So we're just going to make this list a little more small. So as you can see here, the pie chart already has various colors assigned to various bowlers, right? This is not the case in the bar chart. So that's the disadvantage. If you want to represent different teams or different bowlers or batsmen in different colors, in a short amount of time, if you don't have that much time, you could just pick a pie chart. So what I'm going to do here is I'm just going to add filters, okay? So count of bowler is less than, maybe you could say 2,000 and is greater than 1,000. And I'm just going to apply this filter. You can see the bar is much more better in visualization. I'm just going to move this in the side. You can reduce this more if you'd like to. So in page 1, what I've done is I've just represented the number of batsmen and their runs, and also the number of bowlers and the number of balls they have bowled. So I hope this is clear. It's really simple, right? It's not really that complicated. There's a lot more to learn when you keep exploring Power BI. So let's now go to page 2. Okay. Now what we're going to do is let's scroll down. Let's look for something interesting. Let's look at IPL matches dataset. Let's represent toss winner. Okay. I'm just going to grab this and I'm just going to drop it in the page. And I'm going to represent this in the form of a donut chart. Okay. I'm going to again grab toss winner and I'm just going to add it in the values field. And if I make this big, you can see that Mumbai Indians has won the most number of tosses in IPL. Throughout all the IPLs, Mumbai Indians has won the most number of tosses. Okay. Moving on, we have Kolkata Knight Riders, then we have Chennai Super Kings, followed by Rajasthan Royals, then we have RCB, and then we have Kings 11 Punjab, and so on. This is a really nice way to represent a small amount of data, the donut chart, because it's very evident that Mumbai Indians won the most number of tosses. Let's create another page. Let's also check out the venue. Let's represent the venue. Okay. I'm just going to drag and drop this. I'm going to represent this as a bar chart. Again, I'm going to drag and drop the venue in the values field. And I've represented in the bar chart. Okay. So what I'm going to do is I'm going to make this a little big. So you can see that the number of matches that are played in Eden Gardens, Kolkata is the maximum, that is 77. And then we have the Firoz Shah Kotla Stadium, then the Wankhede Stadium, followed by M. Chinnaswamy Stadium, and etc. The list goes on. So the thing about Power BI is that you cannot manipulate the data. You cannot make changes to the data set. Okay. All you can do is you can visualize it in any form and you can just reduce the size of the data and you can also view what particular data or specify what kind of data you really want to see. But you can't really make changes to the data. That is important to know. And again, you can add a lot of filters like is less than or equal to, is greater than, is not, is blank, is not blank. All of that filters can be easily added so you can represent your data. There's an interesting data that is available that says winner. So let's check that out. I'm just going to drag and drop this. And then I'm just going to click on pie chart. I'm just going to drag and drop winner in the values field. And you can see that again, Mumbai Indians has taken over by winning 120 matches, followed by Chennai Super Kings by winning 106, and then followed by Kolkata Knight Riders, and then Royal Challengers Bangalore, then Kings 11 Punjab, Rajasthan Royals, and so on. So this is really what Power BI is all about. You can play around with all of the data. There's so much data, especially in the IPL data set. You have batting team, you have extra types, innings. I showed you the most basic ones, but if you're really interested in knowing the intricate details of all of these IPL teams and really understanding and getting an insight of the past, form of all of these teams, you can really represent these in terms of all these visualizations, add filters, really play around. You don't really have to put a constraint to yourself. I have just showed you the most basic things. I have created a bar stack. I've made use of a bar chart. I've made use of a column chart. I've just made use of a donut chart. And then also I've made use of a pie chart. I've also made use of the basic fields, that is the batsman, bowler, the venues, and the winners who have won the number of matches, and things like that, the venue also. So this is really basic, but I hope this helps you to give a kickstart to your IPL data visualization and you really get to play along with it more.
Our first project or first case study is an end-to-end sales dashboard. In this case, what we are going to do is that we are going to explore the internal sales data set of a mock company and analyze it from the perspective of business. We are going to look into different products, employees, and supervisors to determine their individual impact and overall impact on the revenue of the entire company. And for that to happen, we are going to design and create a sales dashboard in Power BI, which we can publish and share on Power BI service. There are a couple of actionable items that you can see in front of you. We are going to tackle each of these actionable items one by one. So let's move on to our demo machine. So this is how Power BI Desktop looks like. This is the latest version as of the March of 2020. Before we begin, the first thing I'm going to do is I'm going to get data. This is an Excel spreadsheet, so I'm just going to get it real quick. Okay. Now, as you can see, this data set has three different tables. We have the employee master, which has the employee ID, employee names, and the supervisor under which the employee functions. Then we have the product master, and this has the product ID, product name, and the price per unit. And we have the sales data. Now this looks more like a fact table, which has the date, the employee that made the sale, the item sold, and the number of units sold. And these are all of our tables. Now, if you are happy with your data and you think it is a usable data model on which you can directly go and build up and lay your analytics on top of, you can click on load. But I'm going to transform this data and clean it up a little bit before I start using it. This is going to take some time. Now what this does is it opens up your data in something known as a Power Query Editor. Now one of the reasons why Power BI is such a powerful tool is because it has the query editor where you can navigate, define, and perform data transformation operations over a data source. You get the option of transforming your data on the query editor whenever you connect to a data source. You can create a new query or load an existing query. It's completely your choice. It's basically this dedicated window which facilitates and displays your data connections and your transformations that you're going to apply to that data set, the data set with which you started, all the way to the data set which you have reached here in the applied steps section. So let's go ahead. So the only change that I want to make is in product master. Here I'm going to change the data type of this particular column to fixed decimal number. Basically, I'm asking Power BI to consider this column of values as prices. Yes. And here in the applied steps, as you can see, it automatically added a step called changed type. And I think everything else is just fine according to me. So I'm just going to close and apply. This is going to take a while. Kindly be patient. It's going to take some time and it's finally done. And here on the right, you can see all of your fields and their sub fields when you click on the drop down icon. So starting out, people who are new to this is your canvas or your report view. Here is where you're going to be creating your reports in Power BI. The next is your data view. Now this is the view where you can look at your data. All right. You can also make edits to your data using any of these ribbons available to you and the options in them. You can click on separate tables and view them individually. And finally, you have your relationship view. Here you can see various tables are connected to each other. How are they related to each other? As we all have seen before, we have three tables, two of which are dimension tables, which are your employee master and your product master, and one of them is a fact table. which is your sales data table. Now, in our case, Power BI has already established a connection because it's smart enough to do that. It just identified common columns between our tables and made relationships through them. But just in case Power BI could not do that in certain cases, we do not have common names in two tables. I'm just going to show you. I'm going to delete this relationship. Yeah, you can easily do so yourself by long pressing on the column name in one table and dropping it down to the column where you want to fuse it to the other table. And voila, you have a connection there. You have a relationship established. Now, what you need to understand is that once you've connected two tables together, in our case, three tables, with a relationship, you can work with the data in both tables as if they were a single table, which frees you from having to worry about relationship details or flattening different tables into a single table before importing them. In many situations, as in ours, Power BI automatically creates these relationships. And as I spoke about it before, I cannot emphasize enough that while Power BI is actually smart enough to do this for us, if Power BI cannot determine with a high degree of certainty that a relationship between two tables should exist, it does not automatically create this relationship. In that case, as I just showed you a few moments ago, you can create the relationship yourself by dragging your column from one table to another. Now, this has a couple of advantages. Now, because our entire data set is being treated as one table, you can add a column to one table, picking out data from another. Now we've come back to our table view, and what I intend to do here is to create a calculated column in your sales data table. Now the calculated column is going to be for revenue, and it's going to have two different components. One is the units sold, which is available in this very table, and the other one is the price per unit, which is available in the product masters table. So what we're going to do is we are going to come back to our sales data table, and we're going to use DAX to create this new calculated column. So I'm going to click on this new column, and we're going to name this revenue. And we're going to multiply units sold, and we're going to be using a function here called related, because our other column is not in the same table. It's in a different table, which is a related table. So we're going to be using related and price per unit. And we're going to close the bracket. And with that, we have our new revenue column, and it already comes with its data type changed into a currency based data type. Yes. Now what I'm going to also do is I'm going to change the format of the date into something more usable. So I'm going to use this one just because it's shorter, and that's just how I like it. It's a matter of personal preference, but you could just roll with the format that we had earlier. That's not an issue. So with that, now we are ready to layer some visualizations on top of it. So we are back in our report view. Here is our canvas. So the first thing that I want to do is I want to add a title bar to this entire page, just for the aesthetic purposes. So I'm going to go on to the insert option, and this opens up the entire insert ribbon. The first thing I'm going to put in is a shape. So I'm going to keep this bar black. So I'm going to go into this format shape section, and we're going to change the filled color to black with no transparency, and we are going to change the line color to black as well. Then we're going to go ahead and add a text box. Here I'm going to name it mock sales dashboard because we are using mock sales data. I'm going to increase the font size to a 24 and then bolden it and change its alignment to center alignment. And then what I'm going to do is I'm going to change the text color to yellow. So I'm going to maintain this color scheme throughout. I'm going to maintain the PowerBI standard color scheme, which is yellow and black. And that's what I'm going to follow throughout the course of this video. So I'm going to go on background and I'm going to turn it off. Okay, so this looks better. So let's go back to our presentation and see what all is there on our actionable items list. So we've already cleaned and transformed our raw data, and now it's a usable data model that we can build analytics on top of. Next, we have already established the relationship between tables. Now start the actual actionable items, which is to create filters to drill down upon data. So here we have 3 filters that we have to create. One is by date, one is by product, one is by employee. But I'm going to do one better. I'm also going to be creating a drill down, say, for supervisors. Then we'll build further from that. For the whole selective drill down purpose, I am going to use a slicer. And the first one I'm going to do is for date. So I'm going to just drag the date column from the sales data onto our field here. Okay, let's just resize it. And all right, I'm going to make it slightly smaller. And as you can see, it is a slicer with our start date and end date. And as we slice, we will only be viewing data in between the date range that we have selected. Now this looks kind of really bland here, and it's not really going with the color scheme that we have selected. So what I'm going to do is I'm going to do some conditional formatting on this box and try to make it as eye-catching as I can while adhering to my original aesthetic. So next to this field section, you have this paint roller-like option, which is the formatting section. Here I'm going to go down to the background and I am going to make it yellow. I'm also going to go up to border and like turn it on. I'm going to add a little bit of radius to this just to make the box slightly curve out in the edges. Then I'm going to go to date inputs and keep the font color and background as is. Maybe change the background color to yellow and increase the text size. All right, I'll keep the font family as is. Let's go to general and see if we can do something. I am going to change the outline color. Now change the slider color as well to black. Then keep. So with that, I think I'm done. I have created my first slicer. And by clicking on the date, it also opens up the calendar for that month. So you're sure of what date you're picking. Okay, I'm going to bring it up a little bit. So with that, I think our date slicer is ready. Now I'm going to copy this a couple times so I can create other slicers without having to do so much work. So this is our next slicer. I'm going to remove the date from this field and I'm going to add the product ID into this field. And this is definitely not what I had in mind. So here's this little button, this downward arrow inside the visualization, which has 2 options, which is list and drop down. So I'm going to select drop down And then I'm going to go to this ellipses sign, which is these three dots, and I'm going to add a search bar. So now you can search for your product ID. Similarly, I'm going to copy this. Let's rearrange them so that we can fit another two slicers in there. So in the next slicer, I am going to cut out product ID and add product names. We already have a search option, a search field inside these slicers. Now I don't think I can fit in two more slicers in there, so I'm just going to resize these a little bit. And as you can see, I have some visual guidelines from Power BI, which are helping me do the job and keep my visualizations aligned. I hope they are the same size. If not, honestly, let's move on. So two more. So here I'm going to remove the product name and add the employee name. And our final slicer is going to be a supervisor slicer. I'm just going to move all of these slicers a little bit so I can fit this slicer in here. And by the grace of God, we have all survived. And I can go ahead and add this extra slicer, which was not asked of me, which I went out of my way to add. So now let's go ahead and see what else is asked of us. Now what we have to do is determine the sales by revenue and number of units sold. That's pretty simple. We already have that data in our tables. So I'm going to go ahead and I'm going to add a card. Now again, in the fields field, I'm going to drag the revenue column that we have created. And I'm going to go through some formatting to make it match our aesthetic. Go on to data label. For this, we are going to color all the text in yellow. Keep my value to 2 decimal places. Also, I'm going to go on to the category label and change the color to yellow and increase the text size by a little. So then it all stands out against the black background that I'm going to be putting right now. Now again, we're just going to go to our border, turn it on and add some radius. So it kind of has a curvature to it. So I'm pretty happy with this card. So I'm just going to copy it to make a card for the units sold as well. So I'm going to cut out revenue and I'm going to drag the units sold to its field. And now we have 2 cards. So next, what do we have to do? So moving on, what we have to do is we have to determine the revenue generated by each employee under each supervisor. So for this, I'm thinking of a visualization which will have a drill down capability. For this, I'm going to create a hierarchy starting from the supervisor and then having the employees under them. You'll get to know what I'm talking about in a while. So for this, I'm going to pick a donut chart. The reason for me picking this donut chart is that I can use this very nicely to create a chart which I can drill down into. It has plenty of space for displaying information inside and out as well. So here in Legend, I am going to put in supervisor on this field, and in values section, I'm going to put in revenue. Also under supervisor, like I said, I want to create a hierarchy. So I'm going to put in the employees under supervisor. And as soon as I do that, you can see this arrow mark has appeared. And as soon as I do that, you can see this double arrow mark appear. So I'm going to click on it and I can see all these different employees and the revenue that they have generated. I can go back up here. I can drill down, click on drill down, and I can click on this drill down icon, and all I have to do is click on a data point to find out everything about it. So what I'm going to do now is again go to the formatting pane, and I'm going to first change the data colors into something more flattering. We'll keep a yellow, a very dark gray, and a blue. Also want to add a bar or a background color to the title. So I'm going to turn that yellow and align it in the center. I'm also going to increase the text size by a little. Just going to make it 21. This seems okay. And we are going to use SQL, which is the one we've been using throughout. So yeah, that's about it. So now if I want, I could drill down, I could drill up. I can use this drill down button. So now if I select any supervisor, I could get employee-wise data under the supervisor, under said supervisor. So I'm going to drill up. Okay. And as far as I remember, now what we have to do is we have to use a visualization to give us the daily growth in revenue. So for that, I'm going to choose an area chart. Honestly, you could even use the line chart for this. I just prefer the area chart. It's a matter of personal preference. I think it covers space much better and it's way better looking, and you can do a lot more with it data-wise as well. So I'm going to bring date into the axis field here. It automatically turns into a hierarchy of year, quarter, month, and day. But I'm going to click on this drop down arrow and uncheck date hierarchy and select date. And in the values field, I'm going to drop in revenue. So automatically I have a revenue by date. And as you can see, I can control it with the first slicer that we've created. Again, I am going to go ahead and do some conditional formatting in there. Like for example, the data color is in blue, which I'm going to change to a yellow to match the theme of this report. Then the data labels are going to be turned on, so you can see the highest and lowest points of the data. I'm going to keep them in dark black and also increase the text size. I'll also be going to the title and changing the font by aligning it to center. The background will be yellow. You know what? Well, let's switch it up this time. We can keep a black background and we'll keep the font in yellow. And we'll bring up the text size to match our donut chart. Okay. Also fix the font to match with the rest. And that's it. You can go ahead and add a radius if you'd like, but I'd like to keep the border invisible. And with that, we have our revenue by date. We can look at all the highest points of our revenue. One is on 23rd of February 2019. A close second is 11th of March 2019. Well, I wonder what happened on those days, but that's just how our data is. So the next thing that we're supposed to do is to diagnose the individual revenue brought by each product. For that, I'm going to create a bar chart. You can select either stacked bar chart or the clustered bar chart. It doesn't really matter, as you'll be using only one line of values. So I'm going to put in the product name in axis, and I am going to bring in the revenue for that product. I'm going to change it up. And I'm also going to add the data labels to each of these bars, keep them in dark black. And maybe increase the text size a little bit. Let's keep it at 11. And we're going to color our data also in dark black on our y-axis. And that's about it. We're also going to go ahead and match up the title with the rest of the scene. And with that, I think we are done with this particular visualization. Now this till now, I think, is pretty basic. We can go ahead and filter out our entire data by date. As you can see, we can filter it out by product ID, drilled out by supervisor. If we wanted to see which team performed the best, and then we could also drill down. We could apply multiple drill downs and slicers at the same time. So under supervisor 1, we have employee 1 to 6. And if we want to see, suppose, how employee 4 performed under supervisor 1 between date 1st of January 2019 to maybe 31st of January 2019, you have the total revenue that he generated for the company, the overall number of units sold. You have his revenue by date. As you can see, he made his best sales in the 19th of January 2019, and the number of products that he sold and the revenue generated by each of these products. Let's just reset everything. Now the bottom of the space looks a little empty. So what I'm going to do is I'm going to add a scroller there. So for that, what we have to do is we have to go to the marketplace, which you can access by clicking on this ellipsis sign in your visualizations pane. So I'm going to go to App Source. And this is going to lead me to the Visuals Marketplace. Here, I'm going to go ahead and search for Scrollers Your Visualization. I'm going to add it here, and it's going to appear right here at the bottom of your visualizations pane. I'm just going to add that. And let's just bring it to the bottom and resize it. I'm going to bring it here. And in category, we are going to put up, let's say, product ID. And in measures, we are going to put price per unit. And the scroller has begun, but it's not very visible. So we're going to go to Format, turn off the title. So we have the entire space for the scroller. Background is on. We are going to change the text color of the font to yellow. and we're going to change the scroll speed to 1 so that it's slow enough for people to be able to read it. The font size remains the same, and that's about it. With that, we have all the visualizations that we need in this particular canvas or this particular report. Now what I want to do is I want to insert an image into this mock sales dashboard title bar. And what I'm going to do with it is I'm going to make a button out of it. I'm going to place a bookmark in it so that we can connect this page to the page that follows. Make sense? So I'm going to go on insert, go to image. Maybe I'll find something in my downloads. So let's resize it. And then we can add it right here at the corner. Looks decent in my opinion. Let's rename the page. Okay, with that we've renamed the page. One final thing I'd like to do is I realize that this is going to bother me till the end of time. So I'm going to go ahead and change the title name so it fits in one line and bring up the size to just going to align it. Okay. So far what you've done is you've imported a data set from Excel to Power BI. You have cleaned and transformed the data to create a data model on which you can layer your analytics on top of. You've created this wonderful report with visualization, slicers, drill down capabilities by date, product, and employee. So you've basically created a complete sales dashboard. What we're going to do next is to create a drill down page. For that, instead of creating a new page, I'm just going to duplicate this page so I do not have to redo the header and the slicers on this page. So I'm going to delete all of these visualizations one by one. And also this image. Here I'm going to put in another button. Here in the insert ribbon, we have the buttons option. And here is the back button option. Let's just bring it here. Let's make it big and clear. Okay. I'm going to make the fill color black and reduce the transparency to 0. And the icon I'm going to turn into yellow. Okay. And I'm going to turn on the button text and name it back. I'm going to change the font color as well. And that's about it. All right, now we have a back button, which definitely works. If I'm going to click on the back button while pressing on to control, it's going to take me to my mock sales dashboard, which is my first dashboard. So let's go to our second dashboard, and firstly, let's rename this. We can't just keep calling it duplicate of sales dashboard. Oh, well, let's just call it drill down dashboard. Okay, so what I'm going to do is I'm going to put in a table here, and into that I'm going to enter the date
And as it had happened before, it gives us the entire hierarchy, which we do not want. So we are going to select date. Next, we're going to put in employee ID, employee name, maybe. I don't want that. We're going to put in supervisor. We're going to put in, let's say, product ID, units sold, and the revenue. Now let's open up our table so as to fill in the entire space. And in the bottom, we also have our total calculated. We're also going to resize the columns so as to fit the entire table. Maybe there's space for another column. So what I'm going to do is I'm going to also put in employee name. So let's reduce the size a little bit so we can have employee name. I'm going to go up to format, go on style. And there are a couple of different styles given here. Right now we're using the default style. Let's try a couple of different styles and see what we like. Okay, this looks good to me, honestly. And let's go to column headers. We're going to change the font color to yellow. Background color is black. Let's increase the text size by a little. Okay, 14 is too much. Let's go with 12. And alignment should be center aligned. I have this compulsive need for things to be aligned properly. Maybe that's just how I've been trained to think. I'm also going to go on values. Okay, seems like they're all right aligned. Then I'm going to go to conditional formatting, and for my revenue column, I'm going to turn on data bars. All right. I'm going to go to advanced controls and change the color to a light yellow. And here I see all the bars and the values on the right. So what I'm going to do is I'm going to select this row. And if you click on this row, it basically gets arranged in a descending order, which is very desirable. And through this, you can maybe select a particular date, or say 1st of January, and pick a certain supervisor, say supervisor 4. And then look at each of these employees and what they have sold and how much revenue have they generated in total. It's great, isn't it? We know that supervisor 4 on date 1st of January has sold 3 different products, product number 1, 21, and 23, and he has sold around 600 units combined and generated a revenue of nearly 32,000. And we only know that through the power of data analytics. Let's just relieve this of all the filters that I've added. So now let's go back and see what else is left to do. Okay, so we've already created a table view of all relevant data for viewing and drill down purposes. Now we have to connect our pages for better user experience and then publish our dashboard to the service. Now, it might seem a little complicated, but I promise you it's extremely easy. To create a bookmark, we have to go to the View ribbon and then go to the Bookmarks option. you'll have a pane opening like so, and it says that I have no bookmarks. So I'm going to click on add, and I'm going to rename this bookmark to, let's call it DDD, because we have a drill down dashboard. Also, I'm going to go on the ellipses and uncheck data. I'll tell you why I did this, because we want our bookmark to lead us not to this particular page that we have right now. We want the bookmark to lead us to a page which has already been filtered by the filters applied on the previous page. All right, hope I'm making sense. Now we have our bookmark. We're going to go back to our first page. We're going to select this option. And we're going to open the format image, where I'm going to go down to action and turn it on. We're going to select action type, which is obviously a bookmark, and select our bookmark. And in the tooltip, which is going to just display a text, if we hover on this icon, we are going to say click to view drill down. Okay, that seems like it. So now if we hover over this, it says click to view drill down. And if we click on it, it leads us to this page. And just to clear what I was speaking of previously, if I drill this page down for a single product, when I view my drill down, it is supposed to show me. So now that we have everything that we need, let's go ahead and publish this dashboard to the service. So I'm going to go to the home ribbon and click on this publish button right here. And it'll ask me to save my changes. I'll be prompted to save my changes. So I'm going to click on save. And I'm going to save it as sales dashboard 101. And I've saved it. And now it's going to take some time to publish it to my workspace on Power BI. It's going to take a few seconds. And it says a success. That's great. We can open this dashboard directly in Power BI. See, it's exactly the same as it was previously. I can click on this and it'll take me to the next page. And I can click back on this. It'll take me to the previous page. And the cross highlighting works just how it used to work on Power BI desktop. See? The filters work exactly the same. We can apply filtering just the way we want, just the way we did in our Power BI desktop. And we can pin the visuals that we want to our dashboard. So we're going to create a new dashboard and call it Sales Dashboard 101 and pin it. Then we're going to, let's say, pin another visual. Let's pin this. And another one. And maybe we can pin this card as well. and you're prompted to go to your dashboard. And here I can go to my dashboard and it has all the visualizations that I've pinned. The card is right here. And click on the card. It'll take me back to my page. Here you can ask any question to your data using natural language. So maybe I can ask about average price per unit, maybe. And you get the average price per unit. You can ask for top 10 products by price. Here you have product ID, name, and price per unit. So you can basically ask any question to your data and Power BI will answer you. And you can also pin different visuals from different reports onto one single dashboard. And you can share your dashboard by clicking here and putting in the email IDs of the recipients that you want to share your data with. With that, let's go back to our main report. If I click on a certain visualization, it's going to take me back to my main report. So here we have our main report. So in this section, we learned how to import data from an Excel sheet. We also developed, designed, and published our report on the Power BI service. We learned how to create slicers, use cards, drill down and drill up using separate visualizations while also maintaining an aesthetic. We also imported a scroller from the marketplace and created a drill down dashboard which we connected via a bookmark button.
Let's move on to the hands-on section where we will create our own Power BI project. We will be using HR datasets for this purpose. So let's look at some of the steps that we will do. First, we will load the dataset. Then we will transform the data if required and also define relationships among datasets in case the auto-detect functionality fails in the Power BI. Next, we will create our visualizations and add colors or titles and make other changes to make the dashboard look elegant. And finally, we will publish our report so that other stakeholders in the organization can view it. So let's look at some Power BI reports first to see what a good report looks like. Here, I have my market data analytics, which shows some insights about whatever information that we had. Here, it just shows the number of customers and income by states data. It also shows income by vehicle class and income by marital class in addition to some other analytics. We also have the IT spend analytics data. Here, you can see some interesting visuals which shows some interesting graphs about the actual plan by the IT area combined with showing the region in Europe where the variance plan percentage was calculated on a country or region basis. So essentially, the key part about creating a good Power BI report is that they should look appealing to the eyes, which you can see here. So we will do just that from the scratch. Here I have an empty project which I have named demo prop. First, for any visualization, we need data. For this project, I have the HR analytics data from the company. I have extracted this data from my database and I'll be using this data in my reports. So I'll load this data as I create my visualization. So first, let's say that I want to answer some questions like I want to show how many bad employees were hired in the entire duration by gender. For this, I'll need only two data points. First, the gender, and second, the number of bad hires that we have. For this, I'll load two datasets. First is the gender dataset and second is the employee dataset. So let's load it. And now I'll go ahead and load the employees data. Do note that most of the data has already been cleaned. So, in most cases, I won't need to transform the data. So let's load it. So now that the data set has been loaded, what I'll do is I'll drag some values from employee and some values from gender. But first, let's take a look at what we have. So in employee, we have the bad hires value, and we can check that in the field. So let's check the employee. So here, if any hire was a bad hire, it will be marked as 1. Otherwise, it will be 0. So by that, we will just create a visualization using this value and this one, because we want to know the number of bad hires that we have. Here, I'll just drag the bad hires and then I'll drag the gender value. Here, I'll try to create a donut chart. So I'll select donut chart visualization. Now, as you can see, what we see here is that the number of male and female are completely the same. That is, we get 9838 for females and 9838 for males. So this means that there's probably some inconsistency in the data. So to check that, we need to take a look at how the data of the gender looks like. So let's check that. So as you can see here, we have directly used the gender, which is male and female, but they are being represented by the ID column. So if we look at the employee, we can see here that the gender has been determined using the ID and not their gender value. So what we need to do is we need to make a relationship between the ID from gender and the employee. So to do that, what we are going to do is we are going to take a look at the model view and then we are going to connect the ID. So let's click on Manage Relationships. Here, I need to create a new relationship. So I'll select employee here and then the gender, and from gender, I'll be using this column. So let's hit OK and close this. And by doing this, we should have the proper visualization that we are looking for. So if we take a look at this, the relationship has been defined. That is, it connects the gender ID in the employee gender field. So here, what you can see is that the visualization has now changed and it shows that the number of bad hairs in male was about 51.39% and in females it was about 48.61. Now we can try to change the color of this and maybe change this heading. So to do that, I'll go here and I'll make some changes. Now it looks much better. The heading is clear and it clearly indicates that it is going to stay on top of this. Now we can also try to add a background to this. And to do that, what I'll do is I'll turn on the background, and by doing that, we can see the white portion here. So this stands out differently. Sorry, this was my mistake. I'll go ahead and change the visualization again. And I'll format my visuals again. And I'll represent male by, let's say, alright, this color looks good. And I'll represent females by, let's say, yellow. Now it looks much better. You can always make changes according to your requirements, but select those colors which make the visuals look proper and much more appealing. So now that we have answered how many bad hires were there in the company based on the gender, we will go ahead and create another visualization. For this, I'll create a new hire statistics. This will show how many new hires have been made based on the gender and age groups such as less than 30 or let's say like over 30. For this, I'll need another dataset called group, which I'll load right now. So if you take a look at this data, you can see that there are three age groups, that is less than 30, from 30 to 49 years of age, and then the 50 plus. So let's load this. Now, to create this visualization, which will show new hires that have been made, I'll drag the age group first. So I'll select age group and I'll drag it here. Now that it has been done, what I need to do is I need a complete number of the new hires that were made. So in this data, we don't have any such values, but we do have is new hire value, which has a true or false value. So let's check it again. So here we have this new hire. So if we see some employees with the value of 1, then it means that they were newly hired. So what we need to do is that we need to create a new measure which will be new hires using the DAX. So we can do that by right clicking here and selecting new measures. So we get the formula bar right here. So I'll just clear this and I'll type in my variable name, which will be new hires. And I'll provide it a value by doing a sum of this. So sum of all is new hire will be the new hires value. Now that we have created this, we can drag this value into a visualization. So to do that, what I'll do is first of all, I'll select this and select, let's say, I'll use the stack column chart because we will need to show the gender as well. So I'll select the stack column chart and then I'll drag this value of new hires into the y-axis so that the x-axis represents the age group and the y-axis will represent the number of new hires that were made. And after that, all that remains is to drag the gender into the legend field. So by doing this, as you can see, we were able to create another visualization which shows the number of new hires that were made. And this is based on two metrics, which is the age group, which is shown on the x-axis, and the gender, which is shown above. And this is represented by different colors. Again, you can go ahead and change the colors as you require, or change the headings as you see fit. So again, I'll use blue for the male, and for females, I'll use the yellow color. So now that we are done, I'll just make one another change, which is I'll add in the title and make it look much more bold. So again, format your visuals and go to general and then select the title. I'll again add a background so that it stands out like this. So with these two visualizations, we see the number of bad hires that were made in this company and the new hires that are made based on the age group and their gender. So we can see here that most of the employees that are newly hired are below the age of 30. So I'll just go ahead and change one another thing which I don't like about this visualization is that I'll remove these grid lines. So to do that, again, I'll go to format my visuals. And while we are on this, let me also change the color of the title. And with that, I have answered two questions about the company. That is, the bad hires that were made in the company and the new hires that were made. Now, for this next thing, I'm going to create a line chart which will show new hires made by the year and month, including the employment type. So for that, I will need another data set for this, which shows what is the employment type. So I'm going to need another data set that defines the type of employment that a person has. And I'll just load that data, which is named FP. Now, if you take a look at this, it shows that F means full-time job and P means part-time job. Before loading this data, we can see that there's a problem here. That is, the first row is not being used as the column header. But we can see that what it actually will mean, because F determines that the person is full-time employee and P means that the person will be the part-time employee. So let's transform this data first. So I have just one requirement, that is I want to use the first row as the header. And to do that, I'll just click here. And by doing this, you can see how the data is changed. Now, you can go ahead and close and apply this. And now that it is done, we have FP here. But we need another data set called the date, which will contain everything related to the date and when the employee was hired. So I'll load this data right now. So I'll just go ahead and load this data right now, and I'll create a line chart. So as we have loaded this date dataset, we can see that we are not seeing the visuals that previously created. So let's verify what is the problem. So it says here couldn't load the data for this visual, and the filter on date is not valid. Check that the data type of the date field matches the filter you're trying to apply. So first of all, I'll go ahead and check what is the model showing. So here you can see that the date is not connected with the employee. So what I need to do is first connect these two. And to do that, I'll again go to manage relationships and define a relationship. So I'll select employee date, and then I'll select date and again date. So I'll click OK and close this. So now we can see that the employee date is connected with the date of the date. Now let's go ahead and check if the visuals are visible. So again, we see that we can't see the visuals. So let's try to identify what the key problem is. So it says here the date field is not of the correct data type. So okay, let's go ahead and check this. We'll go to date, and here I think this is the problem that we are having, which is the data type is of the text format. So we can change this to date/time. And with this, we should have the visualizations back. So let's check again. Okay, as expected, we can see the visuals again. So let's go ahead and create the line chart that we're looking for, which will show the number of new hires that were made by year and month, including the employment type. So to do that, what I'll do is I'll drag the year column from date. And I'll go ahead and select the line chart. Now I need some values for the x-axis and y-axis. So as I said before, here I am using x-axis to show the years. So I'll drag this to the x-axis. And for the y-axis, I need the number of new hires that were made. So remember the DAX variable that we created? We are going to use that here in the x-axis. So this variable, I'll drag this on the y-axis. And as we can see, the hires that were made in 2011 were lower than 2012, which was lower than 2013, which was lower than 2014. So the number of new hires are increasing on year-on-year basis. So now I also need to include the employment type. So to do that, I'll drag the employment type, which is defined by FP, and drag it into the legend field. And by doing this, you can see, sorry, my mistake. I didn't need to drag this value here. It was actually FPDESC. As I remember, let me just confirm this. Okay, So we need to drag the FPDESC value because it shows what the type of employment is, and the FP is just an ID. So I'll drag this into the legend. So if we take a look at this, you can see that the number of part-time employees in 2012 was around 6,000 and the number of full-time employees in 2012 was around 1,000, and this trend continues. So I also want to see what happened each month in a single year. And to do that, what I can do is I can drag the month into the x-axis. So this activates the drill down. Essentially, when you will try to find out what happens in a specific year, you should be able to take a look at what happens in that year. So let's drill down. So essentially, what we need to do is just click on the year number, and we can see here that there is a downward trend. But this is incorrect because, as you can see, the month that we are seeing here is October. And then this sequence doesn't make any sense because the month starts from January, February, March, and so on till December. So we need to change this. And to do that, what we can do is we can sort this using the months. So to do that, I'll go ahead and make some changes to this visualization. So first, I'll go to my data view. I'll select month and I'll sort this data using the month number. Okay, let's see what changes have been made. So again, it seems like nothing happened. So let's see what we can change. So here I click on sort axis and I'll select year month. And now I need to make this in the ascending order because right now December is on the left side and January is on the right side. And just like that, we have a perfect visualization showing the number of new hires made in 2013. Now I'll go ahead and make some more changes such as changing the colors and the header. And I'll disable the grid line as well. I'll also add the white background which the other visualizations have. Then I'll change the color of these lines. Okay, so this does not look much appealing to me, so I'll change one color. So, to me, this looks much more appealing to the eye, and I'll use this color scheme. Now, for the last part, I'll create a matrix which will show the region and the ethnicity of the new employees that were hired. So, we need the new hires value again. But we also need two new data sets for this, which are ethnicity and the region data. Here we have the BU dataset which contains the information about the region. So as you can see, we have some values available here which shows the region part and the vice president's names right here. So I'll go ahead and load this. Now that BU has been loaded, I will load another dataset called ethnicity. So we can see here that this dataset has 3 columns, of which the last column is empty. So I can just go ahead and remove this data. So I'll go ahead and remove this empty column. And to do that, I just have to select this and click on remove columns. And just like that, this is ready to be loaded. So close and apply and wait for the data to be loaded. Now that the data is loaded, what I can do is I can go ahead and create a new matrix. But before I do that, I need to make sure that the relationships are properly defined. So let's look at the BU dataset. So it has these values, which are self-explanatory, and the ethnicity. So it looks like I need to connect the ethnic group for the employee, and then I need to connect the BU for the employee as well. So I'll go ahead and go to my model view, and let's see what has happened. So for BU, it looks like the relationship was automatically made. And for the ethnicity, it looks like the relationship here was also automatically made. So it goes to show the powerful features of the Power BI, that it is able to make sense of what the relationships might be. So let's go ahead and create that matrix that we are looking for. So first thing is first, I'll take the region value and I'll drag it here. Now I'll select matrix, and now for here I will go ahead and include into rows the vice president's names as well. Now I'll drag the ethnicity column, and for the values I'll provide the new hires, because essentially this visualization is all about the new hires that are made, and this shows the analytics of the HR. So as you can see, we can say in this chart that from specific regions, what kind of ethnicity group were hired and how much do they total. So the first thing that I'm going to change about this visual is first of all the font size, because as of now it looks like it is too small. So I'll again go to format my visuals and I'll change some settings here. So for the column header, I'll change the text size and I'll make it bold. I'll do the same for the row headers as well. And I'll make the same changes for the values. So now I'll just resize all of this, and now I can show you what Power BI is all about. So in this project, what we have answered is the number of bad hires that have been made and the number of new hires that have been made by the company. And I have created this matrix here, which can also go ahead and show that what happens in specific regions. So if we go ahead and click on the central region, we can see that the ethnicity is this, and the visualization changed based on this specific value. So now that the project is ready, I can go ahead and publish it. And I'll select my workspace for this. And now that we have successfully published our report to the Power BI, we can go ahead and see it. So as you can see here, we can see the visualizations that we made. So for this, you can see that if I drill down on 2012, I'll see a trend of something like this, which represents the new hires that were made. And essentially, this will go to show the hiring analytics that have been made by the company. And just like that, the project is done. Do experiment and note that you will be able to create this great reports in no time, because most of the learning comes from experimentation. This video did not include having multiple pages. For example, instead of having just one page here, I could have had two or maybe let's say 5 pages, which could have shown the analytics of the HR operations.
Power BI can create interactive dashboards from millions of data sets. Many top companies use Power BI to create dashboards like this, so that business stakeholders can clearly understand it and spend more time on other tasks. So now I will show you a small demo of creating visual using Power BI. Now, as we have opened the Power BI desktop, now we will create a small visual. To create a visual, let's go to Get Data. We have many options under the common data sources. So I will select text and CSV as my file format is in text and CSV. And we will source our first data. Click on open. Click on load to load the data. Now to check whether a file is loaded or no, towards the right hand side under data, we have the file that we have loaded. Now let's create the visual. For that, select the clustered column chart for creating the graph. So now let's give the values for the graph. So I will be giving location as my x-axis value by dragging and dropping it. Same as for the y-axis, let me give the sum of revenue as the value. Now here you can see my graph is created. Let me change the background color of the report. So let me go to format your report page. Under that you can see canvas background. In canvas background we have color. So you can choose any preferable color you want to. So I will be choosing a dark color and decreasing the transparency to 13%. Okay. So as my background color of the report is also changed, so let me change the background color of the graph. For that, let me go to General, Effects. In Effects, you have color. You can choose any preferable color you want to. And you can decrease or increase the transparency too. I have increased the transparency to 81%. So now you can see the background color of my graph is also changed. Now let me change the color of the text of my values. So for that, let's go to Visuals. In the x-axis, we have colors. Let me change into white. Yeah, you can see that's done. Same as in the y-axis. Let's go to Values, Color, and let's click on white. Here you can see that my color of my text is also changed to white. Now let's also change the color of the columns. For that, under Visual, we have Column. In Column, we have Color. You can change it to any preferable color you want to. So here you can see that I have also changed the color of the column. Let me show you all how to change the title as well. For that, go to General, Title. So under Text, let's type revenue generated by location and change the color into white and give it bold as well so that it's visible and align it to center. So this is how you create the graph. Now, as you can see, my graph also consists of the grid lines. So let me just remove the grid lines as well. For that, let me go to Grid Lines under Visual and just off the grid lines. So here you can see that my grid lines has just been removed. So this is how you create the visuals or the dashboard in the Power BI desktop. To learn more about creating dashboard using Power BI, please check out Edureka's Power BI tutorial where you can learn how to create dashboards from the scratch. I hope you now understand how Power BI works when creating dashboards and so on. Suppose you are a beginner or professional looking to improve your Power BI skills. In that case, Microsoft offers Microsoft Certified Power BI Data Analyst Associate, which will demonstrate methods and best practices that align with business and technical requirements for modeling, visualizing, and analyzing data using Microsoft Power BI. So, if you want to obtain the certification, you must take up the PL300 exam, which costs $165, and in Indian rupees, it is 4,800. And the pattern consists of 40 to 60 multiple choice questions. The duration is 100 minutes, and the passing criteria is 700. Now let's see how to prepare for Microsoft Power BI certification. First, you should understand the exam requirements. Familiarize yourself with the exam objectives for PL300, covering data preparation, modeling, visualizing, and deployment. Review Microsoft's official guide for detailed topic areas. Next comes hands-on practice. Use Power BI Desktop extensively. Practice data modeling, DAX, creating dashboards, and using Power Query. Aim to build end-to-end solution to deepen your skills. Last comes the study resources. Take advantage of Microsoft's free learning paths, online courses, and practical exams. Have you all imagined what are the skills you will acquire? First is prepare the data. You will learn how to connect to data sources, profile and clean data for consistency, and transform and load it for effective analysis and reporting. Next comes model the data. Design and implement a structured data model, create calculations using DAX, and optimize model performance for efficient analysis in Power BI. Next comes visualize and analyze the data. Create insightful reports, enhance them for usability and storytelling, and identify patterns and trends to drive data-driven decisions. Moving on to manage and secure Power BI. Create and manage workspaces and assets while securing and governing Power BI items to ensure controlled access and compliance. So these are the skills that is needed to be certified for Power BI Data Analyst Associate. Now let's see who should take up this Microsoft Power BI certification. The certification is ideal for data analysts and professionals who leverage Power BI to communicate insights from an organization's data. It also benefits business managers and decision makers who want to make data-driven decisions, as well as IT professionals transitioning into BI roles or seeking career growth in data analysis and visualization. Obtaining a Power BI certification, such as passing Microsoft's PL300 exam, not only demonstrates expertise in a leading visualization tool, but also opens up new career opportunities. Similarly, Edureka offers the Microsoft Power BI certification training by PwC Academy, which will help learners pass the PL300 exam while also gaining expertise in business analytics. And Edureka's Power BI certification course by PwC offers dual certification in business intelligence. You will learn concepts such as Power BI desktop, architecture, DAX, mobile apps, data quality assessment, data transformation, data modeling, reports, and among others, using industry examples. This Power BI training is live and instructor-led, ensuring you gain hands-on experience with real-world projects and help the learners to pass the PL300 examination. So I have added a screenshot here, and the screenshot is from Edureka. So all these are skills from Microsoft Power BI that will be covering in the certification. So the skills are data transformation, building reports and special visualizations, charts and page layout, building narratives with Fabric, advanced analytics with Power BI, working with Copilot feature. We also have Microsoft Power BI tools covered, for example, Azure SQL, Power BI, Copilot, Python, Amazon S3, and so on. Now let's also take a look at the job descriptions. Here I've added the screenshots of the top companies hiring for data analysts and Power BI professionals. So Edureka will be a better choice if you want to start your career in Power BI. Now let's see the scope of Power BI. In 2024, Microsoft Power BI held 15.97% of business intelligence market, trailing only Tableau, SAP Crystal Solution, and NetSuite. According to Statista, the BI market will be $27.36 billion in 2024, raising at a CAGR of 5.71% to $34.16 billion by 2028. According to the comparative survey, the United States will generate the most revenue in 2024, amounting to approximately $13,790 million. All businesses are becoming increasingly data-driven, relying heavily on data analytics and visualization tools to provide real-time and actionable insights. Now let's take a look at the salary for a Power BI professional. The average annual salary in India is, for the entry level, it is 6 lakhs per year. And for the mid-level, it is 19 lakhs per year. Moving on to the senior level, it is 26 lakhs per year. Now let's see the average annual salary in US. For the entry level, it is $95,000 per year. And for the mid-level, it is $98,000 per year. Now let's see for the senior level, it is $100,000 per year. Now let's also take a look at the salary for data analyst. The average annual salary in India for the entry level is 11 lakhs per year. And for the mid-level, it is 18 lakh per year. Moving on to the senior level, it is 19 lakh per year. And the average annual salary in US is, for the entry level, it is $65,000 per year. And for the mid-level, it is $76,000 per year. Moving on to the senior level, it is $79,000 per year. Here I have listed the top companies that are hiring Power BI professionals, and those companies are Microsoft, Amazon, Infosys, TCS, Google, Accenture. A Power BI certification is a significant milestone in your data analytics career, setting you apart in a competitive job market. It's more than just passing an exam. It's a professional development process that includes fully understanding one of the most commonly used data visualization tools. In business, data is extremely important. If you are marketing or running a business with a large amount of data, you must understand what people want, what they require, and so on. Only by understanding this data, you will know the market, the business, and customer requirements. However, if the data is in the paper format and contains 1000 rows, it is difficult to understand and work with, consuming a significant amount of time. But what if we present the data in a pie chart or graph chart using visualization and show it in a more appealing way to the stakeholders or to the organization? And this is possible with the tool Power BI. Power BI, initially designed by Ron George in 2010 as Project Crescent, debuted in July 2011 by SQL Server codenamed Denali. Renamed Power BI, it was unveiled for Office 365 in September 2013, evolving from Excel add-ins like Power Query, Power Pivot, and Power View. Microsoft expanded Power BI with features like natural language Q&A, enterprise-level data connectivity, and security through Power BI gateways. It offers cloud-based services, that is Power BI Service, and a desktop tool, that is Power BI Desktop, supporting data preparation, mining, and interactive dashboards. A key milestone was the 2016 launch of Power BI embedded on Azure, enhancing integration and custom visualizations, one of its standout features. Why is Power BI regarded as an emerging leader in business analytics? Power BI is viewed as an emerging leader in business analytics due to its comprehensive, user-friendly, and scalable capabilities. First, we will see how analysts use Power BI. Analysts use Power BI to create interactive data visualization from various data sources and share critical business insights throughout the organization. Now let's see Power BI for IT. Power BI is a tool that simplifies management, ensuring compliance and secures data while providing users with the insights they need. Because most employees in the organization already use Microsoft products, using Power BI reduces training and support costs by incorporating these familiar tools into your enterprise BI deployment. Lower implementation costs, it can be deployed and managed in the same way that Office 365 and other Microsoft solutions are used in your organization. It helps you keep track of your enterprise data. It centralizes control over data access and use, including on mobile devices, establish and monitor policies, detect anomalies, and act. Next, we will see Power BI for developers. They integrate Power BI into applications, websites, and portals. To contextualize your business data, embed stunning, interactive data visuals in applications, websites, portals, SharePoint, Microsoft Teams, and more. Using Power BI REST APIs and the Power BI SDK, developers can easily embed interactive reports and dashboards, ensuring that your users have consistent, high-fidelity experiences across devices. Now let's move to how does Power BI work. Power BI does not need any complex coding. It operates in following 3 steps. The first step is create, that is to connect your data wherever it lives. Then explore your data with stunning interactive visualizations. Moving to the next step, that is collaborate and share. Publish reports and dashboards, collaborate with your team, and share insights inside and outside of your organization. The last step is access insights from anywhere. Take action with seamless access to insights from your desk or while on to go with Power BI apps built by Microsoft, your partners, and your organization. Next, let's see what are multiple source connectors used in Power BI. Power BI provides a wide range of connectors for integrating data from various sources, allowing users to create comprehensive analytics. These connectors are compatible with a wide range of systems, providing flexibility for a variety of business requirements. Here is an overview of it. First, we have is SQL Server, then Excel, next is Azure SQL Database, SharePoint, Salesforce, last is a web data. These connectors allow users to consolidate data from various environments, whether on-premises, cloud-based, or hybrid, streamlining the data preparation and reporting processes in Power BI. Next, let's see what are the top 6 jobs for Power BI professionals. First, we have the Power BI analyst. A Power BI analyst is a professional who analyzes data and provides actionable insights using Power BI's interactive dashboards and reports. They play an important role in converting raw data into meaningful business intelligence to aid decision-making processes. The skills needed for Power BI analyst are experience in manual testing for reporting and analytics dashboards. Then, knowledge of testing methodologies, SDLC, and data validation, proficiency in designing test cases and using tools like Jira or TestRail, Agile or Scrum experience, and strong problem-solving skills. Then, excellent communication and multitasking abilities. Last skill is bachelor's degree in computer science or related field that is preferred. Here I put a screenshot of company Oracle where they're hiring for a business intelligence analyst. Here is the skills part where I've already explained to you. Now let's see the responsibilities. Developing comprehensive dashboards and reports for visualizing data. Engaging in data modeling to support analytics platform. Then, partnering with stakeholders to translate business requirements into technical solutions. Last is maintaining and enhancing the performance of existing database platforms. Now let's take a look at the salary of a BI analyst. The average annual salary in India for the entry level is 12 lakh per year. And for the mid-level, it is 17 lakh per year. Lastly, for the senior level, it is 20 lakh per year. Now let's see the salary in US. For the entry level, it is $57,000 per year. And for the mid-level, it is $75,000 per year. And lastly, for the senior level, it is $99,000 per year. If you're ready to use your data skills to make a real difference, becoming a Power BI analyst could be the perfect fit. Every day, you'll be at the forefront of the data revolution, assisting businesses in uncovering valuable insights to help them make better decisions. Now let's see Data Visualization Specialist. Data Visualization Specialists in Power BI transform complex data into compelling visual stories, while other Power BI roles concentrate on data analysis and modeling. This role is all about developing interactive dashboards and reports that make data simple to understand and act on. The goal is to present data in a way that both visually appealing and meaningful, allowing it to influence important business decisions. Now let's see the key skills for Data Visualization Specialist role. First is data analysis and interpretation. Skilled in analyzing large and complex data sets to identify patterns and trends. Skilled in interpreting data and effectively communicating insights to technical and non-technical stakeholders. Next is visualization development. Expertise in designing and developing interactive and static visualizations using tools like Tableau, Power BI or similar platforms. Ability to collaborate with cross-functional teams to gather requirements and create impactful dashboards. The next skill we have is data storytelling. Expert at translating data finding into narrative that supports strategic business decisions. Experience in presenting insights to reports, presentations, and visualizations. The next skill we have is data quality and validation. Strong focus on ensuring the accuracy and integrity of visualized data through rigorous validation processes. Collaboration with data engineers and analysts to improve overall data quality. The next skill is the technical skills. Proficiency in data manipulation and analysis using SQL, Python, or R. Understanding of best practices in data visualization design and storytelling. The last is communication and problem solving. Excellent communication skills for conveying technical concepts to non-technical audiences. Strong analytical and problem-solving abilities to handle complex data sets effectively. Here I have put a screenshot of a geo company hiring data visualization specialist. And here are also the skills that is mentioned, which I've already explained in the skills part. Now let's see the responsibilities followed. First, create clear, impactful dashboards and reports. Then, present data trends and patterns to make them strategic decisions. Clean and prepare the data sets for analysis. Lastly, collaborate with teams to understand data requirements. Now let's take a look at the salary. The average annual salary in India is, for the entry level, it is 7 lakh per year. And for the mid-level, it is 11 lakhs per year. And for the senior level, it is 25 lakhs per year. Similarly, let's see the average annual salary in US. For the entry level, it is $60,000 per year. And for the mid-level, it is $89,000 per year. Lastly, for the senior level, it is $130,000 per year. Organizations rely on data visualization specialists to turn raw data into actionable insights. By making data accessible, they enable data-driven decisions at all levels, Let's see the next job role, that is Power BI Developer. Looking to turn your raw data into game-changing business insights, this is a raw mission of Power BI Developer. While other Power BI professionals concentrate on analysis, Power BI developers live and breathe the technical aspects of business intelligence solutions. They are the experts who create the data models, create the visualizations, and combine them into powerful dashboards. Now let's take a look at the key skills. First, proficiency in multiple technologies. Then, basics of architecture and design. Next, knowledge of testing tools and agile methodologies. Understanding project life cycles, activities, and estimation methods. Next we have is awareness of quality processes and business domains. Strong analytical, technical, and problem-solving skills. Next we have is knowledge of software quality assurance and solid design principles. Awareness of latest technologies and trends. Last is the effective communication and debugging skills. Here I've added a screenshot of a job description of a Power BI developer, where Deloitte company hires a Power BI developer consultant. So beside is the skills given, which I've already explained in the skills part. Now let's see the responsibilities. You will design and build elegant data models to support stellar analytics. Bring data to life with interactive dashboards and visuals that will impress stakeholders. Optimize data pipelines to keep everything running smoothly as the data grows. Lastly, collaborate with teams to plan BI projects that meet businesses' objectives. Now let's take a look at the salary for a BI developer. And the average annual salary in India for entry level is 19 lakh per year. And for the mid level, it is 21 lakh per year. And for the senior level, it is 23 lakh per year. Similarly, let's take a look at the salary in US. So, the average annual salary in US for the entry level is $97,000 per year. And for the mid-level, it is $112 per year. And for the senior level, it is $140,000 per year. Power BI developers play an important role in enabling organizations to make the most of their data. Anyone interested in technical side of data analytics will find it both challenging and rewarding. If this sounds like you, becoming a Power BI developer could be a great fit. Now let's move to the next job role, that is Power Platform Developer. Looking for a position that combines data analysis and hands-on solution development, consider becoming a Power Platform Developer. This tech professional distinguished themselves by not only delving into data, but also developing end-to-end business solutions with Microsoft's powerful suite of tools. The key skills they have is, first, Power Platform expertise, proficiency in Power Apps, Power Automate, and Power BI, experience in Power Visual Agents for chatbot development. The next skill is Microsoft technologies, strong knowledge of Dynamics 365, SharePoint, and Azure services, familiarity with Dataverse. The next skill is customization and development, ability to create custom connectors and APIs, proficiency in JavaScript, C++, and .NET for advanced customizations. The next skill is data management, experience with data modeling, integration, and migration, knowledge of SQL, Dataverse, and other database systems. Next we have is the workflow automation, building and optimizing workflows using Power Automate. The last skill we have is UI UX design, designing user-friendly applications with a focus on responsiveness and accessibility. Here is a screenshot that I have put from the HCL Tech company hiring Power Platform Developer. And the skills are also given here. Now let's see the responsibilities. Create and implement strong data models to support business analytics. Create interactive dashboards and reports that bring data to life. Optimize and troubleshoot BI tools integration and performance. Lastly, collaborate with stakeholders to translate business requirements into BI solutions. Now let's take a look at the salary. The average annual salary in India for the entry level is 8 lakh per year. And for the mid-level, it is 17 lakh per year. Lastly, for the senior level, it is 20 lakh per year. Similarly, let's see the average annual salary in US. For the entry level, it is $96,000 per year. And for the mid-level, it is $115,000 per year. And lastly, for the senior level, it is $148,000 per year. With a growing demand for data-driven insights and automated solutions, Power Platform developers are becoming a more valuable asset to modern businesses. It's an excellent career path for anyone who enjoys problem solving, learning cutting-edge tools, and making a genuine difference with the power of data. The next job role we have is a Power BI consultant. Power BI consultants are versatile experts in field of business intelligence. Unlike other roles that specialize in specific tasks, these professionals provide a comprehensive range of services to assist organizations in making best use of their data. The key skills they have is expertise in Power BI, where DAX, Power Query, Service, desktop visualizations, and mobile dashboards. The next skill is strong knowledge of Azure, data storage, and SQL. Next, we have good understanding of DWH concepts, that is ETL, dimensional modeling. Then, experience in access control and data security implementation. Then, proven ability to work independently at client locations. Lastly, excellent communication skills. Here I've put a screenshot of the Fragma Data Systems company, where they hire Power BI and data visualization consultant. And the skills are also mentioned here, which I've already explained in the skills part. Now let's move to the responsibilities. Firstly, develop and implement data analysis best practices. Then, create robust data models to meet complex BI requirements. Lastly, drive strategic initiatives to improve the organization's BI capabilities. Now let's take a look at the salary. The average annual salary in India is, for the entry level, it is 11 lakh per year, and for the mid-level, it is 40 lakh per year. Lastly, for the senior level, it is 44 lakh per year. Similarly, let's see the average annual salary in US. For the entry level, it is $100,000 per year, and for the mid-level, it is $124,000 per year. Lastly, for the senior level, it is $145,000 per year. In many ways, Power BI consultant are the keystone of an organization's BI efforts. Their broad skill set and strategic perspective help tie together data streams to surface insights that drive the business forward. Let's see the last job role, that is a financial analyst in Power BI. Financial analysts who use Power BI stand out for their ability to combine data from various sources and create insightful visualizations. These professionals can use Power BI's powerful features to create interactive dashboards, run complex what-if analysis, and generate detailed financial reports. This enables organizations to make more informed strategic decisions. The key skills needed are 1+ year of finance experience, expertise in budgeting, planning, forecasting, and reporting. Then, experience using data for business decision making. Next we have is the knowledge of financial controls and procedures. Then, CA articleship in progress. Lastly, 18 months of internship or articleship remaining. Here is a screenshot that I've taken from the Amazon company, where they hired the financial analyst intern, that is AMZI finance team. The skills are given here, which I've already explained. Now let's take a look at their responsibilities. Include analyzing large volumes of financial data to identify trends and forecast future scenarios. Creating dynamic, interactive financial reports and dashboards that offer deep insights into the businesses. Lastly, working with other teams to ensure financial data accuracy and completeness. Now let's take a look at the salary. The average annual salary in India is, for the entry level, it is 5 lakh per year, and for the mid-level, it is 7 lakh per year. And lastly, for the senior level, it is 10 lakh per year. Similarly, the average annual salary for US is, for the entry level, it is $87,000 per year. For the mid-level, it is $177,000 per year. And for the senior level, it is $186,000 per year. Financial analysts play an important role in assisting organizations in understanding their financial health and making informed, data-driven decisions. They provide invaluable advice to help businesses succeed by combining their financial expertise with Power BI skills. Have you ever thought, is Power BI the future of Excel? Power BI is not a replacement for Excel, but rather a complement, representing the future of advanced data analytics and business intelligence. While Excel is useful for calculations, data manipulation, and light reporting, Power BI excels in interactive dashboards data visualization, and managing large data set with complex relationships. However, Excel remains useful for detailed financial models and hoc analysis and spreadsheet-based workflows. Power BI and Excel frequently collaborate with Power BI importing and visualizing data from Excel, ensuring that both tools remain relevant in the business environment. I hope you have a clear understanding of all the job roles in Power BI, and is Power BI the future of Excel as well? Now, how do we determine if one of these Power BI roles is a right fit? As we have seen, each Power BI role has its own set of responsibilities and required skills. A Power BI analyst primarily analyzes data and creates visualizations, whereas a Power BI developer delves deeper into the technical aspects of designing data models and building dashboards. To determine the appropriate Power BI role, firstly, math skills. Evaluate your technical and soft skills. Next, career interests. Select based on your passion, design, or insights. Lastly is the future goals. Align your job responsibilities with your long-term goals, whether technical expertise or leadership.
Managing data across multiple tools and platforms can be challenging, and that's where Microsoft Fabric comes in. A unified data platform that seamlessly integrates analytics, engineering, and AI. So let's start by understanding why is Microsoft Fabric used. Well, Microsoft Fabric simplifies and unifies data management and analytics. It brings together tools for data engineering, data science, real-time analytics, and artificial intelligence into a single platform, allowing businesses to streamline workflows, reduce complexity, and gain faster insights from their data. But what exactly is Microsoft Fabric? Microsoft Fabric is an all-in-one analytics platform for data processing, real-time analytics, and reporting. It integrates services like data engineering and warehousing, using one lake storage and AI to turn raw data into insights effectively. But how is Microsoft Fabric different from others? Microsoft Fabric is a unified end-to-end analytics platform designed to tackle the challenges of modern data management. Unlike isolated tools or simple rebranding, Fabric is redesigned from the ground up to centralize data in one lake, removing silos and redundant copies. And it makes use of the open Delta format, which allows data engineers, scientists, and analysts to collaborate seamlessly on the single dataset. Fabric simplifies user experiences by using a web-based interface similar to Microsoft 365 to streamline navigation, access control, and security via unified workspaces. And it also offers centralized governance, monitoring, and a consistent billing model. Organizations with Power BI Premium capabilities can already access Fabric's features, providing a low-cost way to leverage its capabilities with additional licensing. So this integrated approach enables businesses to efficiently convert raw data into actionable insights with a focus on simplicity, collaboration, and scalability. Now, let us have a look at the overview of fundamental concepts. Microsoft Fabric simplifies data management by organizing tools into logical groups called experiences, which are tailored to specific roles such as data engineers and analysts. These experiences improve workflows by providing tools tailored to each user's requirements. And Fabric has three main data storage, which is data warehouse, that is designed specifically for structured data and SQL-based queries. Then, Lakehouse combines data lake flexibility and data warehouse performance. Next, KQL database, a database designed for real-time analytics using the custom query language. Then, a semantic model, whether in Microsoft Fabric or Power BI, is a data representation that allows users to query and understand data without having to understand the underlying complexity. And one notable feature is OneLake, a unified storage layer that automatically saves all tabular data from these stores in the Delta Parquet format. This open standard ensures seamless interoperability across tools, eliminating the need for data imports, exports, or format conversions while allowing for efficient collaboration across experiences. Next, in Microsoft Fabric, users can interact with data using tools and programming languages appropriate to their roles. Like for example, in the data warehouse experience, users can write TSQL scripts, whereas in data engineering and data science, they can use Python, R, or Scala notebooks. And for real-time analytics, KQL is used. Low-code and no-code options are also available, making the platform accessible to the users who do not have the coding experience. Next, the Microsoft Fabric includes 4 powerful computing engines that convert code written in various languages into queries against the underlying Delta Lake tables in one lake. This allows for seamless integration across tools, eliminating the need for data import or export. Data stored in one lake can be accessed directly by any engine, ensuring efficiency and reliability. These compute engines are designed to work with Delta Lake as the native format, ensuring high performance throughout the platform. And then, the platform appeals to both experienced and inexperienced developers by providing a unified interface that allows users to focus on data insights rather than navigation challenges. Microsoft Copilot is also integrated, which improves the experience and supports a wide range of skill levels for faster onboarding and productivity. Now, let us have a look at the components of Microsoft Fabric. Fabric provides a comprehensive suite of analytics experiences that are designed to work together seamlessly, and the platform customizes each of these experiences for a specific persona and task. So first we have the Power BI, which enables you to easily connect to your data sources, visualize and discover what's important, and share it with anyone or everyone you want. This integrated experience enables business owners to quickly and initiatively access all data in Fabric, as well as make better data-driven decisions. Next, the Microsoft Fabric Business Intelligence experience is designed to provide valuable insights to business users. And during this experience, important elements such as reports and semantic models are developed. A Fabric report, like a Power BI report, is a business-facing data visualization used to present insights to stakeholders. When a report is published, it is accompanied by a semantic model that includes the report's backend components, such as tables, relationships, DAX measures, and calculation groups. And this model organizes and manages the data that powers the visualizations. The experience includes a suite of business intelligence tools similar to platforms such as Tableau and Looker, but with some distinct differences in how they function within Fabric. The business intelligence experience is designed for a variety of users, including business users who view reports, as well as more technical roles such as Power BI developers, BI analysts, and data analysts who create and manage reports. And it enables these users to collaborate, visualize, and share data insights throughout the organization. Next component is the Copilot in Power BI. Power BI now includes generative AI, which allows you to create reports automatically by selecting the topic for a report or prompting Copilot for Power BI on a specific topic. And you can use Copilot for Power BI to generate a summary for the newly created report page, as well as synonyms for improved question and answers capabilities. Next, Data Factory. The Data Factory experience in Microsoft Fabric is intended to improve data movement and transformation efficiency. Its primary use case is to import new data into Fabric, whether from external APIs or organizational systems. It is designed to handle enterprise-level workloads and can efficiently handle large amount of data and frequent updates. And the experience includes tools such as data flows and data pipelines. Data flow enables users, including citizen developers, to connect to over 300 data sources and transform the data through a familiar low-code, no-code Power Query interface. Users who have used Power BI or Excel will find this particular initiative. The transformed data can then be saved in Fabric's data storage solutions such as Lakehouse or Data Warehouse. Data pipelines serve as an orchestration tools, automating data processing tasks on a scheduled basis. They can start a notebook run or execute a stored procedure in the data warehouse. These tools have capabilities similar to those of popular platforms like Azure Data Factory and Talent. Data engineers, analytics engineers, and Power BI developers are the primary users of the Data Factory experience as they manage and transform data in Fabric. Next is the real-time analytics. The real-time analytics experience in Microsoft Fabric provides users with tools for handling, managing, and analyzing real-time event data. Event data necessitates a distinct approach and specialized tools. Microsoft Fabric offers a real-time intelligence which allows you to develop analytical solutions for real-time data streams. And in this exercise, you will use Microsoft Fabric's real-time intelligence capabilities to ingest, analyze, and visualize real-time stock market data. You will load real-time data into Microsoft Fabric, query and visualize it, and set up an alert to automate an action based on threshold value in the real-time data stream. In this experience, the available tools are the KQL database, which serve as a repository for streaming datasets, and it is based on the Kustu query language engine, which is also used in Azure Data Explorer for logging and monitoring. Event Streams is a no-code tool that allows users to register, process, and route streaming data to multiple destinations within Fabric. KQL query sets enable users to query data stored in a KQL database using the KQL language. And the next component is the Data Activator. Data Activator in Microsoft Fabric is a no-code tool that automates actions based on dynamic data patterns, allowing business users to monitor data and trigger actions like sending notifications or running scripts. Microsoft Fabric combines several Azure tools offering core features like OneLake to help businesses and data professionals make informed, data-driven decisions with an easy-to-use platform. This set of tools is similar to Azure Data Explorer, but with the addition of event streams and Apache Kafka. Data engineers, IoT engineers, and security engineers typically use this experience, particularly for real-time event logging and security tracking. Next, data engineering. Microsoft Fabric's data engineering experience enables users to create and maintain systems for the collection, storage, processing, and analytics of large data sets. Key elements of this experience include Lakehouse manages both unstructured data, such as files, and structured data like Lakehouse tables. This component enables data conversion and organizations via tools such as notebooks. Notebooks allows users to write and execute scripts in languages like Python, R, and Scala. These notebooks use Apache Spark, a popular big data processing framework. Spark job definitions are intended for advanced users who require greater control over how jobs are processed by the Spark engine. These definitions are usually written in Python or PySpark. These tools provide functionality similar to Azure Data Lake Services, Databricks, and primarily used by data engineers and analytic engineers. Next is the data science. Microsoft Fabric's data science experience includes a full suite of tools to support every stage of the data science process, from data exploration and preparation to modeling, experimentations, and insight delivery via PowerBI reports. Key features of this experience include notebooks are required for data scientists to investigate data, conduct experiments, and develop machine learning models in Python or R. Experiments enable data scientists to track model interactions such as parameters, code versions, and evaluation metrics. These experiments are powered by MLflow, the industry standard for controlling machine learning model training and experimentation. Machine learning model allows for the registration and management of machine learning models during experimentation. This functionality is similar to the tools available in Azure Machine Learning and Databricks notebooks. And the primary users of this experience are data scientists, data engineers who use the tools for model development, fine-tuning, and deployment. Next is the data warehouse. The data warehouse experience in Microsoft Fabric offers a traditional transactional data warehouse solution that includes tables, schemas, views, stored procedures, and more, all of which can be queried with TSQL. It also contains visual scripting and low or no-code options, making it simpler for citizen analysts to work with. And it is built on the Polaris engine, which provides high scalability and distinguishes it from traditional SQL Server. And within the experience, users can use Polaris to build a transactional data warehouse, defining tables, schemas, views, stored procedures, and functions. While TSQL usage is similar to SQL Server or Azure SQL Database, the underlying Polaris engine makes it more comparable to Synapse SQL pools. And it also shares similarities with tools such as Snowflake for users who are familiar with non-Microsoft platforms and Azure Synapse Analytics. This experience is ideal for database administrators, data engineers, data analysts seeking a scalable enterprise-grade solution for managing large data sets. Now, let us conclude. Well, Microsoft Fabric is more than just an analytics platform. It's a game changer for the data-driven era. By unifying data engineering, real-time analytics, AI, and reporting into a seamless ecosystem, it empowers businesses to transform raw data into actionable insights with ease. Whether you are a seasoned data scientist or a business professional, Microsoft Fabric simplifies complexity and opens door to smarter decision making, making it an ultimate tool for the future of analytics. In today's data-driven world, businesses require experts who can transform disparate data into game-changing insights. And that is where the Microsoft Certified Fabric Analytics Engineer Associate steps in. This certification is more than just a badge, it is a ticket to mastering lakehouses, semantic models, and data warehouses on an enterprise scale. And by passing the DP600 exam, you will demonstrate your ability to use Microsoft Fabric for cutting-edge analytics, allowing you to pursue high-demand roles in business intelligence, data engineering, and cloud analytics. And if you're ready to shape the future of data, now is your chance. The Microsoft Certified Fabric Analytics Engineer Associate certification validates expertise in designing, creating, and deploying enterprise-scale data analytics solutions using Microsoft Fabric. Professionals in this role transform data into reusable analytics assets, such as semantic models, data warehouses, and lakehouses. To earn this certification, you must pass the DP600 exam. And now, the question is, who is a certified Microsoft Fabric professional? Well, a certified Microsoft Fabric professional is someone who has demonstrated proficiency with Microsoft Fabric. This is all-in-one data analytics platform combines data engineering, data science, real-time analytics, and business intelligence. Microsoft Fabric is intended to integrate data and AI capabilities from services such as Azure Data Factory, Synapse, and PowerBI. But why become a Microsoft Fabric professional? First, due to its high demand and career growth for Microsoft Fabric professionals in India. So, the adoption of Microsoft Fabric is rapidly growing in India, driving demand for skilled professionals in data engineering, real-time analytics, and AI-powered BI. Companies across industries like IT, BFSI, retail, and healthcare are seeking experts who can implement Fabric's unified data platform for advanced analytics and decision-making. So, let's look at why there is a growing demand for Microsoft Fabric professionals in India. First is the growing adoption of AI and data analytics, where businesses are shifting to Fabric's lakehouse architecture for scalable AI-driven insights. Next is the Power BI and Azure integration. With India's strong Power BI and Azure job market, Fabric skills are natural extensions for career growth. And then is the shortage of skilled talent. Limited Fabric professionals mean higher salaries and better opportunities for early adopters. And the salary for a Microsoft Fabric professionals varies depending on experience, location, and industry. In India, the entry level, which is from 0 to 2 years of experience, earn an average of 10 lakhs per annum, whereas mid-level, from 3 to 5 years of experience, earn an average of 18 lakhs per annum, whereas senior level, 5 plus years of experience, earn an average of 30 plus lakhs per annum. But why is demand for Microsoft Fabric professionals rising in the United States? The United States job market is seeing rapid adoption of Microsoft Fabric as businesses shift to AI-driven analytics and cloud-first data strategies. With Fabric unifying Power BI, Synapse, and Data Factory, companies need skilled professionals to optimize data pipelines, enhance real-time analytics, and drive AI-powered insights. Now, let's look at why there is an increase in demand for Microsoft Fabric professionals in the United States. Due to its enterprise shift to unified data and AI. So, the tech giants, financial institutions, and healthcare firms are migrating to Fabric to streamline data management and AI analytics. AI-powered Copilot and Direct Lake architecture are making Fabric a preferred alternative to Snowflake, Databricks, and AWS Redshift. Next, the rising demand for real-time and big data analytics. Industries like e-commerce, fintech, and logistics requires a real-time data streaming and AI-driven decision-making, powered by Fabric's Costo query language and event streams. Cloud-native adoption in Fortune 500 companies is accelerating the need for Fabric expertise. The salary for a Microsoft Fabric professional varies depending on experience, location, and industry. And in the US, entry level from 0 to 2 years of experience earn an average of $31,727 per annum. And mid-level from 3 to 5 years of experience earn an average salary of $56,341 per annum. Senior level 5+ years of experience earn an average salary of $77,129 per annum. Now let us see what will you learn during the DP 600 exam. So the first section of the Microsoft Fabric certification exam accounts for 10 to 15% of the exam and is dedicated to the planning, implementation and management of data analytics solutions. Its primary objectives are to identify solution requirements, configure security, access control, data gateways and manage workspaces and capacities. Candidates must also understand Azure DevOps version control, which includes configuration options and deployment pipeline functionality. While only a small portion of the exam, these topics are critical for anyone interested in becoming a Fabric Analytics engineer. Next, the core section of the Microsoft Fabric certification exam, making up to 40 to 45% of the test, focuses on the data preparation and serving, a crucial skill for analytics engineers. Here, the candidates must understand lakehouse architecture, including creating tables, managing files, and using TSQL in warehouses. It also covers data integration from external sources, different transformation techniques using TSQL, Spark, and DAX, and performance optimization for queries and jobs. A strong understanding of TSQL and PySpark at an intermediate level is essential, along with the ability to monitor and improve performance for efficient data processing within Microsoft Fabric. Next, the model section accounts for 20 to 25% of the Microsoft Fabric certification exam. While implementing and managing semantics, it discusses storage modes, direct query, import, and direct link, including when and how to use them. Candidates should have a strong understanding of DAX, including DAX Studio and Tabular Editor too. This section also discusses data modeling concepts like star schemas, bridge tables, and managing many-to-many relationships. Furthermore, security is a top priority, necessitating knowledge of row-level security and object-level security, as well as methods for validating and enforcing security settings. Next, the final section of the Microsoft Fabric certification exam, worth 20 to 25%, focuses on exploring and analyzing data. While much of the role of an analytics engineer revolves around data engineering, this section emphasizes the analytics side, which is crucial for providing insights. It covers data analysis using TSQL, including querying lakehouse and data warehouse SQL endpoints. Additionally, candidates need to demonstrate expertise in data profiling and analyzing data via the XMLA endpoint. This section, like the rest of the exam, requires a broad skill set in TSQL, DAX, data modeling, and semantic model management. Alright, now let us go through the DP 600 exam details. The Microsoft Fabric certification exam consists of 40 to 60 questions, with scores ranging from 0 to 1000 and a passing score of 700 out of 1000. The questions are represented in a variety of formats, including multiple choice, case studies, which may contain multiple questions about the same scenario, drag and drop, and ordering list. It is recommended that you explore Microsoft Learn resources and practice with the exam sandbox to become familiar with these question types. The exam lasts 100 minutes but allows 120 minutes for preparation and setup. The exam can be taken online or in person at a test center. And the exam cost 4,865 rupees in India and $165 in the United States, with variations in other countries. The exam is available in the following languages: English, Japanese, Chinese, German, French, Spanish, and Portuguese. Now, let us see how to renew the DP 600 certification. So, are you aware that Microsoft role-based and specialty certifications expire unless they are renewed? So, learn the most recent technology updates for your job role and renew your certification for free by taking an online assessment on Microsoft Learn. So, if you have this certification and it will expire within the next 6 months, you can renew it. Passing the renewal assignments demonstrates that you have kept up with the most recent updates. You can also prepare for renewal by reviewing the curated collections of learning modules. This is a collection of learning modules designed to help you prepare for the Microsoft Certified Fabric Analytics Engineer Associate Renewal Assessment. First, administer Microsoft Fabric, use data factory pipelines in Microsoft Fabric, ingest data with data flows Gen 2 in Microsoft Fabric, then get started with real-time intelligence in Microsoft Fabric. Choose a Power BI model framework and optimize a model for performance in Power BI. Now let us have a look at the career benefits of becoming a Microsoft Fabric professional. So becoming a Microsoft Fabric professional put you at the forefront of data analytics and AI-driven business intelligence, making you highly sought after in industries like healthcare, finance, and retail. As organizations adapt lakehouse architecture and integrated data solutions, professionals skilled in Microsoft Fabric are in high demand. Certifications can lead to a higher paying roles, leadership opportunities, and career advancements in AI and data science, enhancing your employability in tech industry. So, who should pursue the Microsoft Certified Fabric Analytics Engineer Associate? Well, the Microsoft Certified Fabric Analytics Engineer Associate certification is suitable for data analysts and BI professionals, like those looking to enhance their skills in data modeling, visualizations, and analytics using Microsoft Fabric. Also, data engineers, professionals responsible for transforming, integrating, and optimizing data for analytics and reporting. Then, the business intelligence developers, individuals working with PowerBI, semantic models, and enterprise-scale reporting solutions. Also, IT and cloud professionals, those seeking expertise in cloud-based data analytics, governance, and security. So this certification is ideal for anyone aiming to advance their career in data analytics and gain expertise in Microsoft Fabric's integrated analytics ecosystem. And many companies in various industries are actively looking for data analytics, business intelligence, data engineering, and IT cloud professionals. Some notable examples include Amazon, Netflix, Microsoft, Google, IBM, and Oracle. So earning the Microsoft Certified Fabric Analytics Engineer Associate certification sets you apart as a leader in data analytics and AI-driven BI. By passing the DP600 exam, you gain the skills to build powerful enterprise-level analytics solutions, unlocking career opportunities with top tech firms and high-paying roles in the ever-evolving world of data. Power BI and Microsoft Fabric are powerful tools for working with data, but they serve different purposes. Power BI focuses on data visualization and creating interactive dashboards and reports, while Microsoft Fabric offers a more comprehensive platform for managing, analyzing, and integrating data across multiple sources with support for advanced analytics and AI. Together, they provide a seamless way to turn raw data into actionable insights. As you can see, I have included a use case of Accenture and Avanade, which has used Microsoft Fabric in their organization. On November 15, 2023, Accenture and Avanade launched Microsoft Fabric-based solutions to accelerate data readiness and AI adoption, supported by 4,000 certified professionals. So let me explain the challenges that Accenture faced before using Microsoft Fabric. So here are the challenges faced, such as fragmented data systems. Well, many organizations manage data in silos, which caused inefficiency and made it difficult to achieve a unified view for decision making. The next challenge is scalability issues. Legacy systems were incapable of scaling up to meet modern workloads, particularly advanced analytics or AI. Then, operationalizing AI. Implementing AI was difficult due to insufficient data infrastructure and a lack of integrated tools, which delayed value realization. Next, data readiness. Preparing data for AI and analytics took time because of inconsistency in data sources and formats. Now that you know what challenges Accenture faced, so let's examine which tools were used before using Microsoft Fabric. So here are the tools and practices before Microsoft Fabric. Data was managed using isolated, traditional tools such as relational databases, ETL processes, and standalone BI platforms. Analytics frequently relied on ad hoc pipelines that were error-prone and unscalable. Then, insufficient alignment between data and operational systems slowed AI adoption. Now, let's explore how Accenture determined that Microsoft Fabric was the right tool for the job. First, it's because of its unified platform. Microsoft Fabric integrates data systems into a single scalable solution. And then, for its flexibility and scalability, where it handles modern workloads and AI requirements better than legacy tools. Next, cloud-native solutions. Microsoft Fabric supports rapid AI deployment and data readiness. Next, for its industry-specific accelerators. Tailored solutions for specific sectors to speed up implementation. Then, for its natural language AI support. that offers advanced AI capabilities that other tools lack, making it ideal for modernization. Well, Fabric is the best option for modernizing data systems due to its strong integration capabilities and advanced natural language AI support, offering seamless data management and insights. So let's see the solutions they came up with Microsoft Fabric. So here are the solutions using Microsoft Fabric and Copilot. Microsoft Fabric is a unified platform that integrates various data-related services, making it easier for organizations to manage data readiness and analytics. Copilot, an AI assistant, allows users to interact with data and extract insights through natural language. The following key features were implemented, such as unified data management. Fabric integrates data lakes, warehouses, and analytics into a single architecture to reduce silos. Next, scalable analytics. Fabric's cloud-native design allows organizations to scale as needed without reconfiguring tools. Next, generative AI. Integrating with Microsoft Copilot accelerates AI adoption by enabling natural language interaction with data. Next comes the industry-specific accelerators. Accenture offered pre-built solutions tailored to industries like healthcare, retail, and manufacturing. Finally, we will see the outcomes of Accenture using Microsoft Fabric. So here are the outcomes, such as improved data access and real-time analytics. Next, AI-powered solutions can be deployed more quickly, and also increased operational efficiency and insight across industries. It also helped organizations transition from fragmented processes to a streamlined AI-ready infrastructure. And finally, this collaboration enabled businesses to maximize the value of their data, boosting innovation and competitiveness. So I hope you now have a clear understanding of how Microsoft Fabric was used and how it helped Accenture overcome the challenges. So if you want to know more about the Power BI use case, please check out the Power BI tutorial by Edureka. Next, we will see why is Microsoft Power BI and Microsoft Fabric used. Well, Microsoft Power BI excels at creating interactive dashboards and real-time analytics, making complex data accessible and actionable to users. It improves decision-making by simplifying data visualization and interacting with various data sources. Microsoft Fabric, on the other hand, combines data integration, processing, and analytics on a scalable platform. It addresses fragmented data systems and promotes AI adoption through features such as Copilot for generative AI. And together, they provide a robust solution for businesses to manage, analyze, and visualize data efficiently. Now, let us see what is Microsoft Power BI and Microsoft Fabric. Microsoft Power BI, which is Power Business Intelligence, is a popular tool for data visualization and reporting. It converts raw data from various sources into appealing dashboards and reports which can be distributed to your team and embedded in apps or websites. Microsoft Fabric is an AI-powered cloud-based SaaS platform that combines comprehensive analytical capabilities for all data needs. Fabric is a relatively new and one of Microsoft's largest data product launches. Its goal is to provide a modern data architecture based on the principles of connectivity, scalability, and an integrated ecosystem. Now, we will take a look at how businesses leverage these tools for actionable insights. Alright, in this Microsoft Fabric, we begin by connecting to various data sources such as databases and data lakes using Fabric's seamless integration capabilities. So we then perform data transformation and cleaning using its powerful data engineering tools, ensuring that the data is ready for analysis. Next, we use Fabric's advanced analytics and machine learning features to derive insights and create interactive visualizations. With built-in natural language AI support, we can query data using simple text, making it accessible to all users. And finally, we deploy and share the result within the organization, benefiting from Fabric's centralized data management and collaborative features. And this process highlights how Microsoft Fabric modernizes data workflows with its end-to-end platform. In this Power BI, we start by importing data from sources like Excel or SQL into Power BI. Then, we create data models by establishing relationships between tables, followed by designing interactive visuals such as charts, tables, and slicers. So using DAX, we add custom calculations to enhance the analysis. After previewing and refining the report, we publish it to PowerBI service for sharing and collaboration. Finally, we can set up dashboards to consolidate key insights for easy access by stakeholders. This process showcases PowerBI's power in transforming raw data into actionable insights. I hope this is clear to you. Now, let's see how to migrate from Power BI to Fabric. So if you have already used Power BI, you now have access to Fabric with all its additional workloads and capabilities. There is nothing you need to move from Power BI to Fabric. Your Power BI content is fully accessible in Fabric. Your workspaces are still there. Your reports are still in your workspace and the user interface for Power BI remains unchanged. The same capabilities are present. So use Power BI in Fabric in the same way you did as a standalone service. Having explored Fabric, the Fabric Azure service users should be familiar with it. Azure services such as Azure Data Factory and Azure Data Explorer were integrated into the Fabric SaaS platform. Now, let us understand the key differences to choose the right platform. Although Power BI and Microsoft Fabric share the goal of providing organizations with data analytics capabilities, they differ dramatically in terms of functionality, audience, and purpose. So let's look at the fundamental distinctions between Microsoft Fabric and Power BI. So here are the differences between Power BI and Fabric. In terms of ease of use, Power BI is easier to use due to its intuitive and user-friendly interface, particularly when compared to Microsoft Fabric. Whereas Microsoft Fabric combines a suite of tools and solutions such as Power BI, Azure Data Factory, and others in a single environment, making it difficult to use each tool simultaneously. To properly size the Microsoft Fabric investment, your team must receive training, plan ahead of time, and understand each tool. However, it is best to consult with expert Power BI professionals to navigate Power BI's complexity, understand its capabilities, create visually appealing dashboards, and maximize Power BI's potential for improved decision making. Now, in terms of capabilities, Power BI enables you to connect different data sources, generate visually appealing and interactive reports, and also collaborate and share Power BI dashboards and reports among teams. Whereas Microsoft Fabric enables you to integrate, process, and interpret data in real time. Also, build, train, and deploy machine learning models, along with automate data activities and transformations. You can also visualize data using Power BI reports and dashboards. Next, moving on to security. Power BI walks in with security and governance features such as row-level security, role-based access control, auditing and monitoring capabilities, data classification and sensitivity labels. Data governance features like dataset certifications, data lineage, and impact analysis are also needed for enhanced data governance. Microsoft Fabric walks in with various security, governance, and compliance features such as conditional access, regional resiliency, logbox, and so on. And data governance features like data protection to discover, classify, and protect data with sensitivity labels. And it's worth noting that both tools offer uncompromising data security measures. Next, in terms of audience, Power BI is aimed at business leaders, managers, data scientists, analysts, and decision makers for various industries who need to create engaging visualizations and collaborate with others. On the other hand, Microsoft Fabric addresses everything from data management to data science, real-time analytics, machine learning, and business intelligence. Thus, it is aimed at data analysts and scientists, decision makers, business leaders, and IT professionals from various industries. Unlike Microsoft Fabric, Power BI's target audience include ground-level workers who require in-depth insights. Now, let us have a look at the use cases. So you can use Power BI for machine learning integration, data analysis and visualization, interactive dashboards, business reporting, and data forecasting. On the other hand, you can use Microsoft Fabric for data science, data engineering, big data processing, real-time data analytics and machine learning, and finally, data integration and end-to-end management. Next, we have integration capabilities. Microsoft Power BI excels in connecting to various data sources offering built-in connectors for databases, cloud services, and live data streams, ensuring seamless data visualization and reporting. Microsoft Fabric, however, provides a unified platform for integrating data engineering, warehousing, and analytics. It enhances integration by combining data preparation, real-time processing, and AI capabilities into one ecosystem, ensuring efficient workflows for complex data environments. While Power BI focuses on insights and visualization, Fabric powers end-to-end data management and analytics integration. Now, we will compare the components of Power BI and Microsoft Fabric for better clarity. So first, talking about Power BI components, Power BI's ecosystem in comparison to Fabric is limited. So some of the key elements include Power BI Desktop, where a desktop application for creating and publishing reports and dashboards. Next, Power BI Mobile, apps for iOS, Android, and Windows devices for reviewing and interacting with reports and dashboards. Next, Power BI Websites. It is a platform that allows users to create, publish, and share interactive reports and dashboards. The website provides a seamless experience for both content creators and consumers, ensuring that insights are easily accessible and actionable. Next, the Power BI service is a cloud-based platform that allows users to consume and interact with reports and visual elements from their browsers. It provides features for creating, sharing, and consuming business insights, including the ability to publish reports from the Power BI desktop and create new reports directly in the service. Next is the Power Query. It is a data transformation tool that allows users to connect to various data sources, shape and transform the data to meet their needs, and then load it into a worksheet or data model for analysis and reporting. Next, we have Microsoft Fabric. It offers a broad range of analytics experiences designed to work together flawlessly, where each experience is tailored to a specific persona and a specific task. The Fabric includes industry-leading experiences in the following categories for end-to-end analytical need. One lake in Microsoft Fabric is a unified data lake that serves as a central repository for all data within the Fabric ecosystem. It simplifies data management by consolidating data from various sources into a single accessible location, supporting advanced analytics, data engineering, and machine learning workflows. Next, Power BI. Power BI is the best business intelligence platform. It ensures that business owners can access all the data in Fabric quickly and possibly make better decisions with data. Then, Data Factory. Azure Data Factory combines the simplicity of Power Query with the scale and power of Azure Data Factory. We can use more than 200 native connectors to connect to data sources on premises and in the cloud. Next, we have Data Engineering. Data engineering experience provides a world-class Spark platform with great authoring experience, enabling data engineers to perform large-scale data transformation and democratize data through Lakehouse. Microsoft Fabric Spark's integration with Data Factory, enabling notebooks and Spark jobs to be scheduled or orchestrated. Next, Data Warehouse. Data Warehouse experience provides industry-leading SQL performance and scale. It fully separates compute from storage, enabling independent scaling of both components. Additionally, it natively stores data in the open Delta Lake format. Next, we have Data Science. Data Science experience enable you to build, deploy, and operationalize machine learning models smoothly within your Fabric experience. It integrates with Azure Machine Learning to provide built-in experiment tracking and model registry. Moving on, real-time analytics. Observational data, which is collected from various sources such as apps, IoT devices, human interactions, and many more. It's currently the fastest growing data category. This data is often semi-structured in formats like JSON or text. It comes at high volume with shifting schemas. This characteristics makes it hard for traditional data warehousing platforms to work with. Real-time analytics is best-in-class engine for observational data analytics. Finally, we have Data Activator. In Microsoft Fabric, it is an advanced feature that enables real-time, event-driven analytics by monitoring data for specific conditions and triggering actions when those conditions are met. It integrates seamlessly with Microsoft Fabric's data ecosystem, allowing businesses to automate workflows and respond dynamically to critical events. This tool enhances decision-making by connecting insights to actions in real time.
Starting off with data visualization. Tableau is well known for its ability to visualize data. Users can create interactive and customized dashboards that are device agnostic. In Power BI, on the other hand, have a large number of data points to offer data visualization. Its simple drag and drop functionality is a deal for both technical and non-technical users. Next is the products. Tableau and Power BI both have released new data analytics and business intelligence products. Here are the various types of products which are used in Tableau and Power BI. First is the Tableau Serve. Next, Tableau Public, Tableau Online Cloud, Tableau Reader, and finally, Tableau Mobile. Power BI is a part of Microsoft Business Intelligence. It offers a wide range of products which are Power BI Desktop, Power BI Services, Power BI Pro, Power BI Premium, and finally, Power BI Mobile. Next is the security. Tableau comes with the following predefined user roles: viewer, interactor, and editor. The publisher can configure access permission for these roles. Tableau offers data security, network security, and RLS option for administrator. It recommends SSL and HTTP configuration for network communication between the client and the Tableau service. On the other hand, we have Power BI. Power BI stores and manages data storage security using Azure Blob Storage, Azure SQL databases, and role-level security is also provided for role-based data access. And the final one is the dashboard. Tableau features are comparable to those of Power BI. In comparison of Power BI, however, many of the features are hidden behind the menus. Tableau is well known for its attractive dashboards that are simple to build with drag and drop. On the other hand, Power BI includes modern features that assist in converting raw data into interactive and visually appealing dashboards. It allows users to visualize data insights, even if they have no prior knowledge or experiences. Creating dashboards with Power BI tiles or visible matrices which directly interacts with the reports and data sets. Moving on to data cleaning in Tableau and Power BI. Data cleaning in Tableau entails preparing and shaping raw data so that it can be efficiently analyzed and visualized. Here are some of the common Tableau data cleaning steps. Connecting to data. Connect to your data sources in Tableau using one of the available connectors, which are SQL, Excel, CSV, etc. Handling missing values. Identify and manage missing values. You can filter out or replace missing values within Tableau using data sheets. Removing duplicates. Check for or remove duplicate row if necessary. You can do this in Tableau by using the remove duplicate function. Finally, data type conversion. Ensure that the data type conversion are appropriate for each file. Tableau automatically assures or assigns data types, but you can change them manually if necessary. Data cleaning in Power BI. Power BI is a process of preparing and transforming raw data into a clear and structured format for analysis and visualization. Here are some of the common data cleaning steps used in Power BI. Data loading. Load your raw data into Power BI using the data source connector, which are SQL, MySQL, Excel, CSV, and etc. Handling missing values. Identify and address missing values. You can use Power Query Editor to filter out or replace missing values. Next is the data type conversion. Ensure that data types are appropriate for each columns. You can change data type by using the Power Query Editor. Finally, handling errors. Identify and handle errors in your data. Power BI provides option to replace errors with default values or remove error rows. Now, we will take a look at the parameters of Tableau versus Power BI. Performance. It improves performance while dealing with large amount of data. Source of data. Having access to a large number of services and database sources. Ease of use. Tableau is known for its simple drag and drop interface that allows users to create visualization quickly. Visualization capability. Tableau is well known for its powerful and versatile visualization capability. Tableau is famous for its ability to provide complex and detailed visualization. Finally, data preparation. Tableau has data preparation feature, but it is less advanced than the Power BI's Power Query. A separate tool, Tableau Prep, is available for advanced data preparation. Next is the parameters of Power BI. Performance. It can handle only limited amount of data. Source of data. It can handle only limited sources to access databases. Ease of use. Power BI is well known for its user-friendly interface, particularly for those who are more familiar with Microsoft products. Visualization capability. Power BI provides a wide range of visualization options, as well as the ability for the user to create custom visuals. It focuses heavily on interactive and dynamic dashboards. Finally, data preparation. Power Query provides robust self-service data preparation capability, allowing users to clear and transfer data into the Power BI interface. Now, we will move on to the use cases of Tableau versus Power BI. Here are some of the common Tableau use cases from various industries. Business dashboards. Create interactive and dynamic dashboards that display key outcomes. Track performance against target by monitoring real-time data. Data exploration and analysis. Quickly explore and analyze large sets of data to discover trends and patterns, and how analysis is used to answer specific business questions. Financial analysis. Create visual representation of financial data, such as revenue, expenses, and profitability, by using interactive dashboards and performing financial modeling. Finally, operational analytics. Visualize key functional matrices to monitor and maximize operational process, identify errors, and process improvement opportunities. Next is the use cases of Power BI. Data exploration and analysis. Discover insights and trends by exploring and analyzing large data sets. Perform independent analysis with Power BI user-friendly interface for quick decision making. Inventory and supply chain management. Visualize and analyze supply chain data to improve inventory management. Monitor supplier performance and maximizing the supply chain to reduce cost. Project administration. Monitor project status, resources allocation, and team performance. Create a visual representation of the project timelines and achievements. Finally, data monitoring in real time. To monitor and visualize real-time data, use Power BI streaming capability. It deals with the requirements which are immediately made as insights, such as manufacturing or IoT applications. Now, we will discuss about which should you choose. Both Power BI and Tableau performs well in business intelligence and data visualization, making it difficult to say which is superior. The only conclusion that is relatively easy to draw is that Tableau is more robust than Power BI, whereas Power BI is easy to get started with and it is more affordable. Learning both can be a best option, and the salary for Tableau and Power BI may differ in India and in United States. In India, the salary for Power BI is 5 lakhs to 9 lakhs per annum, whereas in United States it ranges from $117,000. And Power BI salary in India is 5 lakhs to 8 lakhs per annum, and in United States it is $110,000. If you still need to choose which tool is best for you, then try both of them and find out which is perfect for you.
Picture yourself in the interview, confidently answering every question and impressing your potential employer. Let's dive into the most common Power BI interview questions and how to answer them effectively. Now let's move on to the first question. What is Power BI? Microsoft developed Power BI, a business analytics tool that transforms multiple unrelated data sources into valuable and interactive insights. It allows users to connect to various data sources, transform and manipulate data, create interactive reports and dashboards, and also share insights with others. Organizations use Power BI extensively to analyze data and to make data-driven decisions. Now let's see the second question. Why should we use Power BI? Because Power BI makes it simple for everyone, including non-technical people, to connect, change, and visualize raw business data from various sources. transforming it into valuable data that enables them to make informed business decisions. Moving on to the third question. What is the difference between Power BI and Tableau? Some key differences between Power BI and Tableau are: Power BI uses DAX for calculating measures, but Tableau uses MDX for measures and dimensions. Then, Power BI is qualified only to handle a limited amount of data. Tableau is capable of handling large volumes of data. Power BI is suitable for both experts and beginners as well, but Tableau is best suitable for experts. Power BI user interface is comparatively simpler, but Tableau user interface is complicated. Lastly, Power BI finds it difficult as its capacity to handle large volumes of data is limited, whereas in Tableau, it's capable of supporting the cloud with ease. Now let's see the fourth question. Power BI can connect to which data sources? The data sources is the point from which the data has been retrieved. It can be anything like files in various formats: .xlsx, .csv, .pbix, .xml, .txt, etc. And the databases are SQL database, SQL data warehouse, Spark on Azure HD Insight, or form content packets like Google Analytics or Twilio. Moving on to our fifth question. What is Power BI Desktop? Power BI Desktop enables users to easily connect to, transform, and visualize their data. Power BI Desktop allows users to create visuals and collections of visuals that can then be shared as reports with colleagues or clients within your organization. The sixth question is, what are the available views? First, we have the report view. The report view displays the tables in an interactive format to simplify data analysis. You can create n number of reports, provide visualizations, merge them, or apply any such functionality. Then comes the table view. The table view in Power BI displays data in rows and columns, allowing sorting, filtering, conditional formatting, and also detailed analysis. In model view, users can manage relationships between complex datasets. DAX in Power BI is a query language used for custom calculations. It also creates measures, calculated columns, and supports time-based functions, allowing dynamic data analysis and transformations. Let's see the seventh question. What is a Power Pivot? Power Pivot enables you to import millions of rows from heterogeneous sources of data into a single Excel sheet. It lets you create relationships between the various tables, create columns, calculate using formulas, and also create pivot charts and pivot tables. Let's see the eighth question. What is Power Query? Power Query is a business intelligence tool designed by Microsoft for Excel. Power Query allows you to import data from various data sources and will enable you to clean, transform, and reshape your data as per the requirements. Power Query allows you to write your query once and then run it with a simple refresh. Now let's see the ninth question. What is DAX? DAX stands for Data Analysis Expressions. It's a collection of functions, operators, and constants used in formulas to calculate and return values. In other words, it helps you to create new info from data you already have. Now we are up to the last question for the basic level. The 10th question is, what are some advantages of Power BI? Some of the benefits by using Power BI are, it facilitates the creation of interactive data visualization in data centers. It enables users to convert data into visuals and share them with others. It connects Excel queries and dashboards for faster analysis. Lastly, it offers quick and accurate solutions. I hope you have an idea of the basic level questions asked in the Power BI interview. Now, let's move on to the intermediate level questions. So the 11th question here is, explain the difference between a measure and a calculated column. In Power BI, measures and calculated columns both use DAX but serve different purposes. Now let's see about calculated column. A calculated column is a static column added to a table with values calculated row by row during data load or refresh. It's useful for creating additional fields within a dataset, like characterizing data or performing row-level calculations. Now let's see measure. A measure is a dynamic calculation performed on data in real time, often based on filters or user interactions in the report. It calculates the results only when needed, optimizing performance. Measures are typically used for aggregations like sums, averages, or ratios. Now let me tell you the difference between measure and a calculated column. So, we have opened the Power BI desktop homepage here. So towards the right hand side, you can see the data that I've already loaded. So this is the file of data that I've already loaded. So on the left hand side, you can see table view. Let's click on it. So these are the columns and the values below it. Now let's create a new column. For that, click on new column. Here you can see that my column is created. Now let's change the name for the column as calculated column. Now let's calculate the sum for the quantity. Let's click commit. Now you can see that I have created the calculated column by summing up the quantity. Now let me show you how to create a measure. So click on new measure. Now let me give a title for the measure. So I will be giving it as calculated measure. So let's sum the sales amount and click on commit. As you can see that the calculated measure column is not visible, let's go to the report view on the left hand side. Here under data, we can see that the calculated column and the calculated measure column is created here. Now let's create a graph. Let's select a clustered column chart and give the values for it. Let's drag and drop for the title for the graph, that is the product name. Let's drag and drop the calculated column. Similarly, let's also drag and drop the calculated measure. Now you can see that the graph is created for the calculated column and the calculated measure. So this is the difference between the measure and the calculated column. Moving on to the next question. What is a dashboard? A dashboard is like a single page canvas on which you have various elements to create and visualize reports created by analyzing data. It provides a quick overview of relevant information, allowing users to monitor performance, track progress, and make data-driven decisions at a glance. Dashboards can integrate data from various sources and are often customizable to meet specific business needs. Let's see the 13th question. What are the building blocks of Power BI? The major building blocks of Power BI are: first, we have the data sets. A data set is a collection of data gathered from various sources like SQL Server, Azure, text, Oracle, XML, JSON, and many more. With the Get Data feature in Power BI, we can easily fetch data from any data source. Then we have the visualization. Visualization is the visual aesthetic representation of data in the form of maps, charts, and tables. Reports. Reports are a structured representation of data sets that consist of multiple pages. Reports help to extract important information and insights from data sets to make major business decisions. Last, we have the dashboard. A dashboard is a single-page representation of reports made of various data sets. Each element is termed a tile. What are various Power BI versions? First is the Power BI Desktop, a free interactive tool that connects multiple data sources, transforms data, and creates visualized reports. Next, we have the Power BI Premium. A premium version is used for larger organizations with a dedicated storage capacity for each user. With Premium, data sets up to 50 GB storage capacity can be hosted along with 100 TB storage on the cloud as a whole. Next, we have the Power BI Pro. With the Pro version, you get full access to Power BI Dashboard, creation of reports, along with unlimited sharing and viewing of reports. Let's move to the next question. What do you mean by content pack? A content pack in Power BI is a collection of pre-built, ready-to-use data connections, reports and dashboards created by Microsoft or third-party providers. This allows users to quickly connect to specific data sources and gain insights without building reports from scratch. Content packs are commonly used for popular services like Google Analytics, Salesforce, and Microsoft Dynamics. Let's move to the 16th question. Name some commonly used tasks in Query Editor. Connect to data, shape and combine data, group rows, pivot columns, create custom columns. Last is the query formulas. Let's see the 17th question as well. What are the different Power BI formats? The following are the various formats available in Power BI. First is the Power BI Desktop. You can download and install Power BI Desktop with the help of templates. You can connect it to data source, manipulate the data, and then analyze and visualize it. Then we have the Power BI Services. Power BI Services is a cloud-based or service as a platform. Last we have is the Power BI mobile app. The Power BI mobile app is accessible on iOS, Android and Windows devices. Moving on to the 18th question. What are filters in Power BI? The term filter is self-explanatory. Filters are mathematical and logical conditions applied to data to filter out essential information in rows and columns. The following are the variety of filters available in Power BI. First, we have the manual filters, then auto filters, include and exclude filters. We also have drill down filters, cross drill filters, and drill through filters. Let's see the 19th question. Where is data stored in Power BI? Primarily, Power BI has two sources to store data. Azure Blob Storage, where users upload the data, it gets stored here. Azure SQL Database. All the metadata and system artifacts are stored here. They are stored as either fact tables or dimensional tables. Now let's move to the last question of the intermediate level. What do you mean by group? In Power BI and data processing in general, group by is an operation that allows you to summarize data by grouping rows based on one or more columns. This is often used to calculate aggregated values like sum, average, count, or maximum minimum values for each group. Now let me show you how to group. So for that, let's go to Transform Data, click on Transform Data. Here we have the Power Query Editor opening. On the top you can see Group By, just click on Group By. You can see the Group By window opening on the screen. We have two, that is Basic and Advanced. So first let's do the Basic. So let's add the column. I'll be adding it as Product ID itself. Let's give the name for the column as Text. Let's perform the operation as Average. So let's choose the operation column. So that will be Quantity. Now let's perform the same for Advanced. In Advanced, we have an option for adding the columns for grouping. So first, as we have given it as Product ID itself. Second, I will be giving it as Sales Amount. Let's keep the column name same itself. And the operation is also same. And even the column name. So now let's click on OK to see the performance. So now here we can see that we have grouped the Product ID and the Sales Amount. So this is the average of the Product ID and the Sales Amount given in this column Text. Now let's move on to the advanced questions. Let's see the 21st question. What are some common mistakes that lead to slow report load times? And how do you avoid them? Some common mistakes that lead to slow Power BI report load times include: first, we have the overloading with unnecessary data. Importing large data sets with unnecessary columns or rows slows down the report performance. To avoid this, use Power Query to filter out irrelevant data or only load what's necessary for your analysis. Next we have is the inefficient DAX calculation. Complex or poorly optimized DAX formulas like nested if statements or heavy reliance on measures can slow down performance. Last is the excessive visuals and interactions. Adding too many visuals, particularly complex ones, that is maps, line charts with large data points, can increase load time. Simplify reports by reducing the number of visuals per page. Minimizing the cross-filtering. By focusing on efficient data loading, optimizing DAX and minimizing visual complexity, you can significantly improve report load times and create a more responsive Power BI experience. Let's see the 22nd question. What are the various types of users who can use Power BI? First are the business users. Business users are those who constantly monitor reports in order to make critical business decisions based on insights. Then is the business analysts, who are responsible for creating dashboards, reports and visual representations of data in order to properly study the data set. Data analysis requires an analytical eye to detect important trends in reports. Developers are involved in the creation of custom visuals for Power BI, as well as the integration of Power BI with other applications. Professionals use Power BI to access the scalability, security, and availability of data. Moving on to the 23rd question. What do we understand by Power BI services? Power BI provides services to its cloud-based business analytics. With these services, you can view and share reports through the Power BI website. Power BI is a web-based service for sharing reports. Power BI service can be best referred to as powerbi.com, Power BI Workspace, Power BI Site, or Power BI Portal. Moving on to the 24th question. What are the types of visualizations in Power BI? Visualizations is a graphical representation of data. We can use visuals to create reports and dashboards. The kinds of visualizations available in Power BI are bar charts, column charts, line chart, area chart, stacked area chart, and so on. Let's see the 25th question. What are KPIs in Power BI? KPIs is abbreviated as Key Performance Indicator. Any professional organization has teams and employees follow the KPI protocols. The organization set up KPIs for all the employees. These KPIs act as their targets. These KPIs are compared to previous performance and analyze the progress. Let's see the 26th question. What is the comprehensive working system of Power BI? Power BI's working system mainly comprises 3 steps. First is the data integration. The first step is to extract and integrate the data from the heterogeneous data sources. After integration, the data is converted into a standard format and stored in a common area called the staging area. Then we have the data processing. Once the data is assembled and integrated, it requires some cleaning up. Raw data is not so useful therefore. A few transformation and cleaning operations are performed on the data to remove redundant values, etc. After the data is transformed, it is stored in data warehouses. Last, we have the data presentation. Now that the data is transformed and cleaned, it is visually represented on the Power BI desktop as reports, dashboards, or scorecards. These reports can be shared through mobile apps or web to various business users. Let's see the 27th question now. What are custom visuals in Power BI? Using Power BI visualizations, you can apply customized visualizations like charts, KPIs, etc. from the rich library of Power BI's custom visuals. It refrains the developers from creating it from scratch using jQuery or JavaScript SDK. Once a custom visual is ready, it is tested thoroughly. Post-testing, they are packed in .pbi viz file format and shared within the organization. Types of visuals available in Power BI are custom visual files, organization files, and marketplace files. Then we have the 28th question. What are the major components of Power BI? First is the Power Query for data mashup and transformation. You can use this to extract data from various databases like SQL Server, MySQL, and many others, and to delete a chunk of data from various sources. And then we have the Power Pivot for tabular data modeling. It is a data modeling engine that uses a functional language called Data Analysis Expression, that is DAX, to perform the calculations. Also creates a relationship between various tables to be viewed as pivot tables. Then is a Power View for reviewing data visualizations. The view provides an interactive display of various data sources to extract metadata for proper data analysis. Power BI Desktop, a companion development tool. Power Desktop is an aggregated tool of Power Query, Power View, and Power Pivot. Create advanced queries, models, and reports using desktop tool. Power BI Mobile for Android, iOS, Windows phones. It gives an interactive display of the dashboards from the site onto these OS effortlessly. Then we have the Power Map, 3D geospatial data visualization. Last is the Power Q&A for natural language Q&A. Now let's see the 29th question. What are the 3 fundamental concepts of DAX? 3 fundamental concepts of DAX are: first is syntax. Syntax refers to the rules that define how the code is structured, including the functions to be used. Syntax errors will result to an error message. Then is functions. Functions refers to instructions performed in a specific sequence to achieve a specific result. Last is the context. There are 2 types of context in formulas: row context and filter context. Row context is applied when a formula uses a function that filters a table to identify a specific row. Filter context is applied when one or more filters are used to obtain a certain value. Here we have the last question for the advanced level. What is a slicer? Slicer is an integral part of a business report generated using Power BI. The functionality of a slicer can be considered similar to that of filter. But unlike a filter, a slicer can display a visual representation of all values, and users will be provided with the option to select from the available values in the slicer's drop-down menu. To hire the best talent, you must ask the right Power BI interview questions. It can be difficult to find the right answer, which is why we have compiled these list of 30 Power BI questions structured by experience level.
And with this, we have come to the end of this full course on Power BI. If you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. we will reply to them at the earliest. Look for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you and happy learning.